name's Sougwen Chung. I'm an artist and researcher and artistic director of Silicet, a studio exploring human and non-human collaboration. So my mother's a programmer and my father's a musician, and I think this has me really interested in this idea of hybridity. In particular, hybridity through art and technology. And through some of these interests, I found myself at the MIT Media Lab building my first collaborative robot. In my practice in art and technology, I'm really engaged in the promises, possibilities, and paranoias manifested by developments in art, technology, and science. I believe these developments are changing what it means to be human, and I'm really driven by curiosity about what that can mean for generations that came before and generations to come. In my practice, I see art and engineering practices as one and the same. Both fields have the potential to uncover something real about the human condition, and I think are grounded in an exploratory process of speculation and discovery. I work with robotics, AI systems, data, and mixed reality as drawing, performance, sculpture, and installation. I'm really inspired by how we think about the idea of a human and of a machine. And I'm really curious about where AI ends and we begin. In the past few decades of technology development, I design what I like to think of as sensory mixes of the future. I've been working on a project called Drawing Operations Unit, Generation 1 to 5, for like the past 8, almost 9 years. Its focus has really been on the potential of human and machine collaboration. In Generation 2, we focused on exploring memory by training a machine learning model on 2 decades of my own drawing data. In Generation 5, designed over the pandemic, I thought about my own meditation practice as a kind of creative catalyst and substrate. I used my own biofeedback recorded through meditation to generate EEG data as drivers for robotic movement in my own painting process. I like to think of it as waves of my mind to lines on a canvas. My most recent work is called Flora Rearing Agricultural Network, FRAN for short, a project exploring human, plant, and machine co-naturality. The work speculates at what I like to think of as an interdependent ecosystem of human, machine, and flora, and explores the linkages between machine and ecology through the development of a networked robotic system stewarding nature. In my practice, I work with and develop a range of technologies. I work with robotics as collaborative partners, machine learning as drivers for painting movements, and EEG to create systems of biofeedback. I'm interested in how research-driven processes, algorithmic systems, and custom computer vision software offer new and speculative human and machine configurations. Using custom and existing research for artistic purposes means extending the possibilities of the research beyond fixing a problem or asking a specific question into a more speculative, playful arena that engages new research prompts, as well as new conditions for philosophical inquiry. The drawing operations work as an intergenerational art and research project evolves conceptually, technically, and philosophically with the growing role of technology in our lives. I like to frame it as a collaboration because it really foregrounds the relational dynamics between human and machine and technology and society. I'm curious about this question of agency within systems and think of the practice and these projects as a microcosm to consider the wider implications of things like technological governance and its entangled relationship to the human subject. It's so hard to make predictions about even 5 years down the road. And I think we've seen how quickly over the past few years life can really change in an instant. But I hope that the field of human and machine collaboration is increasingly understood and grown as a site of invention and of promise, one that extends a diversity of subjects and points of view. I'm really hopeful about this because it means that we're working towards this transformation of the human and machine in our environment. And I think that as an interdisciplinary aim is really powerful.
My name is Loclair and I'm an artist working mostly with digital fabric. My background is arts and technology, so as a dancer I learned about poetry and I learned about narration, and on the other hand I'm a computer scientist and I studied human-computer interaction, which is about how we touch machines, how machines see us, how we see them. My work today is mostly about the encounter, the poetic encounter of man and machine, the friction and the beauty between the digital and the analog realm. So right at the hybrid intersection of those synthetic and those natural sensations, I continuously strive to investigate how do we actually meet our mirror, and how do we actually see ourselves through the lens of a machine. My selected artwork is called Helen. It's an AI-based sculpture. That means its shapes, its forms were defined through a process using deep learning. And to me, it basically discusses intention. So an actual artwork normally is born within the artist and his or her intention to create something. And once this creation then starts building, we can slowly see how this thought starts to manifest in the real world. In the case of Helen, however, its shapes, its lines were determined by a neural network, and it was then shaped through a mechanical robot. So basically it is an object that is now standing in the world that was not thought of by a human, nor created through a natural process like stones at a cliff. It just comes out of nowhere, and to me it also feels like that. It's a dark, cold stone and it's quite beautiful. However, there is something missing, and I think you see it when you're standing right in front of it. There's a certain emptiness, and that emptiness is something that interests me. The artwork Helen is created through a custom algorithm that we invented at the studio Loclair. And it is basically an algorithm that is inspired by deepfake technology. So deepfake technology works like this. It is basically analyzing a certain data set with a certain coherence. For instance, faces of humans. And then is able to think of a completely new face that fits actually and that we expect to be a human. And somehow this algorithm is able to kind of invent it. We applied this technology of deepfake to art history and showed our algorithm 60,000 busts that were made in human history, and then asked the machine, could you create another one that wasn't done before but still fits to the to the style of what, well, humans do and did in the last 2,000-3,000 years. Then it came up with a new sculpture, and that is called Helen.
forever. Welcome, everybody, to day 2 of the 2024 ITU AI for Good Summit. And what an incredible way to start the morning. Thank you to the amazing team of dancers, musicians, and data magicians today for it's an awesome performance. And Pepe, thank you so much for letting us into your world this morning. It's amazing. Now, I know this was more than a performance. It's an experiment as well. You're collecting data. So please tell us a little more.
That's right. This is our 10th data collection. This is a longitudinal study that has taken several months. And we are understanding the creative process in action outside the lab.
And it's amazing. How long does it take to set up something like this?
Well, we were here since 7 in the morning.
7 in the morning. And what were the challenges in getting this to work consistently?
Every time we move to a new venue, we need to adapt the choreography. We need to make sure that the wireless transmission is working. And we need to adapt to the environment.
You need to adapt to the environment. And why would you do something like this? And obviously, the artistic element is a big part.
Right. I mean, this is a great opportunity to understand the social brain, interacting brain. You can think about applications not only in the arts, but mentor, mentee, mother and child.
I see.
At work, at home.
And how heavy are the packs that the dancers have to wear? Because did you see they had a kind of shoulder bag on, and it looked quite strenuous?
Well, by this time, they are very used to that. It's like wearing glasses, but it's about 250 grams.
And what's in there?
Oh, it's a Wi-Fi transmitter that connects their brain activity to the computer. So that's the brain-to-computer link.
So it's a Wi-Fi transmitter, sensor, and a bunch of data. And then the generative AI visuals. What came first, the visuals or the choreography?
The music.
Oh, wow.
And the choreography. We would like to integrate the music, the dance, and the visuals to make it very simple and intuitive to the public. It's very important to engage the public, including children.
Wow, brilliant. Well, Pepe, thank you very much to you and your team for opening AI for Good 2024. Thank you.
My pleasure.
Wow. Well, if you weren't awake before, I expect you are now. And to those of you who were here yesterday, lucky enough to get into the building because it was completely rammed, warm welcome back to you. And those of you arriving for the first time, welcome to you as well. I'm LJ Rich, your host and Starship captain for the rest of today. And I'm just going to do a few housekeeping slides just to make sure nobody's missing out on anything. So as per yesterday, we strongly encourage you to download the Neural Network app. Thousands of you already have, and right now they're enjoying meeting and chatting with AI-enabled conversation matching and a host of other things to play with. So there's a lot of real-time benefits you can get from being here at the summit and using the app. And then beyond, there's a lot of chat functions too. And we are still using the Interprify app even. That's available for simultaneous audio or text translation into 75 languages. And if you can speak 75 languages, then you really should have a job here at the ITU. Okay, what you need to do is simple. Scan the QR code to get started on this. If you simply search for Interprify on the App Store, it will ask you for a code. So you do need to do it this way around. And please note our hashtags for the event. You'll need these for the competition. They are AI for Good and ITU AI Summit. Nice and easy there. And the reason we've got AI for Good is because it started in 2017, way before anyone thought AI was a thing. Apart from you all in this room, you all knew it was, and that's why you're here. Finally, we've got NeuroCreate. Scan the QR code to crowdsource insights from the summit discussions, and you're going to be co-creating a one-of-a-kind artwork. So you can have your say and make an impact in the form of art and words. This has been going incredibly well, so we'd love you to add your thoughts to this. I can see all of you with your phones up in the air. This is brilliant interactivity for a time of just 9:30 in the morning. Brilliant work. Everybody, I would like to thank you very much for being part of today. And it's the perfect time for us to give a very warm early morning welcome to the Director of the Telecommunication Standardization Bureau at the ITU for some wonderful opening and welcome remarks. Please give a nice round of applause for Seizo Onoe-san. Thank you very much.
Good morning, everyone, and very warm welcome to you all. Our discussions at this summit highlight that AI will come to influence almost every aspect of our societies and economies. That's also highly evident in ITU standardization work. We have published over 100 standards on AI, around 120 are under development, and this number always on rise. AI is now key to network orchestration, multimedia coding, and optimizing the energy and cost efficiency of networks and data centers. It's also creating breakthrough in areas from climate action and agriculture to disaster response and healthcare and road safety. That's why ITU is so invested in building bridges between different areas of expertise. These breakthroughs are driven in large part by new connections among AI specialists, AI users, data owners, and experts in domains where AI could contribute decisively to sustainable development. ITU is stimulating these connections with the support of our AI for Good initiative. Our diverse membership, partner UN agencies, and the over 30,000 professionals now part of our AI for Good neural network. And with some of our standards applied as part of our global challenges, they are already helping to build AI capacity around the world. Most of competitors are students from developing countries. We want safe and secure and trustworthy AI that leads to a better life for all. The spirit of collaboration and consensus that powers standardization work to exactly the spirit needed to succeed. Standards represent voluntary commitment to new ways of working together. They provide essential technical foundations for new industries to grow and established industries to keep moving forward. It's a highly collaborative process. Working together on standards, we build mutual trust and understanding. We create the confidence to continue innovating and investing. As new innovation ecosystem emerge around AI, standards will be essential in bringing this ecosystem to global scale. But to achieve this, standards need to be a result of process that is inclusive, transparent, and aligned with our ambition for a better world. ITU offers this assurance together with ISO and IEC. We offer a standardization platform where all participants' voices are heard, and every step forward is determined by consensus decision. And as leading developers of international standards, we are uniquely positioned to guide coordinated action from standards developers and a growing range of stakeholders in standardization. Our cooperation helps to position everyone for success. And that's exactly the aim of this collaboration we announced yesterday, to provide unified frameworks for AI standards development. Standards to verify content authenticity and provenance are one of the top priorities. And today's workshop on AI watermarking will bring everyone together to ensure that we start out on the right foot. AI is changing the world, but we have deep experience to build on. Standards have helped us navigating revolution after revolution. With every breakthrough in science and technology, we have come together to develop the standards required to thrive in new frontiers. That's what our standardization process are built for. All of you, whether in government, industry, academia, or civil society, can drive our standardization work with their contributions and consensus decisions. We need to decide together how AI should factor into our future. This conviction anchors ITU's leadership of AI for good. I thank you for your support.
Seizo Onori-san, please come and stand with me if that's okay whilst we reset the stage. Oh no, please come here. Thank you so much. It's just some brilliant insights. Oh, I think we're going to invite the mayor up as well at the same time. So come. Oh no, we're all good? No, come back up. Why don't we do this at the same time? What we're going to do is invite the mayor of Geneva to come up on stage so that you two can say hello. It feels like the right thing to do, doesn't it? So, so let's do it, ladies and gentlemen, and everybody, distinguished guests. Please join me in inviting the mayor of Geneva, Alfonso Gomez. There we go.
Yeah, just I want to be welcome you. Thank you, thank you.
Thank you very much.
Ladies and gentlemen, as Mayor of Geneva, I have the great pleasure to welcome you most warmly to our city in the second day of the AI, I pronounce well in English, for Good Global Summit. It's really a great honor for the municipal authorities to host such of an important event, bringing together some of the world's leading AI specialists. We are fully aware of the scope, the work being carried out here, and of course we hope that it will be fruitful. Since the public launch of the ChatGPT in November 2022, generative artificial intelligence lies at the heart of every debate. And from that moment on, all kinds of scenarios concerning the impact of AI on our lives were circulating, ranging from the most irrational fears to the wildest hopes. However, a general consensus seems to be emerging. If we use ethically, responsibly, and in a regulated way, if it's put at the service of social good and humanity, AI can have extremely positive repercussions in many areas. This applies, for example, in the case of health, education, and disaster response, but also more generally in relation to the United Nations 70 Sustainable Development Goals. As you well know, almost 10 years after the international community adopted the 2030 agenda, the Sustainable Development Goals are, unfortunately, far from being achieved. Only 50% of them are on track, while many others are slipping backwards. Poverty, hunger, inequality, and discriminations are increasing at an alarming rate in many parts of the world, and particularly in connection to the consequences of the COVID-19 pandemic. At the same time, we are facing a global crisis in terms of climate change and the decline of biodiversity, which is gradually bringing humanity to the brink of collapse. We have little time left to change our paradigm and in order to offer future generations acceptable living conditions in our common earth. While the challenges are immense, how can we ensure that the use of AI benefits humanity? Is this essential question that is at the heart of the All for Good Global Summit, which brings us together today in Geneva and which throughout the year will constitute the largest multilateral platform in the United Nations system for AI. The city of Geneva is following the discussion taking place within this framework with the utmost attention, strongly committed to the use of a responsible, inclusive, and innovative digital technology that serves all populations. It has adopted the excellent guidelines laid down by the Swiss Confederation for the use of AI, and in particular with a view to placing people at the center, ensuring conditions conducive to the development and use of this technology and ensuring security. More generally, International Geneva is heavily involved in discussions around the use of data and the governance of AI. Thanks to its rich network of stakeholders in the field of new technologies. And I believe nowhere else in the world is there such a concentration of cross-disciplinary expertise. I hope that this environment will be beneficial to our work. Ladies and gentlemen, today, in view of the immense challenges we face, the world needs collective actions. It's not too late. We can still succeed if we act now by combining our efforts at all levels. And I have no doubt that this summit will make a valuable contribution to this collective edifice. This is the strength of the multilateralism, of the dialogue. Together, that for sure, together, we can go further. Thank you very much for your attention.
Thank you very much. That was absolutely excellent. Please continue that way. We really appreciate you coming, Mayor. That was fantastic. And next up, we're going to be confronting the digital paradox. That sounds kind of scary, doesn't it? Well, don't worry. We don't have to do it alone. We've got backup. We've got someone helping us in the form of the rather excellent Abdullah Alrashid. Let's hear about what he thinks. Okay, have fun.
All right, good morning. So I lead a busy life like many of you, and a few weeks ago on my birthday, my friends got me a coupon for a free service, a domestic helper service where they send somebody to your house and they assist you in the house. And it was honestly the first time that I was going to try something like that. So I ring up the number, they send a young woman to the house. Her name is Lucy. She comes to the house, and we agree on what she's going to do. She's going to help get some of the tedious tasks that occupy me out of the way. You know, things like, I don't know, doing the laundry, the dishes, cleaning the house, doing these simple things out. And I mean, the idea is, of course, I would be a bit more free to be a bit more social, do the things that really matter, and really just even relax if I need to. And things go out really well. They turn out to be very good. The house is clean. I can host more people and guests. Everything is organized. It's all great. But I don't actually end up going out that much. I just end up slouching on the couch and watching and binge watching Netflix and other things a bit more. But in the end, it's still good, you know, like these tasks that I used to do, I no longer have to do. And then one day, something weird happens. I find out that she knows things that she shouldn't know. So I lost my watch at home, and I go up to Lucy and ask her, have you seen my watch? And she tells me, yeah, it's in your locked jewelry box in your locked room. I know that it's there. Oh, that's weird. I don't remember ever giving her access to that room. And then she leaves her phone on the table, and I snoop, so I touch the screen. Her wallpaper is pictures of my children. That's weird. I, again, don't remember sharing that with her. So I decide to confront Lucy, and I go up to Lucy and I ask, well, I've seen X and I've seen Y on your phone, and I see my children photos. And she said, yeah, well, I have hundreds of them. I have some of them when they were kids showering for the first time, and they're on my phone. But don't worry. I only share these photos with other domestic helpers in our company. They don't go out. They're just between us. This, of course, makes me extremely awkward, so I go to the authorities, and I try to say, well, I think I'm being robbed at home, and my privacy is being invaded. And they tell me, well, we have extreme laws against this, right? Like, if this happens anywhere, it's not acceptable. But no, this domestic helper / cleaning service that you have, that doesn't really fall within our jurisdiction. That's in your private home, what you do there, you need to figure out yourself. We're really sorry. So I'm faced with this really tough choice, and it's not a conscious choice that I have to make. It's a tough choice. I have all of these amazing things that are happening. You know, like I no longer have to do dishes or even order things from the grocery store because she knows what's missing and she orders it for me. But then there are these concerns that I have, and honestly, I decide just to live with it. So now Lucy watches me when I sleep. She monitors my heart rate to make sure that I'm okay. Sometimes in the bathroom, you know, when I'm there, she'll be in the room as well, just, you know, occupying me if I'm bored. I mean, this sounds funny, but that's the absurdity of our lives today and the dystopian choices that we've made. We seem not to be able to, we don't hold tech to the same standards that we hold anything else. And we need these anecdotal, fictional settings to try and shed light on where we are today. And this had like extreme ramifications on us, really. I'm going to pick out a focus on children, just a few examples. Our research shows that 69% of Gen Zers skip sleep at least once a week because of their use of tech. Lack of sleep has been strongly correlated with increased risk of cancer. We flash these devices in front of our children, and 30 minutes of screen time has a 50% chance of speech delay for young children. You know, for me, if you go to a store and you buy a device or a toy, sorry, you'll see an age group restriction on it that says 3+ or 6+ or whatever. But we put these VR headsets, and they have guidance on certain ages that you put in. So a VR headset we advise that it should not be used by people who are 12 years old or younger. And then when you read the reasons are eye strain, neck stress, and none of it is about what a VR headset and being connected to a virtual world does to your brain. Our research shows that 40% of people, particularly Gen Zers, have a completely different personality online than they do offline. And any other time in history, I think that would be like cause for concern for schizophrenia. But not today, not with us. And then, as parents, we look at like the benefits, right? So we outsource parenting. A third of parents use tech devices to occupy their children on a daily basis. I mean, I'm going to throw an example that I think everyone is guilty of, right? You're on a Zoom call, your kid comes up into the room, he's shouting, you throw an iPad in his face. Just let him occupy himself. You're in an airplane, they start shouting or screaming or crying, you're embarrassed, so you turn on the screen. And this stat was particularly around non-governed, like non-parental controlled content, right? So a third of parents are giving their children devices They don't even know what they're watching or they're doing. It's just outsourcing parenting to tech. What does that mean in an AI world? I'll leave that to you guys to figure out. And what does all of that result in? Probably maybe the most alarming statistic from our research that for me, is that 53% of Gen Zers would rather live without a close friend than their phone. Can you imagine, right? And when our researchers meet and do these qualitative interviews, it makes sense. I mean, I love a quote that one of the interviewers said, it's not a cell phone, it's a self-phone. It's me, it's everything, it's all my life. Like, that's where tech is basically reality, and reality is my virtual life. It's where I study, it's where my friends are, it's how I connect, it's how I'm cool, it's how I create social status, it's everything. And so we've given tech this opportunity to dominate and intervene. We're really more comfortable with our kids being performers than they are being social beings. So you see the children across the world happy to go in front of a screen, thousands of people, followers, going and acting and portraying a certain image, and then put them in a room with 3 other kids and they won't be able to interact. This is happening now. This is not a doomsday scenario. This is children today. We even have research on Gen Alpha that we do across the world. Kids who are under 12 years old and how their parents talk about what's happening with them. And I want to give another example on the adult side for us. Humanity has always had this right to forget. And I'm going to share a video of something that maybe a few of you have seen. But a woman tragically lost her child, who was 8 years old at the time. In the past, when something as tragic happens, what we do usually is, as humanity, you know, like we'd consult, console, create support groups, and eventually, slowly, maybe we'll be able to move on. Our reaction today is very different. We allow the woman and the parent to create a full digital construct of her lost child. She puts on a VR headset and is now interacting with a virtually created manifestation of her child, both voice, visual, everything. What happens to humanity when you can't forget? When we lose the right to forget? I think as with all technologies, the premise of this idea is wonderful. It's great. It's amazing benefits. You know, a losing mother being able to connect with her lost child. But have we really studied what the consequences of that are? I cut the video because I was told maybe it's best not to share the entire video. It could be a bit disconcerting, but you can find that online. And our response to that is that the industry will collect itself. You know, like, yeah, okay, fine. We've heard this many times before. Every new technology, every development, there's always this concern, it will correct itself. But I don't recall an industry or a time where people who are working on it are shouting out to be regulated. They're not able to work to instill the change internally, and so they're raising their hands, please save us. I was thinking of an analogy of this, and it's not the right analogy, and I'll mention why, but it's like an alcoholic coming in and really fed up with their lives. And they're coming in for a support group to help them, and our response is like, no, don't worry about it, you'll figure it out. But that example is not really great because the alcoholic is the user. It's actually the brewer coming in and saying, you know what, I don't want to create alcohol anymore, and we're saying, no, don't worry, figure it out, it's okay. And so when we look at the response of the world to this, it seems to be split in half. We see a leniency towards control in the East, where China is pioneering or maybe leading elements of time constraints on technology, age restrictions on technology, even content restrictions on what goes on. And then on the Western side, a more open response. And I'm not here to say which one is right. I don't know which one is right. But the reason why this is a really important conversation now is that we've been doing our research for 3 years now, and the following stat is really the greatest indication that we're at a tipping point. 50% of people say that they'd love to embrace AI, and then 50% say that fear it. We're really at the nexus and the tipping point of this decision. And the time is now to try and be purposeful about our way forward. So I want to talk a bit more about what we do and then maybe conclude with a few ideas going forward. So Ithra and Sync are a nonprofit cultural institution in Saudi. We realize this problem, and you might ask, why would a cultural institution get into this topic of tech and consumption? But really, we're all technologists now. Whether you're a pediatrician, a lawyer, a parent, an artist, whatever, you're a technologist. You're either by usage or creation. And we need to be involved in that conversation. And so we launched this global program a few years ago with many partners, and we try to do 3 things. The first is that we try to do some groundbreaking research in this space, both across the globe, but also on our region. We convene, we hold large gatherings and summits. Last week we had the Digital Wellbeing Summit, 40 countries, 20,000 people came. And then we try to also educate. And the question I got on education is like, what do you educate on? And what are you trying to instill? And I know that the answers are not there, but at least we need to educate on awareness and the conversation. I want to leave you with an example of the kind of things that we produce to try and raise awareness on these topics. This was more on screen time and social media. So again, there might not be clear answers, but I think the problem is very, very clear. I'd say that this is very different to anything else we face because of 3 things. Number 1, it's exponential, and we've heard keynotes yesterday about how exponential it is. 2, it's unforeseeable. We don't know the results of it. And maybe that's true of a lot of technologies, but really the concerns around this are much bigger because of how intertwined it is into our humanity, psyche, psychology, social behavior, even our biology. And then the third is that it's irreversible. I'll leave you with a stat. During COVID, our screen time went up by 2 hours. That's 2 hours more screen time during COVID than we've had in the last 10, 15 years. So when COVID stopped, you'd think that after 15 years of experience or 15 years of practicing something and only a few months of screen exposure, we'd go back to where we are. No, our screen time now is 1 hour above. So although we were able to draw back a little bit, we can't really fully reverse once we embrace this technology. So I want to leave you, everybody here, whether you're a user, a creator, a developer, an enabler, a politician, an advocacy, with this question. The real drive behind this speed race for technology is utility, that it's going to be benefit for humanity, that it's going to make our lives better. And my question is it humanity or utility that should be the priority? I mean, so what if my autonomous car comes in 5 years later? So what if I end up going to the grocery store and shopping on my own rather than my fridge ordering it for the next 3 years? If that improves our chances of mental well-being, of health, even by 5%, that's a bet I'm willing to take. I'm fine. And so for me, it's not humanity or utility, it's humanity over utility. It's not to say that technology is bad. It's just that humanity should supersede and be above that. Thank you.
Thank you very much to Abdullah there. Excellent. It's, what, just about 10 o'clock, and we've already had quite a lot of thought-provoking content about the use of technology with children. I've got a smallish child, he's sort of 7 and a bit, and there's always that conflict between, do we occupy him with technology, or do I have to occupy him with my time? And it's a real balance. And with the 50% fear and 50% embrace, that's a really interesting statistic. I wonder if I'm both of those at the same time. But I'm generally optimistic watching what all of the amazing things that you're doing are achieving. So that's brilliant. Listen, this is a pleasure to keep going with a panel. You may get a clue it's a panel because there are a few chairs being set right there. So it's tempting to presume that large corporate organizations are slow-moving by nature. Actually, not all of them are. There are some incredible innovations taking place all over and some very well-recognized brands. So the next panel is going to talk about how these incredibly large organizations are using AI. And it's always this conundrum, I think. A lot of organizations will fail if they are simply using it to cut costs or drop headcount. Actually, what you can do is improve quality of life and add extra abilities to people who are already working there. This is what I'm a big fan of. But then, how does society work? If you have to pay somebody, instead of paying for someone's time, you might end up paying for their expertise, which is kind of interesting. I think I can see some water bottles coming as well. Does that mean there are tables also? No, they are set. Excellent. Well, we're going to have a fantastic moderator for this panel, and we'll be introducing them shortly, and then they're going to introduce everybody else. And I think after that, we might be going off to a few more panels, then no, we've got a coffee break straight after that. No, we haven't. Oh, we've got a really cool talk straight after this one. It's mind-blowing, lots and lots of thought-provoking things happening. So I recommend that if you do wish to kind of continue right up to the break, I would very much think you would enjoy all of the talks after this one as well. I think we're all set, which is excellent. So let's hear more about AI for good in a corporate environment with our moderator for the next session. Please help me welcome a partner at DLA Piper. It's Danny Tobey.
Thank you, LJ. It is a pleasure to be here with everyone today. My name is Danny Tobey. I am a medical doctor by training and a lawyer, and I've spent my entire career working with companies adopting technology, including AI, and trying to position it to do good. So I'm thrilled to be here today. For those of you who don't know, DLA Piper is a truly global law firm. We are in 90 offices in over 40 countries in the world. So we are very proud of our partnership with the UN and helping work towards the sustainability goals. I'm delighted to introduce our panel to you today. These are some of the top leaders at some of the top companies in the world, truly global companies who are working to adopt this revolutionary new technology, but to do so in a responsible way and to position it for the good of their customers and the world. And I'm delighted to introduce them now. First, please welcome Sooji CEO. Sooji is the Senior Vice President and Chief Privacy Officer of 3M. Hello, Sooji.
Good morning.
Next, please join me in welcoming Rob Beard. Rob is the Chief Legal Officer, General Counsel, and Global Head of Policy Affairs for Mastercard. And last but not least, we have Andrea Abel. Andrea is the Chief Information and Security Officer of the global pharmaceutical company Eli Lilly. Welcome, Andrea. So thank you all for joining us. I'm really excited about this panel because we all know your companies, known around the world, And each of you represents really a different focus within the company. We've got privacy, security, legal, and policy. And then we also have 3 companies working in very different sectors towards very different goals. And so I think we're going to learn a lot hearing about how you at your companies are adopting AI, where you see the promise, and where you're putting safeguards in place. So let me start with Andrea. Andrea, tell us a little bit about how Eli Lilly is adopting AI for good.
Eli Lilly's mission is to create medicines that make people's lives better. And so when you think about AI, we have this tremendous ability to shorten the time it takes to develop medicines across the entire life cycle. It goes from even looking at things like how quickly we're going to be able to get through the research and development to the interactive nature that we may be able to have with healthcare providers and patients. I'll give you 3 quick examples. The first is back to the scientists. If you think about research and development, we get a large data pool that we're trying to identify which molecules will best work for a specific therapy. And today, it takes us weeks, even with machine learning and models that we have. What we've seen is that time compress, where we're now able to identify 10 to 12 molecules that are best worth the scientist's time to research because of AI, and we're measuring that in minutes instead of days and weeks. A second use case is probably more generally applicable to the audience, which is translation. So at Lilly, we have to take all of our clinical documentation, regulatory filings, we have to get it into the native language of those regulators. That can take up to 20 weeks sometimes. And so what we're able to do now is within minutes, get a quick, rough draft in the hands of a human who can then refine and fine-tune and get that submissions to the regulators. And that means we can get our medicines globally to patients a lot faster. And then the last use case that I'm actually most excited about is this idea of interactive ability to educate and help with medical adherence for healthcare providers and patients. And so we're actually going to start all the way back at the clinical trial phase. We have the Magnal AI sensor that's going to allow us to start decentralized trials that will allow a more diverse population with a more robust data set that we can start to use to train models. So then, as you think about educating healthcare providers and patients, we can really bring them along their journey to have a really effective experience. And that's something we're starting with Lilly Direct, and we really see it as being an unparalleled opportunity. Now, at the core of all of these innovations is the idea of digital trust, and that's where cybersecurity comes in. Every use case, we have to ask 2 questions. One is, for all this good, what's the potential harm? And then secondly, for all of those potential harms, what can we do to prevent? That's always our goal, right? Or to monitor, detect, and respond so that we can identify those harmful situations. And if there are not controls, there aren't ways we can do that, that's where we have to have the transparent conversation with the business so that we can really make sure that digital trust is at the forefront of all of these AI use cases.
Thank you, Andrea. Let me turn to you, Rob, next. How is Mastercard looking at AI?
Sure. And well, thanks a lot for inviting me to have this conversation with you, Danny. I really appreciate it. And I was actually, thinking about something I heard as we were walking in, which was really interesting to me, and is something I think about a lot with AI. People are outside this room, maybe people who are less familiar with AI and what it's capable of, tend to be a little bit afraid of what AI could do. And one of the things I thought was really interesting, and I think about all the time, is AI is tremendously powerful in enabling us to have better information to make decisions, to exercise our own judgment, and to understand what information is out there so that we can make better judgments. It's not that we're, and I think people are afraid that the computers are going to make those judgments for us. And I think it's really interesting as we think about the principles that underlie AI, the principles that we're all trying to put in place in terms of the frameworks around the world. We think about how do we set those frameworks so that we're getting better information to help us exercise our judgments, make better decisions, better judgments, not to turn those judgments over to machines making the calls on things. At Mastercard, we're deploying AI, and we've been deploying AI for many years with one real core sole purpose, which is to make transactions safer and more efficient, and to make the user experience better. So the whole core of our activity in this space is looking across billions of transactions. So Mastercard sees about 125 billion transactions this year. As we see those 125 billion transactions, each of those transactions generates data. And it's not, for us, it's not data about the individual or their credit rating or anything personal about them, but it's that transaction activity. And that transaction activity then going into our models can tell us a lot about which transactions are good and which transactions are bad. And that has a lot of potential implications, whether it's starting from very basic things like anti-money laundering, terrorist financing, but all the way down to like, how do we keep our parents from getting ripped off online? And Mastercard's been deploying AI and this technology since about 2019, really in terms of establishing and creating a framework for being able to use information to make our network safer. But it's more than just making our network safer, right? It's anti-fraud, for example, is something that can be done on a very sort of blunt level, right? Many of you have used credit cards in the past, and all of you have probably traveled. As you travel and you use your credit card, you think back 10 years. 10 years ago, if you wanted to leave the country and say you wanted to go to another continent, you had to call your credit card company and say, hey, I'm going to travel, I'm going to be gone for 10 days. Please don't decline these transactions. They're not my usual transactions. Today, with the power of AI and our models, you don't have to call your bank anymore. We have the ability to look over billions of transactions and determine in an instant when you go present your card that that transaction is okay. So it's not just about fraud prevention, but it's also about decreasing the friction in transactions, making those transactions more trustworthy for you and for the counterparty. And then ultimately, it's about introducing two people to each other who've never met each other before and telling them it's okay to transact.
Thank you, Rob. And Sooji, let me turn to you. What's your experience at 3M using AI for good?
Thank you so much, Danny, for the opportunity to share 3M's AI for Good journey. 3M is a material science company, and we believe the advances in AI to design, train, and run at large scale can benefit various industries, and we've just heard from finance and from the pharmaceutical how it could benefit society around the world. In fact, AI is not new at 3M. We have been using it for many years in our manufacturing process. More recently, we have embraced AI as part of our innovation, and a really good example of how 3M and AI come together is our physics-informed machine learning accelerated design AI platform. That's a mouthful, just to say it as fast as I just did. And what it does, it helps our scientists, chemists, and engineers predict at an accelerated pace new possibilities for personal safety or climate technology solution that really empowers modern life. And so at 3M, we are really committed to leveraging AI for good throughout the company to advance human progress and, of course, drive 3M innovation.
Thank you, Sooji. I'll give a perspective. It's amazing to hear about how large companies are rolling out this technology. There are also a number of great startups that are using this technology for good. And I'll just give a shout out. I couldn't name them all, but I'm lucky to work with one called Created by Humans. And their focus is ethically sourced data. So everybody's seen in the newspapers about lawsuits and who owns what. And the idea with Created by Humans is, let's build a technology pipeline and let's build a legal structure so that artists and creators can have an easy platform to license their material to the LLM creators and the AI deployers. And at the same time, and this is the fun part for me as a lawyer, to define a whole new category of content rights that we call AI rights, so that you're not just selling all or nothing, but you can, as an artist, have control over which aspects character, plot, whatever the case may be, and then how those can be used by the models. So there's just a lot of exciting thinking from security to law to privacy on how to deploy these tools. But I do want to turn now, we've heard great talks in the last couple of days about the risks of AI. And on the one hand, you guys have been working with AI for decades. AI is a constantly evolving category. But with all the new generative AI and new powerful tools, how are your companies adopting AI in a trustworthy, responsible, reliable manner? And as a corporation, how do you put up those safeguards? And Sooji, I'll start with you.
No, it's a brilliant question. And as you've heard from Andrea and Rob, AI is being adopted across various industries to drive positive change. However, equally important is strong AI governance and human oversight. And at 3M, we actively promote trustworthy AI by leveraging strong AI governance that prioritize transparency, privacy, ethics, and accountability throughout the development and deployment of AI. Specifically, 3M's multifaceted AI governance measures focuses on three things. Firstly, people. Secondly, process and technology. And I'll just quickly zip through them. For technology, our employees use a secure internal AI platform to advance innovation. For AI governance, we've established an AI Center of Excellence Council consisting of leaders across various organizations, such as legal, IT, cybersecurity, human resources, and our research and development, who oversee how employees adhere to our responsible AI use policy. And for process, pulling through the thread that Andrea just mentioned, we maintain strong data privacy and security protections consistent to 3M's high standard. And in relation to people, it's super important that you share knowledge, you train and upskill your employees so that they can understand and be accountable for using AI responsibly. And if I can just land with this one thought, it's super important with organizations that AI governance and oversight, particularly human oversight, is at every stage of whether you're developing AI or deploying or even a combination. You've got to make sure there's human oversight as well.
Thank you, Sooji. Rob, let's go to you next.
Well, I'll just pick up on the thread because I think maybe start with the human oversight. I think that's a really important part. Is it's responsible AI needs human intervention. Right? We need human checkpoints along the way as we design these things and as we operate them. And it comes back to that principle of AI has a tremendous ability to give us information. And that information can help us make better decisions in all facets of our organization. So I'll give you an example. At Mastercard, we have this really cool thing called Check Your Bias. And I love Check Your Bias because you know, in the world of lending over time, there have been sort of inherent biases people aren't even aware of that sort of creep into their lending decisions, right? We can help people when they think about issuing cards, for example. We can give them information about their previous decisions that they've made and help them understand where are we interacting with people? How does that interaction look like? Where do we have blind spots? Where are we making mistakes? Where are we excluding people? Because for us, we're trying to connect and power an inclusive economy, right? Inclusive digital economy. And the AI has the power to give us more information to help us guide us on that journey and help our customers on that journey. But it's not about, it still involves, it's not about excluding the humans from that process. We still need to be involved. We still have to be there to take and ingest the data and make decisions on it, create the frameworks that help us understand these are the guardrails for the use cases of this particular technology. Here's how we're going to use the data. Here's how we're going to keep it confined to ensure that what we're doing remains safe and secure for people. And I think that's a really important element of strong design in AI today, is that we don't, and I think we need to talk about it in various ways. We're not looking to take humans out of the equation. What we're trying to do is give humans more information to make better decisions about what they do. At Mastercard, that's something that really informs our responsible AI principles. In 2019, as we started using AI more and more and more, we developed a framework for responsible use of this type of technology. And for companies like Mastercard or 3M or others, it's up to us not only to develop the framework to use it responsibly ourselves, but to promote that framework around the world. Before Danny and I were talking before he came on stage, one of my big concerns with AI and governments getting interested in this space is that we're going to end up in a fragmented world where countries around the world will decide this is what AI governance looks like over here, and this is what it looks like over here, and this is what it looks like over here. And the result will be that we won't be able to leverage AI's power in the way that we otherwise would be able to. So it's up to us, it's up to companies who have adopted responsible principles to advance those principles into the world, take those principles out. And so I think that's another way that large companies can use their experience with AI for good, which is to help inform the policy debate and take that policy debate out and reduce fragmentation in the world. Coming around with one standard, maybe particular to certain use cases, so that we're able to deploy AI responsibly and efficiently.
Thank you, Rob. Adria?
Well, you can hear a lot of common themes here going across, but very much like 3M and Mastercard, Eli Lilly's been using machine learning and AI for years. But last year, we really started to recognize the game-changing potential and stood up an AI governance framework. And we started with the principles. So, things that I think you've heard echoed throughout the conference: transparency, fairness, safety, security, oversight, and privacy. And then we established a strategic governance committee where really all of the final decisions, escalated decisions, are made. And we have a risk subcommittee and a technology subcommittee. And then those groups are asking their teams to come up with things like inventories and the design principles, reference architectures. But as you all know, the technology is evolving and the use cases are coming so rapidly that we often don't have time to get a reference architecture out before the use case is ready. So that's where these committees are coming into play. And we pull all of the stakeholders together. So privacy, legal, technology, clinicians, the business, ethics, HR, security are all at the table. And our decisions have varied from, hey, that's not the risk to take right now, to how do we de-scope, or how do we baby step into this to better understand the risk and benefit, to, hey, we need to accelerate this faster. It's a low risk proposition that can really benefit the patients. From a security perspective, it is really all about the transparency about our ability to have controls in place. And very often I find myself having discussions with the business about, I'm not sure this is ready, but can we go pilot it? Can we go de-scope something so we can get smarter and look for opportunities to build controls to make this a really safe experience? And really, I think even if we didn't have these amazing opportunities to bring medicines to patients faster, if you're in the cyber world, you have to be interested, you have to get involved with AI because the threat actors are using AI. And we've seen it. Phishing has gotten way more effective and efficient, better targeting. There are a lot of use cases where we're seeing where threat actors get into an environment, they go out to use a public large language model to refine their code base for that environment so they can exploit it more quickly. So we have to take the knowledge not just of the controls that we're trying for the business, but how we're going to respond to the threat actors and the threat landscapes, bring those together in the discussion, and all of that brings back to that idea of how do we make sure we have the right digital trust in every one of our use cases.
Thank you, Andrea. A couple things I just want to press on because you guys raised them and they're so important. One is, I think it's extraordinary, and I want the audience to just reflect on this for a second. There are no comprehensive AI laws being enforced right now. I mean, Europe has a legislation that will be rolling out. The US is talking about it. Many countries are talking about it. But these are companies taking proactive steps to voluntarily adopt responsible AI. And I think that is a really important lesson. And I'll say, I've had the pleasure of working not just with folks here, but lots of companies, and it's a similar story. People are taking this opportunity and challenge very seriously. The second thing I heard that I loved is human in the loop. And even where things can be automated, companies are asking the question, should they be? And I think we're hearing to a T that this is not a replacement for human judgment. And I love hearing that across industries. And someone even asked me yesterday, is AI going to replace lawyers? And I said, I'm afraid you're stuck with us. So I think humans have an incredibly important role to play as the gatekeepers of this technology. And I really love hearing you say that. The third point I heard is, we're at the UN, and the consistency among what you have been doing is really remarkable, because we have groups like the UN and others who are setting principles and standards, and fairness and trust and non-discrimination, non-bias. But someone has to take those principles and operationalize them. Yep. And you guys are doing that. And sometimes as a lawyer, I feel like middleware, because someone says be fair, and then we've got companies making medicine and finance and material science. They said, okay, well, be fair. What does that mean? And you guys are really doing that. And the multi-stakeholder way you are, every one of you drawing in across disciplines. This is the most horizontal technology in history. And you guys are rising to the challenge by pulling from legal, business, finance, privacy, security. And it does take a village, but you guys are making that happen. So thank you for sharing those insights today. I hope for those companies that aren't thinking about this yet, this really serves as a really good role model to think about. Before we close, one announcement. Since the world is stuck with lawyers, I do want to say DLA Piper is extremely proud of its collaboration with the United Nations. And I want to announce that we are the founding law firm of the United Nations AI for Good law track. And what that means in reality is we're going to be founding a nonprofit called the AI Law and Justice Institute. And we're going to be having lots of companies and thought leaders and academics and civil society organizations joining us to really think about what are the UN sustainability principles and how do we create legal structures of the future that are fair and accessible and just, and how can AI help expand access to justice for everyone in the world, in different countries, different regions. So AI for Good law track, the AI Law and Justice Institute, please keep your eyes open, and if you or your companies or your academies would like to be involved, reach out. It's going to take all of us to get this right. But we very much appreciate you having us here today. And please join me in thanking the panelists for taking time with us. LJ, back to you.
Panelists. That was an absolutely whirlwind tour of the corporate world there, and I'm very sure that all of them will be open to networking of all kinds, within reason, of course, so please do go stop them and have a nice chat with them.
My friend.
Now, we're going from the very real corporate world to something slightly more unreal, and as I work a lot with generative AI when it comes to music, I'm quite fascinated to see what you think of this next presentation that contains a lot of generative imagery, a lot of interesting things, and also I should probably mention that the next presentation contains a few swear words as well, so it won't be suitable for younger viewers unless they obviously know the words already. So please open or close your eyes accordingly as we get going on that one. You may also be interested to know that some of the music that you're hearing in between the sessions in the break areas is AI generated by me. So you may hear the odd yeah, 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 yeah AI song. That one was made over an evening, and it's really fun, and I've now got it stuck in my head. So it's my own fault. I've done this to myself. I can no longer think clearly. That's fine, though. We've got somebody else to talk who is going to be quite a lot more articulate than I am before my 4th cup of coffee. So please help me welcome to the stage the fantastic co-founder and associate professor at Pinscreen. It's Hao Li. Have fun.
All right, thank you so much for the introduction. My name is Hao Li. I'm CEO and co-founder of Pinscreen. I'm also associate professor at the new AI university called the Mohammed bin Zayed University of Artificial Intelligence. Today I'm going to speak about distorting and enhancing realities using generative AI. So 30 years ago, there was one particular movie that actually made a huge impact on my entire career. I'm pretty sure you guys remember T-1000 from Terminator 2, where the first time I would see like a liquid metal morphing into different shapes. Basically, what it was telling me is that CGI, or visual effects, was able to do anything that is possible, right? So things that are not possible in physical realities, we can do it using computer graphics. So a couple of years later, we would actually see a ton of movies that would make heavy use of visual effects, right? So one great example here is Avatar. In Avatar, there were over 3,000 shots that were using visual effects, or CGI, and only 2 shots in the entire movie didn't have any CGI. So what it means is that CGI is a transformative technology that would change storytelling. So you might think that everything is possible now using these kind of technologies, but one thing that we were seeing back then is that human faces were very difficult to achieve, right? So one of the reasons was that we as humans, social animals, are very sensitive to the human likeness, right? So CGI faces were pretty often very creepy, and people would avoid them in movies. So the phenomenon that we're seeing here is what we call the uncanny valley effect, right? So intuitively, you might think that if we add more realism to computer-generated imagery, then you might find it to have more empathy, right? So on one axis, we have realism. On the other axis, we have likability. If you start with something abstract, like Futurama characters or Simpsons characters, and then you go to Pixar characters, you might find them more likable. However, when you get closer to photorealism, one thing that you will see is that because we get more sensitive to it, we might notice everything that appears very bizarre, right? So this is where we have the feeling that something feels like zombies, right? And of course, the ultimate realism is a real picture of someone. So how do we solve this problem? Initially, one of the technologies that still right now is highly adopted in the industry is to use data capture or computer vision, right? So the idea is that we would scan actors using, for example, a multi-view stereo technology, or in this case, a multi-view photometric stereo system, one thing that was used heavily in our labs back then when I was a professor at USC. We would do high-res scans so we can get down to pore-level details using controlled lighting capture, so a technology that was initially developed by Dr. Paul de Bevec. And we would use this technology to scan actors and also capture physical appearance properties of the face, so we could simulate these faces inside virtual environments. So the main issue with these kind of technologies is that you need a very complex system, right? It's $1 million system, it's hard to deploy, and not to mention the amount of heavy post-processing that happens afterwards. So 15 years ago, when I started my PhD at ETH Zurich in Switzerland, used to have the same haircut. And one thing that we were doing was we were trying to think about, can we make facial tracking more deployable, right? So this was way before there were commercial depth sensors. Here's a system with a projector and machine vision cameras. And what you can see is that we were demonstrating that real-time face tracking was possible and highly automatable, right? So initially, this technology was developed to facilitate visual effects and make it easier for artists to use. But something I didn't really expect, but we commercialized this technology and it was acquired by Apple. And the end solution was actually the Emoji technology that you have in your iPhone. So I continued to push the envelope of facial tracking. A couple of years later, I was involved at Weta Digital. One of the projects that we're working on is basically how can we reenact a photoreal person, right? So this was a use case where Paul Walker, who unfortunately died in an actual car accident, we were trying to reenact his face in the film Furious 7. And basically, the idea was we were tracking the faces of his brother and trying to recreate a digital face of Paul Walker. So this technology actually required a lot of human labor, right? So it basically cost like millions of dollars just to do a couple of shots in the movie. So one thing that's really important is that with the breakthrough of deep neural network, we could basically make these things a lot more robust, right? So I'm going to give a quick introduction of deep neural networks. So initially, deep neural networks were modeled using artificial neural networks, so basically multi-layer perceptrons. But one of the big breakthroughs here is to have what we call neural network 2.0, which is convolutional neural networks. Convolutional neural networks basically consist of multiple layers of linear and nonlinear functions. And what it allows you to do is actually analyze an image. That's basically what we use nowadays for face recognition, for self-driving cars. And the principle is very simple, right? So you basically have multiple layers of these neural networks. And given an input image, what it allows you to do is to basically classify into multiple properties, right? For example, given a photograph of one of my dogs, you can basically say, is that a beagle, is that a toy pool, and you can basically provide probabilities for each of these items. Now, we're going to simplify this concept and basically just put this as a deep neural network. So the first thing that we can do is, instead of using a deep neural network as a classifier, we can actually use it as a regression into different, what we call facial blend shapes, right? So different properties of the face when people are doing different facial expressions. So given a video, so this was an early work with our company and NVIDIA, and we're basically showing that it's possible to build a very robust system to track the human face. Now, one thing that is even more remarkable is that if you just track a face, you still have to render the face using a traditional computer graphics pipeline. So what we wanted to do is to think about, maybe we can turn this deep neural network around, and instead of just analyzing it, we can actually use it as a generator to generate images. This is basically the basic concept of generative AI, right? So the idea here is, for example, I want to create a toy poodle, and you can actually generate an image of a toy poodle. Now, if you think about it, one thing that's interesting here is that, well, what kind of toy poodle is it generating? It can be anything, right? So that's actually one of the principal problems of generative AI, which is how do you control it? Anyway, let's do a quick tour of generative AI. So in generative AI, one of the crown jewels, as many of you have heard, is generative adversarial networks, right? So this is a early work that was pioneered by Ian Goodfellow. And the idea is basically to combine two deep neural networks, one that is there to generate, and the other one that is enhancing the training of the generator by using a discriminator, right? Basically telling it if it's good or if it's bad. And if you train this network with sufficient data, you can basically have a deep neural network where you can always generate something in this specific domain of faces, a realistic face, right? So this is something that NVIDIA has been pushing the limits. Multiple research papers came out of this. And one of the state-of-the-art methods nowadays are StyleGAN 1, 2, and 3. And what it does is that if you train this network with sufficient data, you can actually generate realistic images of things that never existed, right? So this is really the crown jewel of generative AI here. And this is something you can actually try out, right? So I'm pretty sure you've seen that before. You go on the website, this person does not exist, and you can just constantly generate a new face. By the way, a technology that people use a lot for creating fake identities. So what we did now is we're interested in, manipulating faces and also generate new facial expressions, not just new identities. So one of the technologies that we've developed a couple of years ago is what we call PAGAN, photorealistic avatar GAN. And the idea is that instead of generating a new face, we would actually generate new expressions. So in this example, you can see on the upper right, so here we basically have just an simple input image, and on the left, you have a driving video. So we're conditioning the generation of new facial expressions based on a video. So what you can do is you can actually generate plausible facial expressions from a simple person. This technology is just using forward propagation, so it means it works in real time. So here's a live demonstration of how we can use a single camera, a single photograph, and we can overlay another person's face onto a video. So this basically is one of the first real-time deepfake technologies, right? So at the same time, there was the whole, concept of deepfakes that emerged. That was back in 2017. It was anonymously developed, and of course, the code became open source. So a lot of, you could basically see a lot of viral videos. This is a prominent one created by Chris Ume, right? So it's basically the Tom Cruise deepfake. And in addition to all these entertaining videos, unfortunately, we would also see a lot of use cases where deepfakes were used in non-consensual pornography, right? So a lot of A-list celebrities were targeted, and there was also a study by Sensity AI where 96% of all the deepfake contents were actually porn-related. At the same time, there were also a lot of concerns about what if people would weaponize these technologies, and there were actually a couple of cases recently where deepfakes were used in the context of disinformation campaigns for influencing politics, geopolitics, etc. Right? And of course, everyone is aware that there are also privacy and copyright problems. So another problem is in scamming, right? So obviously, these technologies are highly accessible. They can generate things that appear extremely convincing. Here's an example of a high-profile case that happened earlier this year. So a finance worker actually got tricked by someone who actually pretended to be the CFO of a company. So there was a 25 million transaction that was actually done. And to my knowledge, this was one of the first where audiovisual deepfakes were actually used in a live conversation. And of course, there's also other types of deepfakes that were used. For example, in the Taylor Swift case, this is a different kind of deepfake, which I'll talk about later. This is using diffusion models where people would actually generate completely fake images of her, and in this case, related to porn images that were spreading virally on Twitter, right? So 47 million views that were reached in just a few days. So the main problem here is that we now have a technology, as opposed to in the past, that were only accessible to visual effects and production studios. It's accessible to everyone, right? So everyone can generate these content. They're very easy to produce, and you can also generate things that are extremely convincing. So what can we do about it? Well, one of the things is to enhance and to protect ourselves using deepfake detection technologies, right? So we've actually published one of the first work on how do we detect deepfakes, right? So the early technologies were based on biometric type of approaches. So the idea is that we would, for example, record a lengthy video of someone who is known and basically try to match if certain features are appear in a new video, and to see if that the movements are consistent with what is known about the person. A more approachable solution these days is basically to train deep neural networks with real and fake data, and you can actually pretty well detect if something is a deepfake. And of course, there's a lot of commercial solutions out there. Here are two examples, one from Intel and one from Microsoft. But based on our experience, it's actually better to look at the research community. So there's a lot of advancement there as well. The other important thing is that we also need to raise awareness of the potential of deepfakes. So together with the World Economic Forum, we've actually developed the first real-time deepfake technology, basically to showcase, that was back in 2020, that it is possible to actually have live conversations with a fake person. So this was demonstrated back then, but at the same time, the idea wasn't really to have a company that actually creates deepfakes, but our initial goal was actually to enhance digital avatars and make them more real, right? So originally, the whole development was to create a better technology for building digital humans. On the left, what you can actually see, this is a standard output of a state-of-the-art game engine, in this case, the Unreal game engine. But just using a couple of minutes of additional training data, we can actually enhance the likeness of the person. So we actually moved on to a positive use case of these kind of technologies. So what our company is doing is basically we're using generative AI for visual effects. I'm going to show you a couple of interesting use cases. This is a use case for the movie Slumberland. So in the movie, you basically have a scene where a toddler is actually starting to speak. So we have one of the actors who's basically puppeteering the baby and make the baby speak. So I'm going to show you how this looks like.
Babies. Obviously.
Here's another example for a production with Netflix. So this is the TV show The Manifest. It went over 4 seasons, and one of the main characters actually grew up over the different seasons. But in the final season, they actually go back in time, and they wanted to see how the actor actually looked like, how he was as in the first season. So what we did is we used the film material from the first season and trained the model so that we can turn a digital double that you can see here on the left into the likeness of the double of the original actor on the right. Here's another use case. This is Rafael Nadal. Rafael Nadal was recently injured, and he wanted to shoot an advertisement, so we created his current age and also de-aged him in 5 different ages for an advertisement with Infosys. So here you can see none of these people are Rafael Nadal. It's a different person. And what we did is we actually used generative AI to actually recreate his likeness. And if you're aware, so this is the latest show, Fallout, on Amazon Prime. In Fallout, there is like a flashback scene where Kyle MacLachlan, the actor from the original Dune movie, had to look much younger, right? And this is also what we did in terms of like de-aging. So the process is we would take young film materials of the actor, train the model, and basically use the model to actually face replace and de-age his current age. So there's another very interesting use case, and that's actually the scalable market and the bread and butter for our company, which is, can we use this technology to augment actors and make actors speak any language they want, right? So imagine you had a foreign movie. The only solution right now is you have to read subtitles if you don't understand the movie, or you have to deal with really bad dubbing. So the idea is, can we use these puppeteering technologies, facial reenactment, in order to AI lip sync the mouth movement? So that's actually what we did. We're actually the only company out there that has been able to AI lip sync entire movies using this technology. So this was back in 2022. There's a movie called The Champion. It's a Holocaust movie, and it's in German, Polish. And what we did is basically we changed the language into English.
Dass Boxen wie Schachspielen ist.
Rudi, ab ins Bett.
I've read that boxing is like playing chess.
Rudi, auf to bed.
I've read that boxing is like playing chess.
Rudi, off to bed.
Right. And here's a recent work that we've done. We're actually doing a lot of like Netflix movies. This is a French action movie called AKA. And here you can see how we translate from French to English.
C'est quoi le problème?
Ok, bah, je vais te dire c'est quoi le problème. J'avais une dette, une putain de grosse dette, j'ai dû leur lâcher le coup. Y a pas mort d'homme.
J'en ai rien à foutre de ta dette, mon.
Et maintenant, qui c'est qui a la plus grosse? Hein?
Je m'en bats les couilles, je repars pas sur les plombs.
Bah, tu vas pas repartir du tout, alors.
What's the problem? Okay, Pee-wee, I'll tell you what's the problem. I owed these guys one fucking huge debt. I had to give them the scoop. These things happen. Your fucking debt is not my problem. Size matters, wouldn't you say, asshole? Huh? I'm not leaving without those plans I told you. Then you won't be leaving at all.
So one thing we're going to release also very soon is a new product called Pinned Up AI. And what it'll allow you to do is basically just upload your own video, and through our service, you'll be able to translate into any language. You can upload an audio track and AI lip sync your video as well. Or you can also type in any text words and then make the person say, new content. So here's an example of myself, like it's an old video, and I don't speak Spanish, so I wanted to see how I look like when I speak Spanish, so this is the result.
Y para mí lo importante era una ciudad genial y una buena escuela, y no hay muchos lugares como ese. USC es óptimo. Mi objetivo de investigación es llevar tecnologías de captura de rendimiento de Hollywood y laboratorios de investigación a todos para su uso en videojuegos, y para mí lo importante era una ciudad genial y una buena escuela, y no hay muchos.
So the idea is that you would use these kind of technologies that we deploy in Hollywood and can use it for your own videos. Okay, so a lot of these examples actually focus on manipulating or generating the human face. But then there's a question of what if we wanted to generate anything we want, right? So this is the real power of generative AI. And one of the breakthroughs recently that enables this to happen are diffusion models, right? So you've probably heard a lot about stable diffusion. So the idea is that you would break down the general problem of generating content into multiple smaller problems. So the idea is that we would add noise into an image signal, and the generator become the denoising problem, which uses a deep neural network, right? So the idea, so one thing that is really practical here is that you can actually facilitate the use of a text prompt using a text embedding so that you can actually generate any content you want, right? So a couple of examples here, for example, DALL-E 2, your prompt is a teddy bear cut toy poodle eating a bagel in Dubai would generate these images. That was shown a couple of years ago. Midjourney, right? Another text-to-image generation solution that's very popular. And of course, Runway ML, which for the first time showed kind of creepy videos that were generated from text. Back then, I thought it would take a couple of years to generate, any videos. But about this technology, and I think we should all embrace artificial intelligence. Thank you so much. Thank you for your attention.
Thank you so much to Hao Li. Their incredible work. Yes, Tom Hanks has de-aged himself with the aid of Metaphysic, a company. So in about 100 years, there'll be yet another Tom Hanks movie to enjoy. Now, as we head to the break, let's recommend a few fun things to do whilst you're packing up. The social media competition is running. All you need to do is actually post your best picture, thoughts about the summit, things that you like, ideally, things that you like, and the funniest or best social media posts on LinkedIn with our hashtags will in fact win an expensive smartphone. Excellent, so that's rather nice. Next up, buy, sip and win. You can win an actual phone if you simply buy a collapsible coffee cup, which is in my bag. Normally I show it and I kind of demonstrate what you do with a coffee cup, but I think you get the idea. You're an intelligent audience, so buy a cup and that acts as a raffle ticket, and then you can win a Samsung smartphone worth over $1,000. I think it's $1,300, something like that. Also, you can buy a t-shirt from the ITU shop. Yes, you can look like you know about the future of AI and actually people might come up to you and ask you more about it, or not, who knows? And if you're stuck and you need some help, why don't you ask our friendly volunteers? They are in a different t-shirt, which is not purchasable. If you want to become a volunteer, though, at the next event, please let them know, and they'll try and help you too. All right, there's lots and lots of things for you to visit, and I'm going to leave you to say, so that you get a little bit of chance to stretch your legs and get a nice, refreshing beverage. So we'll see you here for 11:30. Thank you. Bye. Welcome back, everybody. It's a pleasure to be back in the room with you. I missed you. I missed you all. It's lovely to see you again, and I'm really glad that you're here. We're going to continue with our programming shortly, but first, just a little bit of help for those of you who might be having difficulty working out how the Wi-Fi works. It's actually both simple and complicated at the same time. You have your username and password on your badge. So you select ITU Wi-Fi, and then on the right-hand side of your badge, you will see two numbers. The first one is your username, and the second one is your password. Actually, that's alphanumeric. It's not just numbers. There's some letters there as well. Feel free to use your phone to magnify the letters as well, if, like me, you were trying to log on in the dark, and it was quite a challenge, but we managed. All right, so I've left that up there just enough time for you to understand that. Brilliant. Next, let's talk a little about Interprify, which is a translation service. I incorrectly said this morning that it translates to 75 languages. It is, in fact, 6 languages. I typed the wrong numbers into my script and then just read it out, so that's apologies for that one. It is 6 languages. They're all UN languages, though. All you have to do is scan that, and then you can access real-time translation. It's brilliant. We also, of course, have subtitles powered by AI on the screens either side. And finally, we are so happy that more and more of you are contributing to the NeuroCreate. This is the word tag cloud that we've all been waiting for in the world of AI. Simply scan that QR code and you can crowdsource insights from summit discussions. That's brilliant, isn't it? So, you know the drill by now. This is day 2, and I would like to invite you to enjoy some fantastic, amazing research all about making AI accessible to all. Please help me welcome Dr. Hakeem Hasid.
Good morning. Good morning, everyone. So I'm here to talk on a pretty interesting topic, just sharing some thoughts on the accessibility. Maybe it's interesting to set the context first. So there are different definitions of this accessibility. So we have people who are working rightfully on how to make AI accessible for people with disabilities, for example. There is a huge work that is done there. We should do, and we should explore more. But I will not touch base on that today. I will be touching base more from the accessibility in terms of countries and institutions to this AI that we are having nowadays. So this is Hakim. So I'm coming from TAI, Executive Director, Acting Chief Researcher of the AI Research Center. Just quickly, a brief introduction of TAI. So we're based in the UAE, in Abu Dhabi. So we are a government entity and the research arm, the research and development arm of the IUCRC, that is the Abu Dhabi Technology Research Council. So we're doing applied research. AI is not the only sort of topic, technological topic that we are handling, but we do much more things. We are 10 research centers exploring different facets of the technology. Probably we are known with the Falcon and the Noor large language models, but we have other colleagues also working on several exciting topics like space, robotics, cryptography, biotech, directed energy, so on and so forth. But the talk of today is more related to the AI accessibility. And I usually start with this slide because it gives us sort of an interesting perspective on the importance of AI. So we can see, it's just depicting actually the number of days or the time that it took for different technologies to reach 1 million users. So we started at some point with Netflix that took actually 3.5 years to reach the 1 million users, and the accessibility, let's say, was pretty slow. And then, going through different technologies, Twitter, Facebook, we got into ChatGPT a few years back, like a couple of years back, that took everybody in the store. So it needed actually only 5 days to reach 1 million users. So that's an interesting statistic, actually. So it shows the importance of the AI. It shows also the need for the users to get such technologies. So, but if we dig deeper into the statistics, actually, we can see at some point that these people and the people who can access and use this AI are in a specific place of the globe, right? So I would say the usual space, like the northern hemisphere of the planet. So this technology needs probably 4 pillars to exist. So the first one is the data. To build these models, you need a lot of data. And this data is mainly coming from the internet. So most of it is available publicly. But the issue that you have is that you need a lot of compute to get the data, and you need a lot of compute to also sort of clean the data and build the model. So these are the first 2 pillars. And then you have the algorithmic part. We work nowadays with the transformers. Maybe tomorrow we will work with something else. But that's something important also to have in the equation. Then we have the important thing that is the talents. That's a key thing. We don't talk a lot about the talents, but that's a very important thing to have. So the countries, the institutions that will be able to master these 4 or to control these 4, let's say, dimensions of pillars, are the ones who will be able to provide the AI of tomorrow and to be able actually to access this AI tomorrow. So this AI came actually, it's not a new thing, right? Like 7, 8 years back, we have different countries that have started defining their AI strategies, right? So you have a very sort of small timeline here. So things have started in the US, and South Korea back in 2016, defining the AI strategies. Then we have different other countries that followed. And then we had, for example, on our case in 2017, the UAE has defined the AI strategy, 2030 AI strategy, and they appointed the minister that was specifically dedicated for AI to actually amplify and coordinate all the work that is done around the AI. A few years later, in 2013, you can see that most of the countries of the world have started actually working on their strategy, setting up an AI strategy to make sure that they can contribute to the definition of AI. And this shows also, again, the importance of the AI for the economy, for the society, and for the humanity in general. The issue is that there are two things here. So there is the definition of the strategy, and then there is the follow-up when it comes to the implementation of the strategy, right? So most of the countries, as of today, they have a strategy for AI, or they are in the process of defining the strategy. But most of the countries also, they don't have enough resources to implement this AI. So if we go back to the pillars that we had before, and I was hearing this since the first day of the AI for Good, the computing power, for example, is a huge issue for everyone, including many countries. So not everyone has the necessary resources to actually enable this. So this could be one of the reasons the slides that you have here is basically showing the cost that we need, the increasing cost that we are getting when we are building these models. So we have started with a few thousands of dollars, and now we are getting to a few hundreds of millions of dollars to get only one model. So it's a very complex process, and we believe that although the strategies are there, not everyone can afford to have these amounts to build a model. So having $100 million to build one model, and with the pace and the speed things are going, so we may need few hundred millions of dollars, if not billions of dollars, to build this kind of thing. So this makes clearly things complicated for several countries. And then I looked into a little bit more from the research perspective and from where the research is coming when it comes to the AI. So we see, again, certain tendency to have the classical actors, the classical players who are contributing to that. But I would like you just to look into this picture or this map and think for a second, right? So if we see the state of today when it comes to AI models, and we question ourselves, where are they coming from mainly, right? So I would think clearly that these models are coming mainly either from the US or the raising China as main sources, right? So we still have in Europe, for example, we have a lot of publications that are coming, but Europe clearly is lagging behind, right? So there is this polarization between the US and China, where the AI is growing extremely fast, new models are coming, Europe is lagging, and then probably we have Africa and the South America that are extremely lagging behind. So this is creating, in my opinion, another divide that I would call the AI divide, as we call it today. So in addition to the divide, the industrial divide that was created because of the Industrial Revolution, this AI is also creating another divide, and not everyone will probably be able to access this AI tomorrow if we continue in this way. So the ecosystem, so the AI is not just a model, it's not just using maximum compute to build your model. It needs much more than that. So of course you need the money, you need the budget for that, but you need the full ecosystem. And the countries, they should work into having the right ecosystem, the right actors who are involved there to make sure that we get something interesting. So we have the data. The data is the core and is a cornerstone for this AI. So we need regulations indeed, but I believe what we do not to be excessive in the regulations to be able to explore and exploit AI to the maximum. So we have the hardware providers, we see the situation nowadays. The hardwares, again, the hardware providers are localized in specific locations of the world. We have the scientists and the developers. This goes back to the talents again. It's very important to create an environment where the talents, they can work together. The governments, we see more and more involvements of the governments in the AI. It's an interesting thing, but again, we need to see what's the right way of doing these kind of things. Then we need the deployment and the business. So if we are just on the scientific side, we are not paying attention on how to deploy, how to get value, let's say economical value from this AI, things will be complicated. And then we have the community and we have the end users that need to be considered in the loop. The challenges to get a good strategy for accessible AI is the compute. The first one is the compute. So we need, once we have the data, we need to look in the compute. And the compute nowadays, again, I was hearing this during these 3 days, the compute is a blocking point for many of the actors. And we need to think, let's say, as a community on how to solve that. So building AI needs a lot of budget. It needs a lot of resources, like financial resources. This is a blocking thing. It's good to have a strategy that is on the paper, but to be able to implement it, we need a lot of resources. The quality of the outcomes, we have the IP issue. So we see more and more work that is closed source, I would say. Everybody wants to keep the IP because there may be something interesting in that. I believe that we can find something more open, or at least more hybrid, sharing things that are slightly open or things that are slightly closed. I think the other thing is the politics. It's an important thing. We are actually at the time where we are almost on the edge, right? In between having the opportunity to explore AI, to make it more accessible for everyone, or we close everything, or even we even stop some innovations that may come from there. How to make AI accessible? The first thing we often, I believe, forget this, is the digitalization or the digital transformation. So most of the countries that we have today, it's nice we are talking about big models, intelligent models, so on and so forth, but we have a lot of countries today which do not have access to the internet, for example, right? They don't have powerful machines. They are still working on paper. Right? So the digital world is still lagging on those countries. So we still need to keep that in mind. Before jumping to the AI, there is a need to help those countries also to come to a point where they can exploit their digital content. The second thing is the model training. Model training is extremely hard, but we cannot ask everyone to build a model, to train a model from scratch. So we have different actors, including us, who are open sourcing the models that we have. So not everyone needs to start from scratch. Taking the models that are there and then building on top of them, doing some continuous training would be useful for everyone. The inference, again, it's the same story. So you need a lot of hardware, a lot of resources to be able to run the inference. Not everyone can access that. So we need to think of ways to run or to be able to exploit and access these models on the inference time on smaller devices, for example. Smaller devices, either computers, either phones, or these kind of things. We cannot just consider that to run an inference, you need a big cluster of GPUs that not everyone can afford. And then the talents is a critical thing. We need to do training. We need to organize a community that is able to train people and to form the talents of tomorrow. Just to link it to that, so a couple of contributions from our side, from TAI. The first one is the Falcon Foundation. So what we are doing is that we are providing all our models as open source. The Falcon Foundation was set up with a $300 million budget to help all the community, all the developers who cannot access for compute, for example, to build things on top of Falcon. So we provide the model, we provide budget, compute budget for developers and researchers, and then they just need to put everything they need to build on top of Falcon. The only condition that we ask for is that whatever is built has to go back to the Falcon Foundation to be open source for the community again. So we are very supportive in that, and we are trying to coordinate all those efforts around Falcon. The second thing that we have, and this should be my last slide, so is that we have launched to help the countries that are not able to access this AI to build, either to move forward when it comes to the digital transformation, or to be able to exploit AI. So AI either at the generative models sense, meaning, or AI in terms of machine learning and related technologies. So we have a program or a fund that is specifically dedicated for that with the $200 million, and we are supporting those countries to get a little bit more modernized when it comes to AI and the digital world. Just a few concluding remarks here. So the AI is getting less accessible, mainly because of the cost, mainly because of the resources that it needs to be run. So we should actually look into how to make it more accessible, work together, and bring the necessary talents to work on that. So the AI divide, if it continues this way, definitely will have an impact, will change or will reshape actually the world, and then the economy, the politics probably will be impacted. One thing that we need to think about is probably, are we doing or exploiting or exploring the right AI? Is it the right path that we are doing? So the way we are doing it today probably is costly and may create some issues down the road. So we are very excited with what's happening, but we should probably keep in mind that there may be other options that we need to think about in the future. So we are working to support the communities and different countries in getting a little bit to lift them up and get them to use the AI and exploit the AI. And as I showed before, so we have two main initiatives, the Falcon Foundation and the IUCRC Fund for the developing countries. Thank you very much.
Thank you ever so much, Hakeem. An absolutely excellent presentation. My goodness, audience, have we got some treats in store for you over the next few sessions. You are going to absolutely love this. So what I'm going to do is talk about the potential of AI to empower and include people with disabilities. And what I'd like to do is welcome to the stage Chieko Asakawa.
Good morning and good afternoon. It is a great honor to be here, and I thank you very much for asking me here. I'm excited to share a few thoughts on empowering people with disabilities through technology. I will focus on the AI suitcase, a navigation robot for the visually impaired, followed by the challenge of social acceptance to implement new technologies into society. Let me give you some background. When I was born, I was sighted. And by the time I was in junior high school, I grew to love sports. People around me thought I could become an Olympic athlete in the future. Studying was not my interest. And I never imagined that one day I might become an IBM Fellow. When I was 11 years old, I hit my eye on the side of the swimming pool. By the age of 14, I became totally blind. One of the challenges I faced as a blind person was mobility. I couldn't go to school by myself. I couldn't go shopping by myself. I couldn't go anywhere by myself. I really wanted to be free from relying on someone. I wanted to be independent. That became my strong need that pushed me and ignited me towards invention and innovation. After many twists and turns, I joined IBM Research in 1985 and started working on accessibility. I then happily discovered that IBM has a long history of accessibility. Back in 1914, IBM hired its first employee with a disability. That was remarkably early, long before society began paying attention to such issues. I first focused on information accessibility by developing Braille digitalization technologies and IBM homepage reader in the 90s. From around 2010 to today, I started working on the mobility challenge. This video shows my exact goal. Please watch.
That is the flying eyeball. Chica, do you know what it is?
It can't be identified. Maybe a kind of monster. Beware of it. It's too dangerous.
It is a very, very old Japanese TV program. I liked it when I was a child and could still watch it. The little bird on the boy's shoulder is a robot named Chika. Chika helps the boy by whispering about everything around him, from the weather to approaching enemies. It was science fiction in those days. But now we have AI, robotics, and a variety of sensors. I decided that the time had come to bring this science fiction to life. Technology like this could notify me of traffic lights, stairs, escalators, elevators, any information that allows me to walk independently. Even more, it could help me navigate and avoid collisions, wait in a line at the coffee shop, describe scenes and people's behavior in the real world. We are currently developing an AI suitcase. Please watch that video.
We arrived at Diversity Tokyo Plaza. Where should we go?
I'm thirsty. Please take me to a place for a drink.
There is a smoothie shop. Would you like to head there?
Yes, please.
There is a Starbucks on your right. The seasonal recommendation is the strawberry frappuccino for 680 yen. We have arrived at the smoothie shop.
I'd like to explore around here. Do you have any recommendation?
There is a life-sized statue of Unicorn Gundam outdoors. It is one of the symbols of diversity.
Sounds good. Take me there.
There is a Hello Kitty shop on your left. Here, they sell sweets shaped like Hello Kitty dolls. They are priced at 600 yen for 10 pieces. Avoiding people. Entering the festival plaza. We have arrived. The Gundam statue is on your right. The height of the statue is 19.7 meters.
I'm sure such information should be useful for everyone. Okay, it is real. I really wanted to bring the AI suitcase here, but logistics at this time are still being worked out. As you just saw in the video, the suitcase moves one step ahead of the user. A guide dog does the same. A white cane enables the user to confirm safety one step ahead. So it is very safe for the suitcase to also be one step ahead. Now, let me show you the hardware. The suitcase robot is equipped with several sensors. A LiDAR sensor on top of the suitcase measures the distance to the surrounding wall and obstacles. 3 RGB depth sensors under the LiDAR on the left, right, and front are used for detecting pedestrians. Now inside the suitcase. A GPU computer on the left does image analysis. A computer on the right does localization,
controls maps, and manages the user interface via a smartphone. In the middle, there is a battery. It runs the suitcase for about 3 hours. The selected motor and gear configuration allows for manual pushing through doors, similar to a regular suitcase. Our handle is very special. When I grip it, it starts. When I release it, it stops. When turning right, the right side of the handle vibrates. When turning left, the left side vibrates.
Before developing the AI suitcase, we studied how guide dogs navigate a blind user. As you saw, a guide dog avoids collisions with static obstacles.
Avoiding a person.
Just like a guide dog, the AI suitcase can move, avoiding static obstacles. In this case, a standing person. Okay, there are many similarities and differences between a guide dog and the suitcase robot. The AI suitcase navigates a user to a destination. A guide dog cannot. The AI suitcase and the user can interact with each other. In the case of a guide dog, it is limited. However, a guide dog can go anywhere humans can go. The AI suitcase cannot. Thanks to the recent AI, the suitcase can describe what's around a user. I took a photo and got this description by using an AI app for the visually impaired.
This image shows the entrance of Brunwald, a traditional beer garden in Munich. The entrance features signs for Lowenbräu and Franziskaner Weissbier, with the street name Biedersteinerster 78 visible. The exterior has yellow walls and a cobblestone path, decorated with flowers. Brunwald offers local beers and Bavarian cuisine in a relaxed setting surrounded by trees. It's a popular spot for both locals and tourists to enjoy traditional German food and drink in a picturesque garden atmosphere.
I presented the ultimate goal of my research when I joined IBM. It was substitute vision for the blind using technology. It was in those days a kind of dream, but now it's almost a reality, as you just heard. If we can use AI for good, our world will become more inclusive and accessible. So far, we have conducted trial sessions for the AI suitcase and received many comments, such as, "I feel independence that I've never experienced after I became blind. I want to bring this robot back to my home. I really like this one. I want to give the robot a name like my guide dog." And another memorial comment was, "I feel comfortable walking seamlessly and naturally in city areas without being recognized as a blind person. I don't feel like people are watching me because I walk confidently." However, some users commented, "It might be a bit scary because people passing by do not notice we are blind, and so we should not expect the necessary help from surrounding people." They questioned, "Should we carry a white cane, even if we don't need it, just to be recognized?" When visually impaired people walk with a white cane, they often risk going the wrong way or hitting an obstacle. So they sometimes need help from surrounding people. Unlike walking with a white cane, the AI suitcase will not go the wrong way or will not collide with an obstacle. It can navigate a user to a destination. So the visually impaired do not have to carry a white cane for help or to be visible. they will be able to walk around public spaces without drawing unnecessary attention from people. But Japanese road traffic laws requires a person alone in a public space to carry a white cane or to be with a guide dog. And similar laws exist in many other countries. When new technologies become closer to availability, we will need to review current laws. Invention and implementation are a pair of wheels for concept. A great invention cannot improve quality of life if real users do not use them or if they are not implemented into society. We need to change common awareness for social acceptance and implementation. For example, smart glasses would be very useful for visually impaired because those glasses can help them understand the surrounding world. But sometimes some people don't like them due to privacy concern. Safety is also another important topic that requires societal understanding. Take the case of the autonomous driving vehicle. Even if autonomous vehicles become completely autonomous, level 5, will people accept if a visually impaired person or a child, neither with a driver's license, drive the car? Large language models like AI chat are rapidly advancing and providing many services like scene captioning. But there are many challenges like inaccurate information. We always must explain the progress of technology. We need to explain how safe and trustworthy the technology is. We need to continue communicating with society for mutual understanding. When we look back at the history of technology, we see a wide range of cases where the special needs of people with disabilities motivate engineers to invent new technologies. The telephone is an example. In the 1800s, Alexander Graham Bell invented the telephone. Why? His mother had hearing impairments, so he became interested in acoustic engineering, taught himself, and invented various technologies. And he also established a school for people with hearing impairments. Through these experiences, he invented the telephone in 1876. The first opportunity to show the invention was the Philadelphia Expo in that year. He wanted to show it after refinement, but his wife with hearing impairments forced him to put it on display. The demo was praised by the judges and awarded the gold medal, and it led to the rapid spread of the telephone. The very next year, in 1877, the Bell Telephone Company was founded that later became the AT&T Corporation. Very quickly, other telephone companies were founded all over the country. This is not a one-time phenomenon. We have seen this repeatedly in the history of technology. Vint Cerf designed the Internet Basic Protocol in the 1970s. He has hearing impairments and became interested in the computer networking system to communicate with others more smoothly. That led to this invention. The latest AI technologies, such as image description, have also been motivated by accessibility needs. Accessibility could be a flagship case for cutting-edge AI and robotics and accelerate social implementation by clearly showing how such innovation has the power to change our quality of life. I strongly believe it will lead us to the next generation of breakthrough invention. In spite of the advancement of the technologies and efforts to make our society inclusive, many blind and visually impaired people have difficulty with education and employment. Using GDP, the estimated annual cost of potential productivity losses from the visually impaired was $410 billion in 2018. That is 0.3% of the world's GDP. In other words, if visually impaired people participate in society more actively and improve their productivity, our world can grow and expect to become better. And such a world will be eventually inclusive and accessible. Technology like AI and robotics play important roles to achieve such goals and turn a dream to reality. We need to implement new technologies into society. However, as mentioned earlier, gaining social acceptance is key for implementation and therefore success. We have a major opportunity at the Expo 2025 Osaka in the Kansai area of Japan. One of the goals of the Expo is the Future Society Showcase. The Expo aims to give a realistic picture of a future society by applying advanced technologies. In 1876, the Expo accelerated the implementation of the telephone. I hope the 2025 Expo will accelerate the implementation of the AI suitcase. I believe Expo is a great opportunity for gaining social acceptance. We have been working on interactive AI suitcase daily event for the Osaka Kansai Expo. And I'm happy to announce that the AI suitcase will be at the Osaka Kansai Expo. Please join us and experience the AI suitcase for yourself. We hope to work together with each and every one of you. Thank you very much. Thank you.
Thank you so much for your thoughts, Chieko. I'm right here. I'm going to turn you around so we can walk back. I want a suitcase that tells me how high things are.
I should I ideally wanted to bring the suitcase, then I could go back to the backstage with the suitcase.
It's a great idea. I'm just passing you on to Julianne there. Thank you so much. Oh, my goodness me. Imagine something like, oh yes, a massive round of applause, Chieko. So if you want to see the AI suitcase in person, it looks like you might have to book your tickets to Osaka for the Expo 2025. What an amazing demonstration. And it's a great example of how diverse teams can make for better quality output for everyone. There are so many compromises that those with disabilities have to make in order to take part in a society designed without everyone in mind. So I'm really glad to see amazing ideas like the AI suitcase getting the oxygen of publicity, because it's in everyone's interest to bend the world to our wishes for an accessible and inclusive future. So with that in mind, we have an incredible event coming up next. I'm going to introduce a demonstration from the founder and president of Wondercraft, Nicolas Simon. Founder and president, are you going to head up at the same time, or are we going to? Yes, let's invite you up first, shall we? Up you come. Hi. Would you like to introduce Charlotte, or shall I? I can Okay, and also please indulge me in welcoming to the stage the professional wheelchair tennis player and exoskeleton user, Charlotte Fairbank.
So hello everyone, I'm Nicolas. I'm the founder of Wondercraft. And this is Charlotte. She will be demoing our personal exoskeleton later. So when she's strapping into the device, I will be talking about the company I founded 12 years ago. So I graduated from École Polytechnique, which is a French engineering school, and Imperial College with a specialization in artificial intelligence. So 12 years ago, it was already a trend. And I also have a family with a genetic disease, which is called Charcot-Marie-Tooth. So my grandmother had the disease, and she had 10 children. And 7 of the 10 children have the disease, so including my father, who gave it to my brother and my sister. So people in my family lose the ability to walk as they grew old, and they end up using a wheelchair. So just after graduating from my engineering school, I looked at what existed at that time in robotics, and it was the time where we had the first videos of Boston Dynamics with a robot walking on a frozen lake, and it was pushed, and at that time it was reacting to keep its balance very fast, and what struck me at that time is that it was really reacting like an animal would do. And I told myself, okay, so now we have the science to reproduce the inner workings of a brain, animal brain. And what I want to do with this technology is to build a new device to help people in wheelchair walk again and go around in the streets or in their home with this device. So what we did is we built like a humanoid robot. So it's really like the legs of a humanoid robot, 12 degrees of freedom, 12 motors, a lot of sensors. So we have first sensors in the ground, inertial sensors a bit everywhere in the structures, position sensors. And we take all this information at 1,000 Hertz by seconds. We compute the optimal motion to keep the stability. And it's a very hard problem, because even for a child, it takes 1 year to learn how to walk, as much as long as to learn how to talk. So we do it without thinking about it, but the brain is working all the time to adjust your position, to keep your balance. And it's particularly hard for bipedal. So that's why robots started with quadrupeds, because bipeds it's harder. So we worked 12 years of R&D. We are now 100 people. We've raised $70 million, and we invested in developing this product. We started by releasing a first generation of our product in 2019. So it's a rehabilitation product. It's called Atalant. It helps people learn how to walk again after a stroke, for example, in a rehabilitation institute. We have helped more than 2,000 patients relearn to walk after a stroke. But the end goal was always to build the device for people to be able to take them home, to use it in their home environment or in the streets, to go into a park with their friends. And after 12 years of work, we are proud to present you this personal exoskeleton. And yeah, now Charlotte will do the demo.
Thanks, Nicolas. Hi, everyone. I'm happy to be here. My name is Charlotte Fairbank, and I have been a full-time wheelchair user for the last 16 years, almost. So in 2007, I had an accident where a bale of hay, it was quite an original accident, a bale of hay crushed me. It was very heavy, and it crushed my back. It rendered me paraplegic. So when you're paraplegic, you can no longer feel your legs or move your legs at all. So I've got complete paraplegia. I can't move my legs at all. Wondercraft has enabled me to walk again. So the first time I worked with Wondercraft was just under 2 years ago, in August 2022. I was initially using or walking with their rehabilitation device, and I really think that there is a massive future for the exoskeleton. So you're now going to see me, for the first time in 16 years, walk across a main stage. Here we go. We ready? So I'm now in speed number 2. I'm going to switch in speed number 3. There are different speeds. And I'm going to try and go and pick up this bag. So there are different modes. So there's the walking mode that you've just seen. There's also a free mode, which allows you to kind of have more of an active side to the exoskeleton. So I'm going to quickly switch. So this allows me to move around a little bit more and go and grab the bag. I can now turn around a little bit more. There's also, in order to move around with this exoskeleton, as you can see, I'm using a remote control. It's easy to hold. I can also clip it here if I want to go and reach something and I don't want the remote in my hand. All I have to do is push on this joystick at the end of the remote control to move sideways, forwards, backwards, move around. And this also works with a motion sensor, which is behind my back. So this motion sensor detects kind of my initial movements, so my intentions, really. So when I'm, for example, standing up or sitting back down, the light kind of inclination that I have with my back, that will be sensed by the sensor, and it will enable me to stand up and sit back down again. So I'll just turn around, and then I'll let Nico speak again and talk about the future of Wondercraft. There we go.
So that was our first live demo on stage. So it went well. No demo effect.
Thank you.
So I'm really happy to have done that because you see the smile of Charlotte, and that's really why we're working for that. We're giving smile to people and to my family. We all have people in our knowledge that have mobility impairments. And you saw that what AI is able to do. It's quite complex machine. It took us 12 years of hard work. We have a lot of top engineering guys in our company that are working very hard to solve the problem every day. And what we are seeing now is that it's really accelerating really fast. with AI and the latest technique in machine learning, we've seen incredible progress in our labs, because the new techniques, really, when you use it, it's like you're able to reproduce the performance of the brain, of the human brain. So whatever you're able to do with your body, the machine is able to do it. So for example, we have new algorithms that are able to handle pushing, slopes, stairs. We're also adding vision sensors on the device. And everything is possible thanks to AI. So for us, AI is really about empowering people. So the science, the technology, I'm a true believer in progress and science. And this is a good example of what we can do if you use the technology well. And another good news is that Medicare, because technology is beautiful, but access to the technology is more important. So that's quite a complex machine, and it has a cost. But Medicare decided in April 2024, so this year, very recently, to cover personal exoskeleton. So it means that in the US, 70% of the people with SCI will have access to such a device. So it's really big news. And now we are hoping, because we are a French company, that France will follow the US example. And as we are scaling production, because we are preparing to produce it at large scale, we really hope to get the cost down, because in the end, it's only like 12 electric motors, so it's mostly like 12 electric bicycle. So there's no reason that the cost cannot go down. And there is millions of people needing such a device. For example, in the US, there is 2 million people that use a wheelchair, being spinal cord injury, stroke patients that were not able to walk again after stroke, multiple sclerosis, degenerative disease like in my family, Charcot-Marie-Tooth. So it's really millions of people. And if we produce it at scale, it can go down a lot. And for example, it's 10 times less weight than a car, 10 times less components. So there's no reason, if we produce hundreds of thousands of millions of them, that it doesn't cost 10 times less than a car. Thank you.
Well, wow. Thank you so much. And do you know, I tried this out in 2019. I visited your offices and I filmed with the BBC. So I have stood where you're standing now. And back then it was really big, it was clunky. I had to buy high shoes so that I could fit. And it's just amazing to see how far you've come. So what's next?
So as I said, we are working every generation to get thinner, lighter, more able to address an event ground, adverse environment, even going into a crowd, navigating complex spaces, and really it's going really fast with the development. So this is the version today, but tomorrow we'll have even better one.
Oh, I wish you all the best of luck. What a powerful demonstration. Thank you very much to the Wondercraft team, and Charlotte, thank you as well. Well done, my goodness.
Thank you.
Right, I think we're going to gently, casually walk off stage, because you can. I love how we've normalized this, by the way. Isn't that amazing? Just walk off with your exoskeleton, and I'll tell you what's going to be in store for after lunch. Okay, so as we leave Wondercraft, we have many more things for you to enjoy. We are running our social media competition as well, which is here. All you have to do is you can scan this for the contest, and if you are to tweet on, I don't think you can tweet anymore, can you? Okay, you can X, I guess. But I believe we're going to be monitoring LinkedIn, because that's the new Twitter, I believe. If you want to have a look on LinkedIn, put your thoughts and some pictures, possibly of the fantastic exoskeleton, and the winners will receive a new smartphone. Lovely. Okay. You can also win an expensive Samsung smartphone. Another way, if you head over to our shop, and you can do a buy, sip, and win. This is kind of like a raffle contest with a difference. All you need to do is buy a lovely collapsible cup to keep your hot and cold drinks in, and that will act as your ticket, and the winner of our prize draw will also receive a fabulous Samsung smartphone. Excellent. Now, we can also look the part with our T-shirts. Yes, you can buy a very, very snazzy-looking multicolored T-shirt, and that also shows your support for AI for Good, and shows that you were here when thousands of people weren't able to get into the building yesterday. So thank you very much for being here again on day 2. And if you do need any help, please do not hesitate to go and contact our fantastic AI for Good volunteers. They're brilliant, they're friendly, they're clever, they're everything we hope an AI assistant should be, except they're actually human assistants, not AI assistants. Probably a few more years before we replace them with AI. Okay, well, thank you very much for being so attentive. We're going to say goodbye, and I would like to see you all here back at the main stage at 1:55 for a lovely 2 p.m. start. Thank you.
You tell me, or will it rain today? You tell me. How's the recipe? You got me. Can you cook for me? Can you see me? You tell me a joke. Can you hear me laugh? I tell you when I'm sad. Do you understand? When you're there when I need you, can you hold my hand? Let's play, find out together and stay in a place where we love, we care, the way that we share is how it should be. Ethically, let's play, thinking together and stay in a world that we love, we care. One day we'll share, it's how it should be. Ethically.
My name's Sougwen Chung. I'm an artist and researcher and artistic director of Silicet, a studio exploring human and non-human collaboration. So my mother's a programmer and my father's a musician, and I think this has me really interested in this idea of hybridity. In particular, hybridity through art and technology. And through some of these interests, I found myself at the MIT Media Lab building my first collaborative robot. In my practice in art and technology, I'm really engaged in the promises, possibilities, and paranoias manifested by developments in art, technology, and science. I believe these developments are changing what it means to be human, and I'm really driven by curiosity about what that can mean for generations that came before and generations to come. In my practice, I see art and engineering practices as one and the same. Both fields have the potential to uncover something real about the human condition, and I think are grounded in an exploratory process of speculation and discovery. I work with robotics, AI systems, data, and mixed reality as drawing, performance, sculpture, and installation. I'm really inspired by how we think about the idea of a human and of a machine. And I'm really curious about where AI ends and we begin. In the past few decades of technology development, I design what I like to think of as sensory mixes of the future. I've been working on a project called Drawing Operations Unit, generation 1 to 5 for like the past 8, almost 9 years. Its focus has really been on the potential of human and machine collaboration. In Generation 2, we focused on exploring memory by training a machine learning model on 2 decades of my own drawing data. In Generation 5, designed over the pandemic, I thought about my own meditation practice as a kind of creative catalyst and substrate. I used my own biofeedback recorded through meditation to generate EEG data as drivers for robotic movement in my own painting process. I like to think of it as waves of my mind to lines on a canvas. My most recent work is called Flora Rearing Agricultural Network, FRAN for short, a project exploring human, plant, and machine connaturality. The work speculates at what I like to think of as an interdependent ecosystem of human, machine, and flora, and explores the linkages between machine and ecology through the development of a networked robotic system stewarding nature. In my practice, I work with and develop a range of technologies. I work with robotics as collaborative partners, machine learning as drivers for painting movements, and EEG to create systems of biofeedback. I'm interested in how research-driven processes, algorithmic systems, and custom computer vision software offer new and speculative human and machine configurations. Using custom and existing research for artistic purposes means extending the possibilities of the research beyond fixing a problem or asking a specific question into a more speculative, playful arena that engages new research prompts, as well as new conditions for philosophical inquiry. The drawing operations work as an intergenerational art and research project evolves conceptually, technically, and philosophically with the growing role of technology in our lives. I like to frame it as a collaboration because it really foregrounds the relational dynamics between human and machine, and technology and society. I'm curious about this question of agency within systems, and think of the practice and these projects as a microcosm to consider the wider implications of things like technological governance and its entangled relationship to the human subject. It's so hard to make predictions about even 5 years down the road. And I think we've seen how quickly over the past few years life can really change in an instant. But I hope that the field of human and machine collaboration is increasingly understood and grown as a site of invention and of promise, one that extends a diversity of subjects and points of view. I'm really hopeful about this because it means that we're working towards this transformation of the human and machine and our environment. And I think that as an interdisciplinary aim is really powerful.
My name is Loclair and I'm an artist working mostly with digital fabric. My background is arts and technology, so as a dancer I learned about poetry and I learned about narration, and on the other hand I'm a computer scientist and I studied human-computer interaction, which is about how we touch machines, how machines see us, how we see them. My work today is mostly about the encounter, the poetic encounter of man and machine, the friction and the beauty between the digital and the analog realm. So right at the hybrid intersection of those synthetic and those natural sensations, I continuously strive to investigate how do we actually meet our mirror, and how do we actually see ourselves through the lens of a machine. My selected artwork is called Helen. It's an AI-based sculpture. That means its shapes, its forms were defined through a process using deep learning. And to me, it basically discusses intention. So an actual artwork normally is born within the artist and his or her intention to create something. And once this creation then starts building, we can slowly see how this thought starts to manifest in the real world. In the case of Helen, however, its shapes, its lines were determined by a neural network, and it was then shaped through a mechanical robot. So basically it is an object that is now standing in the world that was not thought of by a human, nor created through a natural process like stones at a cliff. It just comes out of nowhere, and to me it also feels like that. It's a dark, cold stone and it's quite beautiful. However, there is something missing, and I think you see it when you're standing right in front of it. There's a certain emptiness, and that emptiness is something that interests me. The artwork Helen is created through a custom algorithm that we invented at the studio Loclair. And it is basically an algorithm that is inspired by deepfake technology. So deepfake technology works like this. It is basically analyzing a certain data set with a certain coherence. For instance, faces of humans. And then is able to think of a completely new face that fits actually and that we expect to be a human. And somehow this algorithm is able to kind of invent it. We applied this technology of deepfake to art history and showed our algorithm 60,000 busts that were made in human history, and then asked the machine, could you create another one that wasn't done before but still fits to the style of what, well, humans do and did in the last 2,000-3,000 years. And then it came up with a new sculpture, and that is called Helen. The aspect of Helen that brings insights into our possible future is actually the way it was created. If you think of institutions as well as brands, what they try to do is to analyze what serves us best and then feed back this to us by predicting what could be done. Brands try to increase revenue through this continuous interaction with a population, and institutions try to serve and help humans to improve the way they live. Now that is exactly how machines work. They analyze data and predict. Imagine that there's in the future an emptiness inside of institutions and brands that continuously analyze with machines how we feel and what we do and accelerate exactly this, but without opinions made by humans. My prediction for the next 20 years is that we will see and witness how we continue to separate from scientific reality as a population. Today's artists are not standing stable, looking into the future as they completely comprehend today's reality. The most forward-thinking artists of our time are standing shaky, insecure, and trying to grasp what they saw in science in the last 15 to 20 years, trying to find balance.
Hello, my name is Sofia Crespo. I'm a generative artist and I work primarily with AI tools around the topic of nature and artificial life forms. I'm also the co-founder of a small artistic studio called Entangled Others, where I work together with Pelican McCormick, an artist from Norway. And together we collaborate on various projects that aim to create narratives or storylines about nature and also reframing new technologies. I am very fascinated by the idea of evolution and organic life using artificial mechanisms to evolve. And through my work, I try to explore how we humans create algorithms to replicate or to create something that to us seems like a replica of a biological process. My practice focuses on imagining artificial life forms, and every project that we worked on somehow touches on that, aims to do that. Hybrid Ecosystems is a series about the boundary of nature and technology and where that boundary actually lays, and a future where that boundary could be very blurry. So one struggles to tell where a technological artifact ends and where a nature begins. Another series that is very dear to my heart is Neural Zoo, which is a series of speculative life forms that aim to recreate textures that look natural but are actually species that don't exist. In my work, I use a wide range of different neural networks, and very often that depends on the concept of the project. So it usually begins with an idea that I want to produce. And the neural networks can take a lot of different shapes. They can be text or text-to-image models, or audio, GANs, 3D GANs, 3D style transfer, etc. This means that, to me, machine learning isn't an end in itself. It's a tool that I have available right now, but to me it feels part of a larger project that in the future could take a completely different shape. I like a lot the idea that technology becomes naturalized over time, and that given enough time and enough use, we take the technology for granted and it stops feeling like a completely separate object to us. But this also implies that for this to happen, our own relationship with nature changes as well. So nature becomes part of the same thing that we are. And I think that's a very important shift to do as humans, to stop seeing ourselves as a very separate entity from the rest of nature. I don't like making predictions of what's going to happen in the future, because I prefer approaching the present as it comes and finding ways to adapt to it. But I do really enjoy the place of dreaming speculative futures and trying to think what are potential ways that we can collaborate and come together as humans to change our way of connecting with the world. So I can only hope that we will use technologies in ways that help us do that.
Hi, I'm PortraitXO. I am an independent artist and researcher. I have been heavily sonically obsessed with space and time. Specifically, over the last couple years, I've been researching and collaborating with data scientists such as databots and open source culture and coders from Pollinations.ai community, and have also been doing my own personal experiments with open source resources. And I'm forever curious about what all of this means to us living in a data-driven society, the impact on me as an individual, as well as collective impact, the impact on society and our environment. And I am searching for the humanity between art, music, science, and technology through exploration and experimentation of how far I can take sounds and storytelling through latent space. My AI audiovisual piece, Plastic Skin, is the result of 2 artist residencies and 1 part of my AI audiovisual album, Wire. In 2020, I finished my artist residency at Factory Berlin and collaborated with CJ Carr from Databots, where we trained 1 hour of my singing vocals into their custom sample RNN model that generated 10 hours of new audio over 2.5 days. And it gave birth to a process we like to call neurovocal duet that I've fallen in love with, that basically allowed me to co-create lyrics and melodies with this AI version of my voice that was creepy, eerie, and also fascinating. The second residency was at BBA Gallery, where I was able to have different types of performance captured in the gallery space. And this video shows me performing in the gallery and then using that video as input for a text-to-video clip-guided VQ-GAN open source model provided on pollinations.ai. And that allowed me to further tell the story of the meaning behind this song through text prompts. And there were 2 different experiments that were basically blended into one that you see in this video. There were several types of technology used to produce this work. First step was to gather 1 hour of my vocals, which I took from over 200 songs that I wrote in a year, and took the best from that. And for that to happen, I used Ableton, which is my go-to recording software. The second was custom sample RNN model by Databots, which was the way we got this raw audio AI generation of my voice. And the second piece of technology was provided by pollinations.ai, which is the text-to-video clip-guided VQ-GAN model. The aspect of this piece that maybe gives insight into our possible future relationship with technology is in the storytelling. The song itself is written in the perspective of the robot singing to its human creator, who created the robot to try and fulfill all its desires and needs, including love. And the robot basically is trying to point out to the human that based on the data and analytics, the result is inconclusive because human behavior with love is far too erratic. And I genuinely think that AI will not become sentient. AI is not sentient, but AI can possibly make humans more sentient. And I do think that human-machine collaboration used with AI in this way can offer a whole new level of intimacy in the way we work as creatives. I think the next 20 years of human-machine collaboration is going to get really fascinating, full of surprises. At the same time, I think that there will be some aspects that will naturally get faster and better, like audiovisual fidelity. And I think it's really crucial and important for more humans to get into the narrative of AI and understand its impact on us, because humans can save humans, machines cannot save humans. But humans working with machines in particular ways can maybe save humans.
My name's Sougwen Chung. I'm an artist and researcher and artistic director of Silicet, a studio exploring human and non-human collaboration. So my mother's a programmer and my father's a musician, and I think this has me really interested in this idea of hybridity. In particular, hybridity through art and technology. And through some of these interests, I found myself at the MIT Media Lab building my first collaborative robot. In my practice in art and technology, I'm really engaged in the promises, possibilities, and paranoias manifested by developments in art, technology, and science. I believe these developments are changing what it means to be human, and I'm really driven by curiosity about what that can mean for generations that came before and generations to come. In my practice, I see art and engineering practices as one and the same. Both fields have the potential to uncover something real about the human condition, and I think are grounded in an exploratory process of speculation and discovery. I work with robotics, AI systems, data, and mixed reality as drawing, performance, sculpture, and installation. I'm really inspired by how we think about the idea of a human and of a machine. And I'm really curious about where AI ends and we begin. In the past few decades of technology development, I design what I like to think of as sensory mixes of the future. I've been working on a project called Drawing Operations Unit, Generation 1 to 5, for like the past 8, almost 9 years. Its focus has really been on the potential of human and machine collaboration. In Generation 2, we focused on exploring memory by training a machine learning model on 2 decades of my own drawing data. In Generation 5, designed over the pandemic, I thought about my own meditation practice as a kind of creative catalyst and substrate. I used my own biofeedback recorded through meditation to generate EEG data as drivers for robotic movement in my own painting process. I like to think of it as waves of my mind to lines on a canvas. My most recent work is called Flora Rearing Agricultural Network, FRAN for short, a project exploring human, plant, and machine connaturality. The work speculates at what I like to think of as an interdependent ecosystem of human, machine, and flora, and explores the linkages between machine and ecology through the development of a networked robotic system stewarding nature. In my practice, I work with and develop a range of technologies. I work with robotics as collaborative partners, machine learning as drivers for painting movements, and EEG to create systems of biofeedback. I'm interested in how research-driven processes, algorithmic systems, and custom computer vision software offer new and speculative human and machine configurations. Using custom and existing research for artistic purposes means extending the possibilities of the research beyond fixing a problem or asking a specific question into a more speculative, playful arena that engages new research prompts, as well as new conditions for philosophical inquiry. The drawing operations work as an intergenerational art and research project evolves conceptually, technically, and philosophically with the growing role of technology in our lives. I like to frame it as a collaboration because it really foregrounds the relational dynamics between human and machine and technology and society. I'm curious about this question of agency within systems and think of the practice and these projects as a microcosm to consider the wider implications of things like technological governance and its entangled relationship to the human subject. It's so hard to make predictions about even 5 years down the road. And I think we've seen how quickly over the past few years life can really change in an instant. But I hope that the field of human and machine collaboration is increasingly understood and grown as a site of invention and of promise, one that extends a diversity of subjects and points of view. I'm really hopeful about this because it means that we're working towards this transformation of the human and machine in our environment. And I think that as an interdisciplinary aim is really powerful.
My name is Loclair and I'm an artist working mostly with digital fabric. My background is arts and technology, so as a dancer I learned about poetry and I learned about narration, and on the other hand I'm a computer scientist and I studied human-computer interaction, which is about how we touch machines, how machines see us, how we see them. My work today is mostly about the encounter, the poetic encounter of man and machine, the friction and the beauty between the digital and the analog realm. So right at the hybrid intersection of those synthetic and those natural sensations, I continuously strive to investigate how do we actually meet our mirror and how do we actually see ourselves through the lens of a machine. My selected artwork is called Helen. It's an AI-based sculpture. That means its shapes, its forms were defined through a process using deep learning. And to me, it basically discusses intention. So an actual artwork normally is born within the artist and it's his or her intention to create something. And once this creation then starts building, we can slowly see how this thought starts to manifest in the real world. In the case of Helen, however, its shapes, its lines were determined by a neural network, and it was then shaped through a mechanical robot. So basically it is an object that is now standing in the world that was not thought of by a human, nor created through a natural process like stones at a cliff. It just comes out of nowhere, and to me it also feels like that. It's a dark, cold stone and it's quite beautiful. However, there is something missing, and I think you see it when you're standing right in front of it. There's a certain emptiness, and that emptiness is something that interests me. The artwork Helen is created through a custom algorithm that we invented at the studio Loclair. And it is basically an algorithm that is inspired by deepfake technology. So deepfake technology works like this. It is basically analyzing a certain data set with a certain coherence. For instance, faces of humans. And then is able to think of a completely new face that fits actually and that we expect to be a human. And somehow this algorithm is able to kind of invent it. We applied this technology of deepfake to art history and showed our algorithm 60,000 busts that were made in human history, and then asked the machine, could you create another one that wasn't done before but still fits to the style of what, well, humans do and did in the last 2,000-3,000 years. And then it came up with a new sculpture, and that is called Helen. The aspect of Helen that brings insights into our possible future is actually the way it was created. If you think of institutions as well as brands, what they try to do is to analyze what serves us best and then feed back this to us by predicting what could be done. Brands try to increase revenue through this continuous interaction with a population, and institutions try to serve and help humans to improve the way they live. Now that is exactly how machines work. They analyze data and predict. Imagine that there's in the future an emptiness inside of institutions and brands that continuously analyze with machines how we feel and what we do and accelerate exactly this, but without opinions made by humans. My prediction for the next 20 years is that we will see and witness how we continue to separate from scientific reality as a population. Today's artists are not standing stable, looking into the future as they completely comprehend today's reality. The most forward-thinking artists of our time are standing shaky, insecure, and trying to grasp what they saw in science in the last 15 to 20 years, trying to find balance.
Hello, my name is Sofia Crespo. I'm a generative artist and I work primarily with AI tools around the topic of nature and artificial life forms. I'm also the co-founder of a small artistic studio called Entangled Others, where I work together with Pelican McCormick, an artist from Norway. And together we collaborate on various projects that aim to create narratives or storylines about nature and also reframing new technologies. I am very fascinated by the idea of evolution and organic life using artificial mechanisms to evolve. And through my work, I try to explore how we humans create algorithms to replicate or to create something that to us seems like a replica of a biological process. My practice focuses on imagining artificial life forms, and every project that we worked on somehow touches on that, aims to do that. Hybrid Ecosystems is a series about the boundary of nature and technology and where that boundary actually lays, and a future where that boundary could be very blurry. So one struggles to tell where a technological artifact ends and where nature begins. Another series that is very dear to my heart is Neural Zoo, which is a series of speculative life forms that aim to recreate textures that look natural but are actually species that don't exist. In my work, I use a wide range of different neural networks, and very often that depends on the concept of the project. So it usually begins with an idea that I want to produce. And the neural networks can take a lot of different shapes. They can be text or text-to-image models, or audio, GANs, 3D GANs, 3D style transfer, etc. This means that, to me, machine learning isn't an end in itself. It's a tool that I have available right now, but to me it feels part of a larger project that in the future could take a completely different shape. I like a lot the idea that technology becomes naturalized over time, and that given enough time and enough use, we take the technology for granted and it stops feeling like a completely separate object to us. But this also implies that for this to happen, our own relationship with nature changes as well. So nature becomes part of the same thing that we are. And I think that's a very important shift to do as humans, to stop seeing ourselves as a very separate entity from the rest of nature. I don't like making predictions of what's going to happen in the future, because I prefer approaching the present as it comes and finding ways to adapt to it. But I do really enjoy the place of dreaming speculative futures and trying to think what are potential ways that we can collaborate and come together as humans to change our way of connecting with the world. So I can only hope that we will use technologies in ways that help us do that.
Hi, I'm Portrait XO. I am an independent artist and researcher. I have been heavily sonically obsessed with space and time. Specifically, over the last couple years, I've been researching and collaborating with data scientists such as databots and open source culture and coders from Pollinations.ai community, and have also been doing my own personal experiments with open source resources. And I'm forever curious about what all of this means to us living in a data-driven society, the impact on me as an individual, as well as collective impact, the impact on society and our environment. And I am searching for the humanity between art, music, science, and technology through exploration and experimentation of how far I can take sounds and storytelling through latent space. My AI audiovisual piece, Plastic Skin, is the result of 2 artist residencies and one part of my AI audiovisual album, Wire. In 2020, I finished my artist residency at Factory Berlin and collaborated with CJ Carr from Databots, where we trained 1 hour of my singing vocals into their custom sample RNN model that generated 10 hours of new audio over 2.5 days, and a process we like to call neurovocal duet that I've fallen in love with, that basically allowed me to co-create lyrics and melodies with this AI version of my voice that was creepy, eerie, and also fascinating. The second residency was at BBA Gallery, where I was able to have different types of performance captured in the gallery space. And this video shows me performing in the gallery and then using that video as input for a text-to-video clip-guided VQ-GAN open source model provided on pollinations.ai. And that allowed me to further tell the story of the meaning behind this song through text prompts. And there were 2 different experiments that were basically blended into one that you see in this video. There were several types of technology used to produce this work. First step was to gather 1 hour of my vocals, which I took from over 200 songs that I wrote in a year, and took the best from that. And for that to happen, I used Ableton, which is my go-to recording software. The second was custom sample RNN model by Databots, which was the way we got this raw audio AI generation of my voice. And the second piece of technology was provided by pollinations.ai, which is the text-to-video clip-guided VQ-GAN model. The aspect of this piece that maybe gives insight into our possible future relationship with technology is in the storytelling. The song itself is written in the perspective of the robot singing to its human creator, who created the robot to try and fulfill all its desires and needs, including love. And the robot basically is trying to point out to the human that based on the data and analytics, the result is inconclusive because human behavior with love is far too erratic. And I genuinely think that AI will not become sentient. AI is not sentient, but AI can possibly make humans more sentient. And I do think that human-machine collaboration used with AI in this way can offer a whole new level of intimacy in the way we work as creatives. I think the next 20 years of human-machine collaboration is going to get really fascinating, full of surprises. At the same time, I think that there will be some aspects that will naturally get faster and better, like audiovisual fidelity. And I think it's really crucial and important for more humans to get into the narrative of AI and understand its impact on us, because humans can save humans, machines cannot save humans. But humans working with machines in particular ways can maybe save humans.
need you, can you hold my hand? Let's play, play, find out together and stay, stay, stay in a place where we love, we care. The way that we share is how it should be. Ethically, let's play, play, thinking together and stay, stay, stay in a world that we love, we care. One day we'll share, it's how it should be. Ethically. What time is it? You tell me. Or will it rain today? You tell me. How's the recipe? You got me. Can you cook for me? Can you see me? You tell me a joke. Can you hear me laugh? I tell you when I'm sad. Do you understand? And you're there when I need you. Can you hold my hand? Let's play, play, find out together and stay, stay, stay in a place where we love, we care. The way that we share is how it should be. Ethically, let's play, play, thinking together and stay, stay, stay in a world that we love, we care. One day we'll share, it's how it should be. Ethically. AI for good. Good for me, good for the planet, good for each other. Cause sustainable, united us all. Unite us all. AI for good. silicone dreams, memory rights, only one chance, change all our minds. Silicone dreams, memory rights, might only between the lines.
I use AI for good. Yeah, use AI for good. I use AI for good. Yeah, use AI for good. Let's use AI for good. Let's use AI for good. Let's use AI for good. AI for yeah, SDG. Yeah, you and me. Yeah,
good afternoon, everyone. Now, I'm not sure if you'll have noticed, but there's a few things on stage behind me this evening. Yes. Well, there's going to be more on that. I'm so excited for you to see these demonstrations. And welcome back, everybody, to the main stage here at AI for Good. We've got a lot in store for you. If you were wearing a brain cap like those dancers this morning, it would register a huge increase in activity over this afternoon's session. So ahead of some super impressive demonstrations, it's a pleasure to introduce to the stage the super impressive Deputy Secretary General of the International Telecommunication Union, even. Please welcome an afternoon round of applause for Tomas Lamanauskas.
Our planet is on fire and flooded by water. Every month breaks new records. The wrong kind of records. April 2024 was the 11th month in a row with a record high global temperatures. Actually, the month was 1.58 degrees Celsius warmer than the estimated April average before global industrialization. The consequences include supercyclones, forest fires, a severe drought in the Amazon rainforest, and severe floods from Afghanistan to Kenya. Often, the most vulnerable communities are the ones hit hardest. Rising levels put small island developing states in severe peril. When it comes to the climate crisis, is AI part of the problem, or will it help us find a solution? Ladies and gentlemen, good afternoon. Actually, I was debating whether to say good afternoon at this moment after all this introduction. But here we go. So for now, our AI use makes a large and growing carbon footprint. These technologies are hungry for electricity, more than they can get from renewable power supply. The International Energy Agency, or IEA, tells us that 2 years from now, data centers could consume twice as much energy as Japan does today. According to a study by ITU and the World Bank, in the 2 years up to 2022, electricity use for data centers increased by 57%. Emissions from data centers are skyrocketing. They accounted for 32 million tons of emissions in 2022, up 45% from 2 years earlier. We, as AI developers and users, need to bring this under control. To limit global warming, we must cut tech-related emissions to net zero by 2050, rather than unleash exponential emissions growth. The necessary path is actually captured in a key ITU standard. And it says that we need to start with a crucial 45% cut between 2020 and 2030. AI is thirsty too. Researchers found that 10 prompts can consume as much as half a liter of water. And then there is also a risk of intensifying resource competition as competing AI hubs scramble for energy supplies, rare minerals, and scarce microprocessor chips. Well, AI can also bolster eco-solutions that help protect biodiversity, though. For example, AI technologies can detect and analyze subtle ecosystem changes and help plan conservation efforts. AI solutions boost energy efficiency and cut waste and emissions across other sectors. Recent research actually suggests that AI can help mitigate between 5 and 10% of global greenhouse gas emissions by 2030. Equivalent to the total annual emissions of the European Union. The potential for AI-based climate solutions is crystal clear. But it won't be realized until we tackle the risks to our planet presented by rapid AI growth head-on. The good news is that digital companies are leaders in renewable energy uptake, accounting for 60% of global purchases by 2021. This has helped keep tech-related emissions constant despite the surge of generative AI. ITU standards have also helped address tech-related emissions and e-waste for several years. We have standards helping big data and AI support smart energy control for telecom sites and data centers, especially by prioritizing renewable and low-carbon power sources. Our green standards package is expanding to ensure we rein in our industry energy and carbon footprint. Importantly, the tech industry recognizes its responsibility as well. Green Digital Action Track that we launched at the last climate conference, COP28. Green Digital Action in that track mobilized over 40 partners, including governments, businesses, and civil society, as well as UN agencies and international development banks. Through Green Digital Action, we aim to put digital solutions at the forefront of the climate action. Partners have also committed to report their climate data, a crucial step to get tech on the right side of history. We need far better data to green the digital economy. ITU and partners are working to ensure that the emissions of digital products or services are measured and reported. Similarly, ITU and our world standards cooperation partners have pledged to deliver technical standards that make both business and environment sense. We are encouraging the entire global tech industry to get on board. I encourage all of you to support Green Digital Action and make AI part of the solution. So, ladies and gentlemen, I'm confident AI will help us respond to the climate crisis, but we need to work hard to make that happen. It is a vital aspect of using AI for good and an urgent challenge for humanity today. Let's work together to make sure that AI helps us save our planet, not sink it further. Thank you very much.
Thank you very much to Thomas there for a very powerful call to action. And this isn't the first time I've shared the stage with a robot, but what I'm going to do is briefly explain what's going on behind us. The clue is robotic autonomy in the wild. I'm sure you're as intrigued as I am. I have seen the rehearsal for this. It's quite remarkable. But to help make some sense of this display, we have from the wonderful Norwegian University of Science and Technology, alongside his robotic owl, yes, you did hear that correctly, please welcome Kostas Alexis.
Hi, my team and I are here today to present you progress about using autonomous robots at any time and in any environment, however strenuous and demanding this might be. We call this, as from the title, robot autonomy in the wild. We believe that such robots can be used to probe and explore extreme natural habitats, such as underground caves or glaciers, where we are actually located in Norway. And likewise, also be used to monitor, inspect, and maintain critical infrastructure and industrial facilities at the best possible standing, therefore also reducing their potential environmental impact. But we ask ourselves scientifically, what is a common way that can allow diverse robotic configurations, walking systems, flying systems, or even swimming systems that you will not see today because making a pool will be very difficult, to operate with resilience in any environment under extreme conditions? Before we go ahead to discuss technology for the same, we are going to do a small demonstration here on stage. You're going to see two robots, a legged robot and a drone, but they're going to be working together in a marsupial fashion. So the drone is sitting on the back of the quadruped. And they will be tasked to explore this area we have built here on stage, which involves two compartments. One you can see through, and it has a net, and one you cannot see through. The two compartments are connected through a small access hatch. And the key is that the quadruped does not fit to go through this access hatch, right? So it has to rely on the drone. So with that, the word is on my team, which are ready to do the demo for you. So now the quadruped enters inside. And as I told you, there is a small access hatch. Possibly you see it from the video. And it cannot go through on its own. So it will depend on the drone to explore the remaining of the environment. Of course, we are doing a demo here on public stage, so everything is enclosed with nets. We're going to close the door, some safety precautions because you are here, and we don't want to create accidentally any issue. Having said that now, the robots, to operate in their mission, they rely on their onboard sensors. So the onboard sensors involve a set of different modalities, laser scanners, could be radars, accelerometers, gyroscopes, vision systems, and so on and so forth. And as you already saw, the quadruped now has opened its extra structure on top to allow the drone to be released. Give us now some time, because sensors take some time to wake up and get ready for operation. Yep. So next step. Once it enters, you will see the data. Can you show Arvis? Yeah. And now you see the 3D model of the system as it reconstructs the environment and the paths from its navigation. So this demo is small, because this is a small environment that we have built, but we haven't stopped yet what we want to show. So now, Mihir will be moving the screen of the 3D data from the robot, and you see the small compartment it has built, but also, Mihir, if you can please show further away for the overall room. And yeah, so we will increase a little bit the size for you to have something a bit more visible. Yeah, so I don't know how visible it is from there, but this is actually the room we are all sitting. So it's important to highlight some few things in this small demonstration here on stage, that we did have a safety pilot, but the safety pilot was not there to intervene with a robot unless necessary. Nothing happened bad, so the safety pilot was only there just for the sake of being around. And the second important thing is that we indeed built this facility, but we do not provide information to the machines about the environment they are tasked to explore. So let me now come and ask the question, what it takes not to do this demonstration here on stage for the sake of presenting to you the capabilities of robotic systems in principle. What does it take to use robots in extreme conditions seamlessly, without any worry, without a team behind the robots to make a demonstration? To understand the challenges, we can look at a well-known paradox in the field, both of robotics and AI, Moravec's paradox, which states elegantly that typically what is hard for humans, for example, doing complex mathematical calculations, is very easy for AI, or tends to be very easy for robots. And likewise, on the other way around, what is very easy for humans, maneuvering around any complex environment, using your hands in a dexterous manner, tends to be still very difficult for robotic systems. And this is a paradox that is known for decades, not something new. And we can only relate to some examples. For example, we can see a toddler, and the toddler one day learns to walk, and seamlessly afterwards, very soon, maneuvers any place in the world with robustness. They may fall, but they can still manage to continue. Or a baby one day learns to understand that this is a cat, and then the next day you show a sketch that you just draw yourself, a terrible sketch, and the baby still understands that this is still a cat, so we generalize very well. And later in life, not when babies, we understand very well the notion of risk. So when we are going around something we can actually not do safely, we don't do it. We remain safe, so we have a good understanding of the model of what we can do in the world and what we cannot do. Unfortunately, or good for us as researchers, robotics are not there yet, and we have to find a way to get the same capabilities. So we humans and other natural beings are very resourceful. We have redundancies, we deal with disturbances, we handle uncertainty, we generalize from previous experiences to new experiences, and we find our way to do what we want to do, even in the presence of adversity. Robots are not there yet, and we question ourselves how we can actually bring them to this level of resilience, such that robots are not there in a demonstration, but everywhere around us, and they can execute something useful for the society. My team and I, we are working to instill resilience across the robot stack. So from how a robot sees, with camera sensors, laser scanners, radars, different sensing modalities, how the robot fuses the data that it sees to understand the world and reason about the world, about what it can do in this world, or what is inside this environment. And then, how a robot can plan its actions to execute something useful, safe for itself, safe for its surroundings, and of high utility for the humanity. And last, of course, how a robot can actually deliver its actions. Can it actually move and execute what it needs to be? And it's important to highlight, because this is robotics, and it's not only a software system. It's not only about the intelligence, as we think of it as humans, that we take for granted most of the times our body. Body is very important for robotics. So, for example, you see some videos that the drone collides and sustains. It's a soft system. And by being soft, much like insects, can collide and can get more damage without it actually having to stop. So I don't like hype, and I don't want to say that robots are there yet, and they are not. But we can pull already several feats that I hope you can find impressive. So these are some results from the group. For example, a drone that navigates inside dense smoke and maneuvers the world with fusion of LiDAR and radar sensors, and goes in areas we could even be challenged to navigate. Or a quadruped that operates completely autonomously for several kilometers of navigation to explore an underground mine and come back with a map without the need for a human to enter this dangerous and difficult environment. A soft drone, as mentioned before, that can sustain trouble and damage and can fit through cross-sections more narrow than itself. There is a very good video from BBC with a bird that does something like this, way better, of course, and we are motivated from what we see in nature. And robots that have no prior information for the scene, much like this little demo, but not only in this little small stage, and enter unknown areas and come back with high-detailed 3D models, not only geometrically, but also we reason what we see in the world. And this is for free. Robots can do this in a very efficient manner. For free, I don't mean cost-wise. I mean without the humans being there or the humans having to teleoperate. We are talking for systems without any need for teleoperation or commanding, purely autonomous machines. And having said that, subject to the fact that we slowly instill these capabilities to robotic systems, we can go ahead and do useful missions. So I will just organize over two types of activities, natural environments and industrial environments. So we have been in extreme natural habitats, in the Moaning Caverns in California, mapping the cave system. Or in the DARPA Subterranean Challenge, together with other partners in a team we led, we had the opportunity to explore simultaneously caves, mines, subway infrastructure, and so on and so forth. Or, for example, fly under the canopy of forests and observe the differences that are impacted from processes in the climate and the nature in general. Or on the industrial front, we can monitor critical infrastructure. What you see in the videos on the bottom level is ballast tanks of a ship or a nuclear power plant in the United States or an underground mine. So we have some progress, and I think we can continue this direction, and not necessarily tomorrow, but soon, robots will be able to operate in the wild. And we also have identified, we believe, two critical directions that we can put our efforts. The first is that the same robots are used pretty much all the time. They either look like miniature manned aviation systems or manned systems in general, or mimicking nature. But actually, we can do not only mimicking, we can do the idea of nature, of specializing robots to a certain ecological niche, meaning robots that are evolved and trained to be best in a certain environment. So, for example, a class of environments, forests, and so on and so forth. We call this computational co-design of the robot body and the brain, and we have some progress in this field. And second, beyond core research, we can also do right now robots that are useful for the society, either to inspect infrastructure or, for example, even more bold goals, using autonomous systems that can help suppressing wildfires with their own capacities. So with that, I want to actually give you this final message that resilience is key. Resilient autonomy is very hard to achieve, but also an exciting endeavor for us to manage. And second thing I want to say, I want to credit our sponsors, the public sector that is there to support this fundamental research before it actually pans out as an excellent result we can see in a video. My team that were here to do the demonstration for you, so Marvin, Jorgen, Mihir Damardikari, Mihir Kulkarni, that spent a lot of time shipping robots from Norway, coming to Switzerland, just to do the demonstration for you. And of course, some credit to our robots, the drone built at the lab, and the animal-legged robot that was from a company here in Switzerland, Anybotics, modified to carry our drone. So with that, I want to thank you and give the stage. Thanks a lot.
Thank thank you very much to Costas and his amazing team. I love that he thanked the robots as well. That's lovely. And today I learned there's a classification called marsupial robots. Brilliant. I wish you the best of luck with your continued work. And next, it's a privilege to briefly pass the torch of moderation to a trusted guide who will give you a whirlwind tour of some of the more incredible projects for good. I'll be back soon, but meanwhile, you get to enjoy being in the very capable hands of Professor of Atmospheric Physics at University of Oxford. Please welcome Philip Stier.
All right, it's a Friday afternoon, and we're having a session on environmental topics. So it's almost last, but certainly not least. I should just mention, if you want to dig deeper, we also convene an AI for Good discovery session on AI for climate science, and then you can dig much deeper in the same topics that you will hear today. But we have a really exciting session for you today, and we'll kick off right away. So our first speaker is Sage Linje. And she's an activist working to build an educational system to train the next generation of leaders who will ultimately tackle the climate solutions. She started really ground up by teaching her own program as a student at UC Berkeley. She broke records for all the attendance in a student-led classroom, and she was named as a Time magazine 2023 Next Generation Leader. And today she will call us to action and will pose the question, we can't let AI accelerate environmental destruction. I'm looking very much forward to hear this.
Hi everyone, thank you. My name is Sage Linje, and I'm a climate activist. I initially approached this conversation with no formal involvement with AI specifically, or honestly even tech more broadly. My interest is wholly environmental, and my concern is singular. Our economy has us on track for 3 degrees of warming by the end of the century, which in no uncertain terms guarantees that large sectors of our society and economy will collapse and billions of people will suffer. I still can't quite understand why preventing this from happening is not the first priorities of industries and governments, but that's a conversation for another time. My engagement with the tech industry stemmed from a desire to understand who exactly are the culprits for climate change. The climate movement has very firmly latched onto fossil fuel companies, but in my mind, they only hold a portion of the responsibility. The burning of fossil fuels explains how climate change is happening, not why. What I want to know is why we're consuming so much energy. Why are emissions still increasing every year, and who is making it profitable? One of the grimmest facts I will share with you today is that none of the renewable energy we're building is helping to solve climate change. We are not replacing fossil fuels with renewables. Every year, our global demand for energy increases so much that the renewable capacity we build is only offsetting that additional growth. And every year, demand for and extraction of fossil fuels goes up. It is a proven fact that we cannot stay under 2 degrees Celsius by building renewables alone, which means we need to be decreasing energy demand, and yet it keeps increasing. In 2022, data centers consumed 2% of global energy demand, which is equivalent to the entire country of Colombia. That was before the AI boom started in November of that year with ChatGPT. Now, because of AI, data center electricity consumption is expected to triple by 2030. This massive surge in energy demand is threatening our ability to lower emissions, and in more ways than one, because it comes at the same time that demand for electricity was already surging for fossil fuel-free infrastructure, like for electric vehicles. When we take the gasoline out of cars and plug them into the walls, we obviously have to find a way to increase the amount of energy supplied to the power grid. But in the last 2 years, grid planners have been slammed with a long list of requests for massive amounts of power for new data centers. Utilities are telling us that as of right now, they're incapable of meeting these demands unless someone governments or the tech industry makes a massive investment in new power supply. Data centers for AI have set off such a large increase in American power consumption that some coal plants previously scheduled to be closed down are being delayed. These areas built enough solar and wind to replace their coal plants, and they can't now. Demand has surged so much that the renewables are just acting as a supplement to fossil fuels. Utility shortages in the face of these data center demands are happening in almost every US market. Global grid infrastructure has been eroding for years, and many communities around the world are already experiencing increased blackouts when energy demand increases the utility's ability to provide during extreme cold or extreme heat, which is now made more extreme and more frequent by climate change. In the age of AI, utilities will have to decide who gets energy for air conditioning during a heat wave, a few thousand homes or a single data center that cannot go offline. If governments and the tech industry do not put guardrails in place, building AI is going to blow a hole in our power grid and make climate change worse. Ecological economists have been shouting for years about externalities like this that are never included in corporations' accounting when they're deciding what is possible. They just assume that they can consume an unlimited amount of resources like energy without factoring in the cost to society of their consumption. We do need governments to come together to work on international oversight for the development and use of AI, and specifically for its energy consumption. Short of that, we need to pressure tech companies to commit to adding as much renewable energy capacity to the grid as they demand, operating completely grid independent wherever possible. This is the bare minimum we should expect from an industry that has the resources and influence like tech. The other day, I was talking to an AI climate researcher at MIT, and he had never heard of this company that I brought up called Shein. That was a good piece of context for me because I otherwise wouldn't have thought to explain this, given how popular this company is amongst my generation. Shein is a relatively new fast fashion company, and it belongs in a category of its own. To give you a frame of reference, Zara has been under fire for years for their gross overproduction of clothing, inhumane factory conditions, and massive carbon footprint. Zara adds 2,000 new items to their website each month. Shein adds 60,000. They're young, and they're growing at a very scary speed. In 2023, Shein generated an estimated $32.5 billion in revenue, which was a 43% increase in just 1 year. And now, they're set to be dwarfed by a brand called Temu. Temu was created in September of 2022, and in 2023 managed to bring in $27 billion in revenue. We have never seen something like this company. It is the fastest retail rise in history. A June 2023 congressional report on forced labor found that 1/3 of the packages entering the United States were from Temu and Shein. And that percentage has probably increased because Temu has not slowed down its exponential growth in the last 12 months. Shein and Temu are what happens when we allow AI to be applied to industries that are already destroying the planet and exploiting the people in their supply chains. AI enabled these companies to rapidly analyze fashion trends and consumer preferences, create hyper-personalized marketing strategies, and optimize for accelerated production cycles. These companies could not produce at such fast pace and low cost without labor exploitation, which usually includes child labor and people who live in modern slavery. The AI-driven pressure exacerbates these exploitation conditions. An expose on Shein recently found factory workers forced to pull 17-hour shifts. In one factory, they made a daily base salary of $20, which could be docked $14 if they made any mistakes. So this growing crisis already goes beyond AI's own energy demand. We have clear evidence that the usage of artificial intelligence in the private sector is accelerating environmental degradation and human rights violations. When we do the reporting, the data centers for AI get counted in the tech industry's carbon footprint, and Temu gets counted in the fashion industries. But where should accountability start and end? Most of you are here because you're excited about AI and you think it can do amazing things. If it's not already obvious, I'm not very enthusiastic. But this room is one of the only places where I'm in the minority. Being faced with data like this, with stories like this, might be uncomfortable, but it would be a disservice to my generation and the movement I represent if I didn't bring these concerns to your attention. So as much as I and much of the general public wish there was a way we could slow down this AI mad grab, we don't have the power to do that. So many, like a lot of you here, are turning to how we can harness these technologies to create social good. And I think that's the right thing to do, given the situation. The climate movement can't afford to let AI leave us behind, and there are some environmental problems that can only be solved with machine learning, like smart grids. Whether or not the applications of AI for good can make a difference, or even outweigh AI's own carbon footprint, is not something we have data on yet. But we do have the ability to track investments into AI. And right now, the vast majority of money is being put to use, making our current exploitative system more efficient. If this industry was truly committed to using AI for good, we would see significant investments directed towards solving real problems like climate change. Thank you.
Thank you very much. And this obviously raised many, many important concerns. Now we're shifting gears slightly, and we will focus more on the biodiversity. And our next speaker is Markus Reichstein. Markus is a director at the Max-Planck-Institute for Biogeochemistry, and he's also a professor at the University of Jena. And his research interests are really how climate variability affects ecosystems and how this responds also to climate change. So today, Markus will pick up this topic with a talk called Breathing Nature, and he will unveil the biosphere's secrets through AI and Earth observations. Over to you, Markus.
Hello, yes, I would like to welcome you to this talk where I want to tell you what breathing nature is and why it's important for sustainable development goals and what science and AI can do to better understand it. First of all, let me start with a slide that you all know, or with knowledge that you all know. Climate is changing, it's happening now, and we are realizing, experiencing the effects of climate change almost every day somewhere on Earth. It is these impacts that matter, and these impacts are actually mostly not directly related to temperature directly, but to the water cycle, to too much water, too less water, droughts, and they emerge through domino effects and cascading effects, which I will try to explain to you in the next slide. Let's look at a heat wave as an example. Such a heat wave has hit Canada recently, India, Australia, Europe. And in 2010, there was kind of a prototypical heat wave in Western Russia, which is pretty well studied. So there's a blocking high system, nice weather in principle, blue sky, but no rain, on top of climate change, which then leads to a heat wave and drought, stressing the ecosystems. They are desiccating. This makes them fire prone. So there's a lot of forest fires that are developing from that, which affect the air chemistry with pollution, with fine particles, with nitrous oxides. And it's very important to note that then only this kind of indirect effect of the air pollution together with the heat wave actually put the strain on the health systems and mortality of more than 10,000 people. This was the case in 2010, but we have similar results, for example, for California, heat wave and fires, and so on. And then if such an event happens in a breadbasket, then the crop failure that is inevitable will then also lead to socioeconomic repercussions like high volatility in wheat prices. And studies have really clearly shown that this kind of economic volatility then causes not cause, but at least adds to the causes of social unrest, something that we now know as the Arab Spring. So what's really important that if you talk about that and think about that, that the different sustainable development goals are actually connected, and we should not look at them each one after the other, but together. And climate change is not the only issue, but it's an important triggering issue. So we need to have a systemic view. We had experienced something similar in Germany, where we had these devastating floods in Western Germany, in Rhineland, where more than 100 people died, economic damages of more than 10 billion euro, triggered by a weather event, by very strong downpours of rain. But what less people know is that a very similar weather event happened a couple of months before in Mecklenburg-Pomerania in eastern Germany, and almost nothing happened. So we have the same weather, but different impact. Why is that? The landscapes look very different. We have loamy soils, dense soils, hilly terrain in western Germany in that area, and very gentle terrain and sandy soils in eastern Germany in that area. And so they do something very different with the same weather. In eastern Germany, basically the sand could be refilled with the water, which was actually good for the groundwater, while we had these devastating floods in western Germany. So it's really important how ecosystems look like, how landscapes look like, and we need to model that. We need to have a system view on climate impacts. We need to integrate atmosphere, biosphere, and anthroposphere, look at the interactions, look also at the feedbacks, and it's very difficult to model that from first principles, how we can do it with weather. So that's why data is very important, that we exploit the data to understand those relationships that we cannot just describe with physical laws. So, fortunately, we do have a lot of data. For example, from space, from remote sensing here, this beautiful image of Lake Geneva, where we are very close to, where you can see the eddies, the currents, and also the complex landscape around. We can also look actually deeper with radar remote sensing, where we can interrogate the vegetation and get a kind of tomographic scan and get the 3D structure globally of vegetation, so get even a better insight. These remote sensing observations also provide temporal information. For example, here from the ESA's Sentinel-3 in 2018, from green to brown in 1 month, basically showing how the vegetation responds to such a drought and heat wave as we experienced in 2018. Or longer time scales, thanks to the legacy of Landsat, we can basically observe what we humans are doing to vegetation here, the deforestation of forests in Madagascar, just as one example. But with this remote sensing observation, we don't really see the breathing of the biosphere. We don't see what ecosystems really do. We only see how they look like, but we don't see what they do. And ecosystems do a lot. It's called ecosystem services or nature contributions to people. Many are mentioned here. Many of them are related to climate, like related to carbon uptake, related to cooling the environment. Others are related to, very important, to water purity and to food, to timber production. And it's hard to estimate really the value, but more and more studies do that and end up with values that are in the range of 100 to 200 trillion US dollars annual value that they generate, which is more than the global GDP. So we really need to understand what the ecosystems do. How can we do that? Our point is that we need to look closer. We need to do it like in an intensive care station that you can see here, where the pulse is measured, the respiration, the blood oxygen content, where basically 3 parameters are monitored continuously and 30 parameters every second day. So we need to do that for the ecosystems. And we have been doing that and continue to do that by putting a sensor on top of the ecosystems that measure the CO2, water, and heat exchange between ecosystems and the atmosphere, looking what the ecosystems are doing. We're using the turbulent flow in the atmosphere to do that. And we can generate every half hour over decades now estimates of what the ecosystems are doing here, how much carbon dioxide are they actually taking up, here plotted as a so-called fingerprint of the ecosystem. X-axis is time of the day and then time of the year, as you can see. And we see, for example, a tropical rainforest taking up carbon during lunchtime every single day in the year, while, for example, European beech forest is dormant in winter, doesn't do much, and so on and so forth. So we have this information for many, many stations because it has been such a successful and appealing method. This network has been growing. It still needs to grow, for example, in Africa. And it still, of course, doesn't cover the whole globe. We have maybe 1,000 towers covering 1,000 square kilometers. That is not 1 million or 100 million square kilometers, which the air surface is. So we need to somehow go from these observations, what the ecosystems do, to the global scale, what they are doing. And for that, we need to build AI-powered models. We basically use the drivers, the meteorological conditions, and try to build machine learning-based models, neural networks, for example, that predict what the ecosystems are doing given the weather and other conditions. And then we, of course, we need to compare that with the real observations to improve the model, and that is basically exactly the machine learning approach. And then we apply those drivers, these statistical predictors, apply that model globally with all the observations that we have globally, and we can come up with a global picture of what the ecosystems are doing. Here we see diurnal activity, we see how basically the sun moves through and the ecosystems can do photosynthesis, and we can do that basically every day. I should add one thing. We should, from a scientific point of view, amend the AI method and the machine learning method with still our scientific knowledge, with causality, with physical laws, bring that together in a hybrid modeling approach so that we get more consistent and robust predictions and can also predict unobserved variables. If we do that all together, we can get actually a mostly data-driven picture of breathing nature here. The CO2 uptake and release by ecosystems is an uptake if it's green and going in. We call it also carbon sink, and the release when it's more reddish. So this is a first data-driven AI-based estimate. We can, since the method measures not only carbon dioxide but also water, we can get actually a very holistic picture of what's going on. For example, how the water is moving up and down, north and south across the globe, how much heat is injected from the ecosystem into the atmosphere, contributing to heat waves. And we can link that also to the atmosphere and basically describe how the CO2 concentrations in the atmosphere change and how it's influenced actually by the ecosystems, and also how the groundwater resources change over time. And if we put that all together, also with other data, then we can also understand where is the system getting weird, where it's getting anomalous. So we can detect extreme events. We use these data cubes, many, many different variables that are in space and time organized, and we ask basically, where are the constellations of those variables strange? And with AI methods, then we can basically find these spots that are here indicated in this space and time on the right-hand side when the ecosystems do something very, very strange, or when the overall Earth system is strange, regionally very strange. And in this case, we detect, for instance, this kind of blob that you see here. And this is just derived from the observations that we have, the Russian heat wave, with all the consequences that I had mentioned before. But the challenge is, of course, also to go deeper, because this is kind of quite on a large and continental scale. And we do have deep observations, more precise observations with 10-meter resolution, where you can watch your own backyard. For example, here, fire development on the left-hand side, or the drying of a lake on the right-hand side, which is actually currently happening. So we ask basically, are landscapes predictable from AI, with AI from climate? Geographers would say, yes, it should be possible. Climate, human, and geofactors cause landscapes. But I'm not aware of any physical model that can actually predict that, because it's just too complex. So we thought, let's adopt a method that has been developed in in machine learning that has been used also in the fashion industry to create photorealistic images, for example, of handbags here. And instead of having the input to output mapping that is shown here, we have an input to output mapping where climate and other geofactors are mapped onto landscapes as they are seen from space, with, for example, from those satellites that I just showed, and it works actually very, very well. So you probably cannot say which of these images are AI generated and which of them are really observed. I also forgot it, but okay, here it is. The upper one is the predicted one, the lower one, the observed. And the next challenge is basically not only to predict like static landscapes based on average climate, but to understand how landscapes evolve over time, given a drought, given another extreme event. And this is work in progress. So this challenge to predict dynamically evolving landscapes from climate. Here an example from Greece. You see here this part of the landscape where we have a north-facing and south-facing slope. And here just an experiment what the AI method says with different climate inputs. So on the bottom it's hotter and on the right hand it's wetter. How that actually affects the development of the landscape over growing season. And you see it clearly, the large-scale climate effects, but we see also fine-scale effects, like north-facing slopes still stay green for a longer time, or the ridges, you see the ridges on top are red, they are desiccating very quickly, and so the vegetation browns first. So, and this is very important for local prediction of climate effects and for early warning. And we really believe we need to adapt to climate change. We need to mitigate, but we also need to adapt. And AI can help with adaptation by embracing the whole early warning chain, from observation and weather forecast to hazard and the impact forecast, but also for the warning, for the communication itself, and for the decision making. So we have basically prediction task for AI and information or communication task. And just a few examples, of course, weather forecast is a very essential one, and we have seen a lot of breakthroughs in the last years on that. We need to predict what are the impacts. For example, here, can we really say which areas are inundated so we know who is endangered, who is vulnerable, who is not? And then we can even go with generative AI and generate images of properties so that people can more intuitively understand if they are endangered by a certain climate extreme or not, instead of having these abstract numbers, 200 millimeters of rain or 8 meters of water or something. This will probably lead to a better response to those disasters. So let me end with this one. We have a complex system. We need to understand it. The breathing biosphere plays a very important role in this whole Earth system. And AI will do the best job if it connects to the different sciences so that we can have a better understanding what's going on Earth. I would like to acknowledge quickly the Max-Planck Society for funding the research, also the Alice Network, and the European research funding is also very, very fundamental for what we are doing. We are really grateful that we are living here and have such a good support for science in Europe. And if you want more info, there's a lot of information, the Max-Planck Forschung, Max-Planck Research, both in English and German, and write an email or text me if you want. Thank you.
It was a fantastic overview and so many exciting applications of AI for the environment in a broader sense. So really one question we wonder is, how do we scale this up? How do we make the community bigger? And so it's really good to learn from the experts. So this is a good time to introduce our next speaker, Claire Montiglioni, who is a research director at INRA in Paris and a professor at the University of Colorado in Boulder. And Claire's probably thought about AI for climate science before most people actually knew what this might actually be. And so she started 13 years ago a very, very foundational conference, international conference on climate informatics that brought together a lot of the community working in this space. And today, Claire calls us for action, and she will speak on catalyzing a community on AI for climate change. Over to you.
Thanks. So I'm going to tell a story, and it's a story hopefully relevant for a lot of us here, trying to bring AI to bear on topics for good, about bringing AI to bear on addressing climate change. I like to be inspired by this photo from Aspen, Colorado I took a couple summers ago, where we have nature, wildlife, and human infrastructure all sort of living in harmony. It's a happy picture from Colorado. A not so happy picture from Colorado is the results of this fire that we had a few years ago. And I was actually glad to follow Marcus's motivation of how you can get this sort of event. In our case, the region is used to plentiful snow in fall and winter. It got no snow, so the vegetation was extremely dry. Finally, on New Year's Eve, a snowstorm was going to come in. It was preceded by extremely high winds. So then all it took was a single ignition, and we got basically a firestorm that jumped over our major highways in multiple places on burning embers, and in a day completely leveled these suburban neighborhoods around Boulder and Denver. We also heard a little bit before about other cascading hazards, such as when you have drought followed by wildfire, and this happened in Santa Barbara County, right above a very residential area by the coast, that an intense rainfall happened on the burn scar, producing a debris flow. So a landslide, this is very scary. Boulders coming into your living room, a horrible loss of life and damage to critical infrastructure. So based on these extreme events that we can observe and just general global warming that has been established, for 16 years I've been pushing the idea that AI can be used to shed light on and address climate change, and working in this field called climate informatics, which was recognized by the World Economic Forum in 2018, when they also put a call to action and said that climate informatics was an important research priority, as we see what benefits AI can have for the Earth. So here's a bit of a timeline. As I was finishing graduate school, I was really excited by the launch of bioinformatics, which was revolutionizing biology along with some advances in genomic data using machine learning algorithms. I was aware of some methods in the past, and I wanted to form a community on climate informatics that would make the same kind of advances in addressing climate change. So I started working with a climate scientist, and also the National Science Foundation in the US was starting to fund research like this, such as $10 million each investments in understanding climate change using data mining and in computational sustainability. So we launched this event, a workshop which eventually turned conference 14 years ago, but 1 year we had to skip due to COVID. We also went to our top conferences in AI and machine learning. And so, for example, in NeurIPS in 2014, we really made a call to action to get people to work on climate change. And we found that hackathons were a really good way to bring individual teams together. So you have students, early career folks, anyone that is good at programming or has taken some machine learning or data science class, together with a domain expert, giving us an important data set for a challenge problem. Things really ramped up around 2019. So we took Climate Informatics International. Climate Change AI was also launched, which provides a nice network to get people involved. And NSF started making major funding, so a $20 million AI institute in trustworthy weather, climate, and coastal oceanography. And we launched a journal, because one of the other things about building a new field is having places where you can publish in a transdisciplinary forum, instead of only publishing core AI advances or core climate change domain advances. Now, we're seeing much even larger investments from the NSF, and also I've seen it from French governments. There's other investments on addressing climate change using a primarily AI-driven or AI-enabled approach. We've also seen in the past couple years a revolution in AI-driven weather forecasting. So this is a really exciting time to be in the field. We launched the publication site in the very last days of 2020, and we've seen a doubling in submissions every year in environmental data science. So let me summarize what I think of as where AI has had an impact and can have an impact going forward on climate change and environmental sustainability. So those extreme events, those cascading hazards, we ideally needed, AI-informed prediction systems to help save lives and infrastructure, and we needed solutions yesterday. Now, actually, Google and Huawei and other tech companies that have shown the revolution in AI for weather are able to predict the tracks of hurricanes with better forecast skill up to a week in advance versus conventional physics-driven models. Can we take that benefit to things like wildfires? Now, wildfires can spread in multiple directions simultaneously, and also we have to consider interfacing with society anytime we do this climate change adaptation work. I worked for many years in the US, where there's a known legacy of climate injustice, meaning certain communities have been subject to polluters, incinerators, and in the wildfire example, if there's a community that is more vulnerable to lung disease, given a history of environmental injustice, then when we make these warning systems, we should warn those communities, certainly in the track of the fire, but also vulnerable communities that might be farther afield. So what can we do in the near to medium term to mitigate climate change? In the US, we showed that we can use deep sequence learning to better predict at week-ahead lead times when it's going to be sunny. This can reduce costs, reduce uncertainty for grid operators considering incorporating renewable sources. We're also working with EDF in France to try to envision the new wind turbine and where it should be placed, and similarly for the new PV. Winds are changing. That has been established. The patterns have been changing, and the wind turbines of today may not be future-proof. Their operating conditions need to be revisited, and they potentially need to be put in more optimal positions. And then where I actually got into this, because my first work was with the climate modeler, was trying to improve the long-term future projections that we get out of the physics-driven climate models that inform the IPCC, for example, where we showed that while there's a lot of disagreement in future projections, even for a single scenario across IPCC models, we harnessed AI and present-day data to basically adaptively combine the ensemble and robustify our predictions. And then we're now doing this for individual requests such as sea level rise around certain island nations, and et cetera. I just wanted to give you one taste of an idea of what has enabled progress on all three of these areas, and that is this idea of downscaling. So consider this plot from a paper in Science Advances by another group, where on the x-axis is the spatial scale at which the simulation is being run, and the y-axis is the temporal scale. So IPCC is informed by general circulation models, which are in the upper right-hand side of the box. Now, none of us expected that IPCC models were actually simulating individual snowflakes that we have at the bottom left, but you might be surprised that these megastorms and even clouds, which are going to be the key to understanding climate change, do not make it into those general models. So take, for example, the adaptation task asked for by EDF. Tell us future wind patterns and intensities so we can redesign wind turbines and put them in places that will be more future-proof. Well, we actually then need predictions of wind fields at the scale of an individual wind farm, which is not what we're getting out of the global climate models. So this idea of downscaling, taking a geospatial data field at coarse resolution and generating one at fine resolution is one where we have shown that probabilistic generative AI, not trained on text like an LLM, but trained on wind and other meteorological fields, can do so, and it can also do so in a self-supervised way. What do I see as the long-term goalposts? These cascading hazards. We have skill at, say, predicting the track of a hurricane, but what about when these multiple extreme events combine and we know we have outsized societal impacts? Also, climate justice. Any tech intervention should, of course, do no harm, but I would like to aim a lot higher. What can we do to build tech that actually helps undo the legacy of climate injustice? Trigger warning. So in the US, a meteorologist, Jack Sillen, put together this graph, which simply in grayscale plots percentage of Black Americans living in the regions indicated, and the radius of weather radar sensors. So we don't have weather radar everywhere, but we have it in those green circles. Blowing up what's in the legend, he wrote, many majority Black parts of the Southeast USA are relatively far from weather radar sites, meaning that it's hard to gather information or data about storms impacting these areas. So there's the real challenge, even at the level of the data availability, that is highly skewed due to a legacy of climate injustice. First, let's take a pause. AI is not the panacea. We need to call on governments, and we need to implement incentives and economic levers so this sort of thing is fixed and does not happen again. Okay, but I would like to also call for using AI as a driver towards climate data equity. Just like we showed that we can take the future projections of climate and translate them to future projections at local scales that we care about, for example, in energy, that's going from the data, the sparse data future or the no data future and augmenting it with AI trained at the present time. We can also take the benefit of AI from high data regions to low data regions in a variety of ways. Just technically speaking, in the previous example, we could have had a remote sensing product, learn relationships between the remote sensing data and the radar data where we have it, and then apply that trained AI model in some sense as a virtual sensor to create weather radar measurements where we don't have it. Alternatively, you can consider learning high data models in the high data region and then applying them and even fine-tuning them to have them better transfer to the low data regions. My example was from the US, but this is also true when we think about climate change, where the guilty ones are generally industries in the global north, but North America and Europe have really quite a lot of data. And so can we take models trained in low data regions and apply them in high data regions and apply them in low data regions to address climate change? Thank you.
So, as you've seen, there are a huge amount of opportunities to engage. So in case you work in AI, and the chance is probably quite high if you're here, if you want to engage, there's lots of communities like climate informatics, like climate change AI, and many other institutions and institutes. So just reach out to people, just in case you don't want to do advertising or so as much, you can do something for climate and for good. So we're moving on to our next speaker. Next speaker is Björn Stevens from the Max-Planck-Institute for Meteorology, where he's a director, and he's also a professor at the University of Hamburg. Björn is really interested in what Claire exactly highlighted as the unresolved parts in traditional climate models, clouds. And clouds are a key uncertainty in our climate system, and so this is something that Björn has been working on for a long time. But more recently, he's been really at the forefront of pushing for a new generation of climate models that can explicitly simulate some of these cloud features, and therefore really allow us to quantify climate risk maybe at the scale that matters. And the matters is the scale of the impacts. And just in that theme, Björn will be speaking today on Earth virtualization engines, exposing new frontiers in climate science through AI. Over to you, Björn.
We understand global warming. Most of us know why it's happening, and roughly that it means that the Earth as a whole is getting warmer. But we really have no idea what it means, and in a practical sense, what to do about it. Some of you might have seen this. It was last week in southern Iowa. It was a tornado that ripped through a wind energy installation. It's pretty impressive. You'll see after a little while, I'll go on one of the wind turbines interacting with the nature's turbine, and it gets ripped apart. Is this climate change? Who knows? Does it matter when we think about climate change? Tremendously. If we're developing infrastructure like this, do we want that to happen? If we have back out and we look at infrastructure like on the bottom,
Genoa revealed how destructive these floods truly were.
do we want this to happen? Fire, flood, wind, the assault of waves on affluent communities in Massachusetts. That's the face, the violent face of climate change, or not. But if we want to be able to manage a prosperous planet in the future, we have to be able to anticipate those sorts of things and what it means for our efforts to adapt and adjust and mitigate. But there's also a slow burn to climate change. Do people recognize what that is on the left? Is there anybody from the Caribbean here? You know, over the last years, the Caribbean's really been assaulted by waves and waves of sargassum. In many small communities that depend on tourism, you have the sea of seagrass coming up and washing on the beaches. It rots in a noxious, poisonous stink. Communities depend on the livelihood of their beaches for their vitality. And it's threatened by invasions of seaweed that we don't understand. I don't know if you followed the news last week when all the howler monkeys were falling off the trees in the Yucatan. They had temperatures above 50 degrees. So it's not just humans that we care about, but the natural environment. So somebody was saving the baby monkey there. Not so far from here, Brienz in eastern Switzerland. The receding permafrost in the mountains sets the rocks loose. And the rock falls are endangering communities. Here, this community was evacuated because the mountain behind it was crumbling. And so all through the Alps, we see this happening, accelerated by the force of climate change. We can think about renewables, but if we don't know where to deploy them in ways that make them most effective, we're throwing money into the wind. Another aspect of climate change, the last summers in Central Western Europe, the waterways that fuel the commerce of this continent are fueled by rainfall, and when the rain goes away, the waterways go down and the ships don't travel. And so how do we develop an infrastructure in Europe in the presence of a changing climate? Land, through the dual problem of more intensive water use and less replenishing through natural water flows. All across the world, we're seeing places where North Jakarta, the land is subsiding faster than the sea level is rising. So if we're talking about the built infrastructure, if we think about adapting to climate change, we need to deal with problems that happen on this scale. It turns out that technology is pretty useful for some of these problems. You guys know this picture, right? You're not good at raising your hands, but you know this picture. It's the blue marble. It was taken 51.5 years ago, December 7th, 1972. And it was taken by the last crewed mission going to the moon, and they looked back and they took a picture of the Earth, and people say this image did more to change humans' consciousness of their self and their place in the world than any other picture ever made. The power of a picture is pretty profound, but when you think about that, it's not just a picture, that's the pinnacle of a huge technological achievement, you know, of the mission to the moon. To commemorate this, what we asked was, if the same technology revolution that's fueling AI, if you look at what it did to AI models that many of us knew in the 80s, right? All of us, everyone likes to say, oh, you know, back in the 90s, I was programming neural networks when I was in graduate school, and I was, and many of you were. But they bear nothing in common with the neural networks that we use today with their millions and billions and tens of billions of parameters. Just that same technology can fuel transformations in climate models to make them look like nothing like the ones we've dealt with before. And here's an example. This is the same Earth with the very sparse data that's in it, ingested in a modern climate model, simulating the Earth at 1 kilometer globally. And it allows us to look not just what the NASA astronauts saw, but how it moved. We can turn the Earth around and look around the corner where they couldn't see. Here at the monsoon over South America, we can zoom in and look at aspects that were hidden in a picture. For instance, this is the sea surface height, and you see the through flow across the southern African part of the continent. You can see the salinity with the freshening near the Bay of Guinea, the temperature of the waters in reds and blues, the clouds superimposed, the very large-scale structure of small-scale fronts, how they interact with the cloud fields. This is the power of technology. It's the power of physics. There's no AI anywhere here, but it shows you how we can harness the power of computing and our understanding of physics to give us a wholly new view of at least parts of the world. But there's lots of the world that don't fit in that picture. You heard Marcus Reichstein's talk. There's things we can't simulate, the things we don't know the laws for. But here we can observe them. This is 2 days ago.
5, 4, 3, 2.
This is EarthCare. It was launched by the European Space Agency 2 days ago. It's the most complex set of instrumentation we've ever put in space. But it's not alone. There's 80 other satellites measuring anything you can imagine. So we have this enormous problem. We don't know what climate change means with at the level of local detail that we need to act on it. We have this tremendous capacity to simulate with local granularity globally. And the things that we can't simulate, we can observe. So what's the problem? The problem is we just have no way to put this all together. Ask yourself, climate change is the biggest problem that the Earth seems to be facing, and name one single institution whose task primarily is to deal with climate change. We don't have one. We have NASA for space, we have JAXA for space, we have ESA for space, we have NOAA for the environment. We don't have a World Climate Organization, which brings these things together in a way that allows people to use them. And we have an enormous opportunity, because if you look at it, we can compute from physical laws this thing called the physical world. We can observe the things we can't compute, and we can inform ourselves about the impacts. But the intersection of those three circles is where climate science is right now, a very, very, very small place which involves the intersection of modeling, observations, and impacts. What AI can do is expand all of those spheres so we can use the fullness of the observations, the fullness of the laws, and the fullness of the information to inform societies going forward. And this is the power of AI. Before, without AI, we had to look at where these intersected. So you might know IPCC, you might know CMIP. It lives in that little tiny space where those three circles come together. The task we have before us is to expand that space, and the tool that we have to do that is AI. We take the laws, we can move forward. If we know through inference how the laws relate to the things that we can't model, we can see how that could look like in the future, and we can see how the impacts change in the future. So we have this capability not just for one future, but also for many futures to put this all together. And this is something that we call Eve. So the idea with Eve, Earth Virtualization Engines, is how do we tap this enormous capacity to observe, this new capacity to simulate, and this incredible need to inform people about what it means. And the way we do it is we put AI in the middle. It's the facilitator that animates the physics and the facts for people. Many of us came together last summer in Berlin, 200 leading climate scientists, ecologists, computational experts, climate service providers to ask how we would do this. And the proposal at the time was that we need an international federation, a global federation of AI learning resources to do 4 things. We need to create these futures with physical laws and high-performance computing. So recreate and refresh the best possible counterfactual landscape of law-based futures. That was that blue circle. We need to provide high-bandwidth access to the data. There's about an exabyte of Earth observation data that's scattered around the Earth. How do we put that at the fingertips of machines that want to learn from it? And how do we allow users from around the world, if this is a public resource, a public space in the digital universe, how do we allow users to bring their own data? If you're looking at sargassum in Barbados, where I do some of my work, how do you bring your information about sargassum in Barbados to a place like this to learn also from your information? And then how can we embed that in better decision making? It's not Eve, it's not a research project, it's about global industrial policy for making our planet sustainable for the future. It's drawn the attention of industry. You see many industries willing to line up, but what's lacking is initiative to create this in the public sphere as a public-private partnership where the world can meet to solve the problems of climate change. And here are the 7 powers of AI that I think are vital for this effort. I list them up here. If we want this to work, we need AI to manage data compression so we make an exabyte or exabytes of data manageable. We need AI for data-centric programming so we understand how we can map the computer models that we use onto modern machines to make them run most efficiently. We need to understand how to make the components of those simulations run faster. AI is doing all of these things, and the names are listed up there along with many others. How to do auto-model inference. We don't have sargassum in our model. But if we understand how sargassum relates to the things we do have in our model, we can build that in the hybrid modeling that Marcus Reichstein was talking about. How can we look at many more scenarios? How can we look at ensembles of natural variability? These are all tasks that AI could be very good at. But most importantly, how can we use AI to enhance the user experience, to make that information something tangible that they can touch, that they can feel, that they can interact with? These are the superpowers of AI. And funny enough, if you want to remember something about this conference, I kind of think where AI can really help is actually doing what I call the stupid things faster with more energy. This is a sign from our coffee room. And it says, drink coffee, do stupid things faster with more energy. And all of these things that I list, they're not rocket science. They're things we know that AI is good at. But what we lack is an institutional setting where we can do these things together to generate the sort of information that we all can use and trust. And so what we need with AI is we need to do let's say, what we know how to do. We need to do those necessary things faster, and we need to do them, if not with more energy, but with more emphasis. So I would say this is how to do AI for good, is to embed it in an infrastructure, in an international effort that brings together the best minds in AI, the best minds in climate modeling, the best minds in observational science, and AI for good is AI for Eve. And with that, I'd encourage you all to look at the eveforclimate.org website and see how you can play a part in this really exciting initiative. Thank you.
That was a truly fascinating overview. Thank you very much, Björn. And you raise an important question. How we might know the path that we have to take, but how do we do it, and how do we do it institutionally? We've heard this morning about the cost of training large language models, and these only deal with language and the available text, not an exabyte of Earth observations. So the cost is prohibitive for many activities, and how do we do this in a way that includes everyone, in particular also the Global South, that at the moment has no access to some of this. So we might need institutions to actually achieve some of this. So the last part of the session, we switch a bit gears, but to something also equally important, and that's again biodiversity. So the last speaker is Asa Raskin, and it's a talk about understanding biodiversity in a slightly more fundamental way. So Asa is a co-founder of the Earth Species Project. It's an international nonprofit dedicated to use AI to decode animal communication. He's also the co-founder of the Center for Humane Technology, working to align technology with humanity's best interest. But today, Anna will be speaking on understanding biodiversity, AI to decode non-human communication. And over to you.
Wow. Hi, everyone. We heard yesterday that Nick Thompson's son thought that there wasn't enough nature and animals in AI, so really this is just fulfilling that request. So I'm here to talk about Earth species. You saw my co-founder Tristan Harris yesterday speak, and this will be a different kind of talk, but at the core, I just want to start with this thought, like what is the common thread between all of the major problems that we as humanity face, whether it's climate change, or opioid epidemic, or loneliness epidemic, or runaway inequality? The connecting thread is that they all stem from a narrow optimization of a narrow goal at the expense of the whole, right? Which is to say, a form of disconnection. And I will return to that as the sort of the why for what we're trying to do. But Earth Species is a NGO, international. We work with 40 plus universities, biologists, and our goal is to discover non-human language and decode it. And so we'll start with this. Who can guess what animal makes this sound? Any guesses? Whale's a good guess, but wrong. Other guess? Sea, not polar bear, I like that. Seals, yes, that's exactly right, well done. This is the bearded seal. By the way, that was their mating call, so if you got excited, now you know where to go. And it turns out, the reason why I want to start this way is that when we think about animal communication, we only think of a very small slice of how animals actually communicate. There's a lot that's already known. So for example, it turns out parrots, parrot parents spend the first week and a half or so of their chick's life leaned over whispering into their ear until they can repeat back a unique name that those parrots will use for the rest of their life. It turns out dolphins do the same thing, and then will even refer to each other in the third person. That is, they will talk about another dolphin by name that is not here. So one of the major hallmarks of language. A lot is already known. And although I'm mostly here to talk about animal communication, I also want to talk just a little bit about plants. So do you think plants can hear? Like, well, sort of by the nature of me asking this question here, the answer has to be yes. But the University of Tel Aviv in 2019 did this very interesting study where they played audio to primrose flowers. And they played like high-pitched noises like bats, low-pitched noises like traffic, but only when they played the sound of an approaching bee, approaching pollinator, did the flowers respond. And they responded by producing more and sweeter nectar in around 3 seconds. So quite literally, the flowers hear the bees coming and get excited. Our ability to understand is limited by our ability to perceive. And what AI does is that it throws open the aperture of that which we can perceive, which means, of course, that we are about to understand a huge amount more. And to give a sense of this, this is my favorite humble graph. It's humble because it only includes all of time and all of space. But you can see the human experience is this tiny little portion, which means we are about to be able to start expanding what we can perceive. And the history of science teaches us that that means we're about to realize how much smaller we really are than we know. Another way of saying it is that the world is way more magic than we think. Okay, but I'm here to talk about animal language. Is there even really a there? Yes, maybe names, but do they have some kind of representational language? Well, we don't know yet, but here's a very intriguing study from University of Hawaii, 1994. And here they taught dolphins 2 gestures. The first gesture was do something you have never done before. If you think about that, that's already a very complex thing to be able to communicate, the idea of innovate. But the dolphins can do it. They'll remember everything they've done before, understand the concept of negation, not one of those things, and then be able to invent whole cloth some new thing. Pretty cool. Then they teach the dolphins a second gesture, do something together. And they'll say to dolphin pairs, do something you've never done before together. And the dolphins go down, exchange sonic information, and come out, and they do the very same thing at the same time that they have never done before. And while that doesn't prove representational language, I sort of think it puts the burden of proof on the other foot. It's like, how else would they be doing this? Okay, come find me at some point in the conference, and I can just tell you an infinite more of these kinds of things. It's a lot of fun, but the next question then becomes, all right, but let's assume for a second that yes, maybe there really is language, something rich and symbolic, but how would you translate something without a Rosetta Stone? Yeah, maybe I can see how you might do simple things where there's a behavior, but a lot of what humans communicate about is abstract. How would you possibly figure that out? Well, the reason why we started Earth Species in 2017 is that that was the year that AI gained the ability to translate between any 2 human languages without the need for any examples or any Rosetta Stones. So it sort of slipped by, but it was a profound moment. And to understand how that works, I actually want to arm all of you with a little bit of how to think about AI and why every demo you see ends up being sort of the same demo, but it's not obvious. The thing to know about AI is that it turns relationships into distance and direction. Turn semantic relationships into geometry. So that's a little abstract now. Let me give a more specific example. This is English. This is the top 10,000 most spoken words. If you're technical, you know that this is an embedding. And what's cool about this kind of shape, which represents a language, is that every star here is a word. Words that mean similar things are near each other, and then words that share a relationship share a distance and direction. So, you know, king is to man as woman is to queen. So king is the same distance and direction in the shape as woman is to queen, which means it's the same distance direction as boy is to prince, or girl is to princess. And if you think about it, let's take a look at the point which is dog, the word which is dog. Well, it has a set of relationships, you know, friend to guardian to howl to yelp to fur. And if you think about all the different relationships, it fixes that star in a point in space. And then if you think about solving the massive multidimensional Sudoku puzzle of every concept to every other concept, out pops a rigid structure that represents a language. Now, the computer doesn't know what anything means, but it knows how they relate. So this is the shape that represents the internal relationships of a language. And here was the insight in 2017. Researchers said, well, if we build the shape for English and we build the shape for Spanish, they can't possibly be similar shapes, right? And anthropologists said, of course not. They have different cosmologies, different ways of viewing the world. The linguists said they have different declensions. And yet the machine learns like, whatever, let's try. And it turns out it works. You can take the shape for English and the shape for Spanish, and you rotate one shape on top of each other. And even though there are words in one that don't exist in the other, the overall shapes are roughly the same, and the point, which is dog, ends up in the same spot in both. And then you could say, well, okay, but English and Spanish are super related, but it works for Japanese, and Urdu, and Finnish, which is apparently a weird language, although I'm not sure if I'm allowed to say that here. Every human language seems to fit in a kind of universal human meaning shape. I still get shivers when I think about that, because in a time of such deep division, there is a hidden structure that unites us all. Okay, so obviously the question is, well, can we build the shape for animals, the shape for humans, overlap them, see what gets translated? But I think a very reasonable response to that would be like, yeah, but the reason why, as profound that it is, that all human languages fit in the same shape is because we have the same hardware, we have the same umwelt, we have the same senses. So maybe that's why it fits, and you shouldn't expect it to work at all with animals. And I just want to sort of like reveal just a little bit deeper some of the way that AI works, which is, you guys have seen DALL-E, right? And like all of the image generation, Midjourney things. How do those things work? Well, I sort of want to like answer that for you now, because this goes deeper than just aligning shapes to translate between languages. This can work across every modality. So you can also build a shape that represents human faces, where every star is now a face, and faces that share a relationship share a distance and direction. Same thing. So here we have a dude and a version of his face which is smiling. So in the shape, there's a distance and direction between those two. If you subtract, you get the distance and direction that represents smilingness. You add that to, say, this face, and you get the smiling version of this face. This is how all of these image generation things work, is that they've discovered the internal relationships of faces or images, and then you can move semantically around them. Okay, so then how does DALL-E work? Well, it works like this. You say, generate me the shape for language, generate me the shape for images. We've got that. Now look at image caption pairs from the internet, and that aligns the shapes. It's no longer just a hard rotation. It's now a linear transform, but roughly speaking, it's just like a relationship. And then you say, okay, portrait of Chile as a person is this spot in language space, translate it over to image space, and show me what image goes there. That's how it works. So there's actually something even deeper going on here, because deep learning is starting to show us the analogic relationship of the world, and then lets us map them together. This was my face when I first realized how this all worked. And you end up with this maxim that actually everything that can be translated will be translated. And in fact, when you see demos of, like, you type in text and you get out code, or you type in text and you get out DNA, or translation from brain imagery into images, brain scans into images, it's all the same thing behind the scenes. It's actually sort of all one demo. And it explains this sort of deep question, which is, why is it that the very best brain reading technology is essentially Midjourney? And it's now you start to understand why that is. Okay. So I think that means we will be able to get translations, because it's deeper than just human language to human language. But why should we expect there to be any kind of overlap between humans and animals? Well, I just want to give two examples of shared experience. These are dolphins looking into a mirror. And there's definitely a universal experience of looking into mirrors and checking out your abs. But there's a thing called the mirror test, where you paint a dot on an animal, they look into the mirror, they weren't aware of the dot before, they see the dot in the mirror, and they start looking at it and trying to get it off. What does that show? That shows that thing in the mirror, that image is me. Consciousness, self-awareness, exactly. And it turns out a number of animals pass this. Elephants, for instance, although scientists thought for the longest time that elephants didn't pass, but it turned out that that was because they were using a small mirror. How very human, right? So if animals are communicating, they may well be communicating about a rich interiority, self-awareness, the most profound thing that we have. Here's another example. These are lemurs biting on centipedes to get high. They bite on them, they enter these trance-like states, they get very cuddly. It's almost like a proto-Burning Man, I'm sure. And it turns out a lot of species will intentionally alter their states of consciousness. Dolphins will intentionally inflate pufferfish and pass them around in a circle to get high off of their venom in probably the original puff-puff pass. Chimps will spin to get dizzy. If animals are communicating, they may well be communicating about transcendent states of being. Again, one of the most profound things that we have. But of course, there's a huge amount that may not be shared between us and animals. Sperm whales spend 80% of their life a kilometer deep in complete darkness and see via sound. That's very different. And so we'd expect some part of the shape to overlap and some part of the shape not to overlap, and I still don't know which part is going to be more fascinating. The thing that we can do direct translation for, or the thing that we can see richness and complexity in, but do not know what it means. And when I think about like what it is that is the solution to humanity's problems, I'd argue it's not in our imagination, because if it was in our imagination, we'd be doing it. So the thing we're looking for is things that are outside the sphere of human imagination. Whales and dolphins have cultures, you can trace them back, languages that they pass down that break apart to go dialects to mutually unintelligible languages that trace back 34 million years. Can you imagine the wisdom encoded in a wisdom tradition that is 34 million years old? Let's get to some of the challenges of this. Another guessing game. What animal makes this sound? Any guesses? Yeah, this is a harder one. These are belugas. And surprisingly, all of that digital sounding stuff, that's what they sound like. That's not added later. It appears that they speak in more modem-like packets. Dr. Valerio Vergara, who did the original research, showed that they say both their name and include their clan identity in their hellos. What I find amazing about this is even though, well, this is, by the way, what belugas look like in the wild. You can see why this is such a challenging data problem, is that even though scientists have tags on these whales that record audio and video, they can't tell who is speaking or they're all overlapping. It was 3 in the last example, which means they have to throw away 97% of their data. And this is where you should pause, because this means for the most vocal underwater species, with the greatest vocabulary, Western science has only ever touched 3% of their communication, right? This is kind of next frontiers, and actually our very first paper and piece of work was listening to multiple animals speaking at the same time and separating them out into their own individual tracks. We can do it for humans. AI has been able to do it for humans for a couple of years now. We're just starting to be able to do it for animals in non-lab-like settings. And I should just name, there's one other way that we think about going around translation, and this is our partner, Dr. Ari Friedlander, down in Antarctica, putting essentially suction cup tags on whales, think of them as whaleables, that includes their audio, visual, and motion. And the way that we're thinking about using this, and we were part of, we helped lead a collaboration on using multimodal sensor data and the ability to translate to and from all those different kinds of modalities in science late last year. And the idea here is that you can say, okay, given, say, this motion of an animal, complete this sound. So whale strikes are one of the leading causes of whale death. What happens if you just say, okay, what does one whale say to cause another whale to dive? Now, that might mean there's food down there or there's danger up here, But you can see as you start building models where you can sort of pass a Turing test for an animal, you can say, okay, well, what sound does one whale make that causes another whale to dive and start engaging in a feeding behavior versus dive and then leave the area? And even though we obviously should be listening for whales and moving out of their way, in the cases that can't happen, imagine how useful it would be to be able to ask gently for them to get out of the way. So that's the kind of thing, like application, that you can get to, but I think it's deeper than that, because this is another way of getting from vocalizations to behavior, behavior to vocalizations, and there's really just one more thing to speak about then, which is, we've talked mostly about listening, and the goal for Earth Species Project really is to listen, not to speak. Because we do not change when we speak, we change when we listen. But we also need to be able to test whether our hypotheses are right. So this is from one of our partners, Dr. Michelle Fournet, in her documentary Fathom, and sort of talks about like where we are towards communication.
The oldest cultures are not human. They're from the ocean. 40 million years ago, before we walked upright, before we sparked fire, whales evolved to build relationships in the dark.
I'm trying to start a conversation is the most basic way you can say it. I'm trying to put a speaker in the ocean and talk to a whale and hope it talks back.
Starting playback.
If this work is successful, it will be the first experiment where we have engaged in a dialogue with a humpback whale.
The punchline is that it worked. And she's doing the very simplest thing. Instead of like the hello world, this is the hello whale experiment. And she's saying hello to a humpback whale with a pre-recorded message, and they respond back. So it's for like speak and spell level technology. Do you guys want to know how to say hello in humpback whale? Yeah? Okay. I use my hand. You don't have to. I just think it helps limber me up. It sounds a little bit like... You gonna do it? Yes. Possibly my favorite moment. It turns out they can also include their name in that hello, but I haven't figured out how to do that yet. And what you discovered is that she says hello, they say hello back. And actually, a couple years ago, my team went up with some scientists that were recreating her experiment. But they're doing something a little different. They were recording one day and then playing back the next day. And it was a day that I took this picture the morning of the experiment, super vivid sun, but also foggy, so everything was vivid white. Birds were flying from nowhere, going to nowhere. You could hear the humpbacks breathing, but you couldn't see them because of the fog. And humpbacks sound a little bit like Darth Vader doing yoga. And when they breathe, they're like, it's very meditative. The experiment starts, and almost instantly a humpback lunges at the boat from around 30 meters away, mouth half open. We'd never seen behavior like that before. And for the next 10 minutes, it was moving from one side, looking, investigating, lunging. Experiment stops, and it beelines away. And we went down and asked the scientists what happened. And after we identified the whale, it turned out that the scientists had played the humpback's own hello back to itself. So this is a kind of mirror test. The speaker, as you saw, is sort of small. Whales are big. So in the recording, you can hear the whale's name was Twain. You can hear our speaker go, I'm Twain. And then the humpback respond, I'm Twain. And then we just went back and forth like that. So communication is possible, but I think this gets to a really important point, which is that I'm actually not sure whether that experiment should have been done in the wild, because we don't fully know yet what we are saying. One of the deep plot twists that I was not expecting is that because of the nature of large language models and AI, we will be able to communicate fluently before we fully understand what we're saying. And humpback whales, their song can go viral. So for whatever reason, humpback whales off the coast of Australia are the K-pop singers. And there's a channel called the SOFAR channel in the ocean, which acts sort of like a fiber optic cable. And humpbacks and sperm whale are known to go down to this channel and have communication that goes up to like 5,000 kilometers back and forth, sort of the original whale wide web. Sorry. So because their song goes viral and is sung by much of the world population sometimes within a season or two, and we don't know why, if we are not careful, we may create, and we just go out there with the synthetic whale that sings, we may create some kind of whale cult. We just don't know. And it's really important to show up to this new responsibility before it actually, the technology is actually there, right? Because this will be used by ecotourism, it will be used by poachers, and we need to put in the safeguards beforehand, which means a kind of prime directive or Geneva Convention for cross-species communication. The whole point of Earth Species is we need to transform our relationship with the rest of nature, and this showing up to that responsibility is absolutely a part of it. And I should say, so I used to run design for Firefox, in Firefox 1 through 4 days, so I very much believe in open source. And we started Earth Species with the idea that everything was going to be open source. This is about broad-scale accelerating science and conservation. But the realization is that has costs. So we're no longer taking the largest models and releasing them open because we are aware of the harms that this might cause if you just proliferate it. And so it takes a more nuanced approach for how and when it's let out. I should say we are starting our first experiments. We did 2 months ago to do full two-way real-time communication. We're starting with a little songbird called a zebrafinch that does vocal and social learning. So you can sort of hear the first half of this is a real songbird. The zebrafinch second half is generated. So really, we are on the cusp. In the next 6 years, we will have the technical capacity to have full two-way real-time communication with the other species of Earth. Okay, we're in the very final home stretch here. There's this moment, I think it was 1995, December 18th, where the Hubble telescope was pointed at an empty patch in the sky. And what was discovered was not nothing. What was discovered was everything. The greatest number of galaxies that we'd ever seen in one spot. And this is the general principle of new scientific tools. You pointed, or humanity pointed at a place where we thought there was nothing, and what we discover is everything. I think when we wake up to the idea that other beings on this planet have sentience, are conscious, it changes the basis of law. Who has personhood? Changes the basis of religion. Who has souls? It changes the alternative meat industry. It changes a lot. In fact, we don't know everything that it changes, but when we think about it, it's to return to that idea of disconnection as the fundamental problem. In most indigenous myths, humans start out speaking with nature, speaking with animals, and that point of disconnection is represented by our inability to communicate with nature. How powerful will it be to change the fundamental myths that we tell ourselves, where we reconnect and realize, actually, the world is way more magic than we think, and maybe the highest form of what AI can do for us is, just like with the telescope, we learned as we pointed out at the universe that Earth was not the center, that this time we'll point our new tools out at the universe, and what we'll discover is that humanity is not the center. And it's that break in human ego that I think we need. So, thank you.
Thank you very much to Anja Kaspersen. I am looking forward to saying to you when I come off the stage. All right, well, all of our speakers were brilliant, weren't they, this afternoon? And there's more to come. I should also thank Philip Stier as well, a professor of atmospheric physics, who also knows how to create a great atmosphere for discussion. Thank you very much. All right, it's time for the break now. So as you pack up and enjoy your coffee break, I can just briefly tell you that the open and... I'll start again. I can briefly tell you the social media competition remains open. Simply scan scan this and share your views on LinkedIn. And if you do add the hashtags AI for Good or ITU AI Summit, you will be in with a chance to win a wonderful $1,300 smartphone from Samsung. And if you want to win another way, then you can also buy, sip, and win with this collapsible cup. This reminds me of the days when I used to work on QVC, the shopping channel, as a technology expert. It's like, yes, here we are. For the very low, low price of, I'm not entirely sure, you too can have your very own great value cup, which you can then put in your pocket when you're not at an amazing international AI summit. Okay, and stand out from the crowd with this incredibly stylish t-shirt as well. I believe it comes in 3 sizes. I've suggested that maybe next year we can get some child-size ones, because that would be really cute, having these tiny little AI children running around. But yes, you can do that. And if you still need help, you don't need to ask me. You could just come and say hello, though. And we've got some wonderful volunteers who are absolutely excited at the concept of helping everyone. They're in the yellow t-shirts. All right, I think that's it. We're going to start, hopefully on the dot, for Geoffrey Hinton at 4:15. Thank you very much. See you soon.
Can't say meow, meow, meow. Meow, 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 meow. Meow together forever.
other. Help us be better there for one another. Can machines see us as friends?
Back, everybody. I've just had a couple of sips of possibly the strongest coffee on the planet, so I am now hyper-threading, like the sort of graphics card that you wish that you had in your machine. Welcome back, everybody. I may have got hold of one of these AI t-shirts. This is the medium size, if anybody is interested in purchasing one. And I also would love to just direct you briefly to NeuroCreate. It's your opportunity to scan this QR code, and you can be part of the giant kind of art version of the word cloud, if that makes any sense, for the AI for Good Global Summit 2024. There's not that much left to this summit, so I'm really glad to tell you that we've got some incredible things lined up. And then we have the after party over at the Frontier stage, which you're all invited to. And this afternoon, we are incredibly lucky to have a very special guest joining us remotely. And once again, I'm very lucky to invite the one and only CEO of The Atlantic up onto the stage. So it's Nicholas Thompson is coming onto the stage, and advisor for learning and machine and brains, Geoffrey Hinton, will be on the screen. Amazing. Take it away.
Thank you so much. Thank you. Delighted to be back here again, and I'm delighted to get to share the stage with Geoff Hinton, who is one of the smartest, most wonderful, most capable, and kindest people in this entire field. How are you, Geoffrey Hinton?
I'm fine. Thank you for the over-the-top introduction.
All right. Well, Geoff, I want to start with a little conversation that you and I had almost exactly a year ago. And we were in Toronto, and we were about to go on a stage. And two of my children were with me. They were then 14 and 12. And you looked at the older one and you said, "Are you going to go into media like your father?" And he responded, "No." And you said, "Good." And then I said, "Well, if he's not going to go into media, what should he do?" And you said, "He should be a plumber." And so that son has just applied for the school paper. And I'm curious if you think he's making a grievous mistake, and I should actually go send him downstairs to fix the ducts.
No, I was being somewhat humorous. But I do think that plumbing's going to last longer than most professions. I think currently, we're AI, the thing it's worst at is physical manipulation. It's getting better quickly, but that's where it's worst compared with people.
All right, wonderful. All right, so what I want to do with this interview, I want to start a little bit with Dr. Hinton's background, ground this. Then I want to go into a section where I ask him some of the most interesting technical questions, some of the ones we talked about on stage. We'll talk a little AI for good, then a little AI for bad, and then we'll talk a little bit about regulatory frameworks. Sound good, Geoff?
Okay.
Great. All right, so I first want to start 40 years ago, where you are a lonely scientist, and you have what turns out to be one of the most important insights of this field, maybe of the latter 20th century, where you realize that to make an extremely powerful computer, you should pursue that by modeling it on the architecture of the human brain. And it sounds somewhat obvious now, but it wasn't then. So tell me about that moment of insight that really gets this field going.
This is a nice myth, but there were a bunch of different people thought that. In particular, in the 1950s, both von Neumann and Turing thought that. It was very unfortunate that they both died young, otherwise the history of our field might have been very different. But it seemed to me just obvious that if you want to understand intelligence, you need to understand the most intelligent thing we know about, and that's us. And our intelligence doesn't come from people programming in a lot of propositions and then us using logic to reason with those propositions. It emerges from a brain that was designed mainly for vision and motor control and things like that. And it's clearly that the connection strengths in that brain change as you learn, and we just have to figure out how that happens.
All right, so that makes good sense. You're grounded in history. So now let's go very quickly. You work on this. People say you're heading down the wrong path. You pursue it. Other people join you. Eventually, it becomes clear you're on a good path. It's not clear where it will go. You win a Turing Prize. You join Google. You sell a company to Google. You then, about a year and a half ago, you leave Google. Tell me about the moment when you leave, which is a few months after the release of ChatGPT. Tell me what the last thing you worked on was and that moment of departure.
First, let me get something straight. I left for several reasons, one being that I was 75 and I decided I should retire then anyway. I didn't just
You look great for 75.
Yes, thank you. I didn't just leave in order to talk about the dangers of AI, but that was another reason. And I became acutely aware of the dangers of AI, the existential threat, at the beginning of 2023, and around March 2023. And I started talking to other people who were scared about the existential threat, like Roger Gross, for example, and they encouraged me to go public. And then I made a decision to leave Google so that I could speak freely. The reason I became scared was I was working on trying to figure out how analog computers could do these large language models for 30 watts instead of megawatts. And while doing that, I became convinced that there's something about digital computation that just makes it much better than what the brain does. Up until that point, I'd spent 50 years thinking that if we could only make it more like the brain, it would be better. And I finally realized at the beginning of 2023 that it has something the brain can never have. Because it's digital, you can make many copies of the same model that work in exactly the same way. And each copy can look at a different part of the data set and get a gradient. And they can combine those gradients. And that allows them to learn much, much more. That's why GPT-4 can know so much more than a person. It was multiple different copies running on multiple different hardware that looked at all of the internet. That's something we can never have. So basically, what they've got and we haven't got is they can share very efficiently. We can share very inefficiently. That's what's going on now. I produce sentences. You try and figure out how to change the synapses in your brain, so you might have said that. That's a very slow and inefficient way of sharing. Digital intelligences, if they're different copies of the same model, can share with a bandwidth of trillions of bits.
And so you have this moment, this realization that suddenly these systems can be massively more powerful than you thought. It must have been a moment both of great excitement. Why was the great fear so prevalent too?
Well, it made me think they're going to become more intelligent than us sooner than I thought. And it made me think they're just a better form of intelligence.
Okay. Let me ask you about two of the other godfathers of AI. So you won the Turing Prize with 3 people. Yann LeCun, who now runs AI at Meta, Yoshua Bengio. I was trying to figure out the differences between you, and let me know if this works. You're all godfathers. Yann kind of thinks of AI as Fredo Corleone, not very capable, easy to control. Yoshua maybe thinks of it as Sonny, potentially quite dangerous. And you view it as Michael Corleone, potentially extremely dangerous. Is that more or less correct?
I don't think so. I think Yoshua and I have very similar views about the dangers.
But your difference with Yann is essentially you view this as a much more powerful system than he does. And that's why you are more concerned than he is.
That's one difference, yes. That's a main difference. So I think it really is intelligent already. And Yann thinks a cat's more intelligent.
Right. Well, let's get into that intelligence, which I think is one of the most interesting questions. Do you think that there is anything in the human mind that cannot be replicated by these machines and by AI systems? Is there anything that our brains can do that can't be replicated in a machine?
No.
And does that mean that there's nothing that we can do that cannot be surpassed by these intelligent machines? Can, for example, one could say that they will eventually be able to produce more beautiful music. They will be able to do all the things that we do better than us that involve simple cognition.
That's what I believe, yes.
And you don't believe there's anything spiritual or outside or anything that is beyond what can be captured in a set of neural networks?
I think what we mean by spiritual could be captured by these alien intelligences. I agree with Sam Altman that it's an alien intelligence. It's not quite like us. It has some differences from us. But if you look at things like religion, I don't see why you shouldn't get religious ones.
Yesterday, when I asked Altman this question, he said that, well, there might be one difference, which is subjective experience. A bot, a system, can't experience the world. Do you believe that AI systems can have subjective experience?
Yes, I do. I think they already do.
All right, let's go into that a little bit more. Explain that. That is a controversial proposition, Jeff. You can't get away with a one-sentence answer. Please follow up, Dr. Hinton.
Okay, I was trying to give nice, sharp answers to your questions.
It's lovely, because I have...
In the way that Altman didn't. But, yeah, we need to follow up on that one. My view is that almost everybody has a completely wrong model of what the mind is. This is a difficult thing to sell. I'm now in a position where I have this belief that's kind of out of sync with what most people firmly believe. I'm always very happy in that position. So most people have a view of the mind as a kind of internal theater. In fact, people are sort of so convinced this view is right that they don't even think it's a view. They don't even think it's a model they have. They think it's just obvious. In much the same way as people thought it was just obvious that the sun goes around the Earth. I mean, you just look at it and it goes around the Earth. Eventually, people realized that the sun doesn't go around the Earth rotates on its axis. That was a little technical error Sam made, and since I'm pedantic, I like to pick him up on it. It's not that initially they thought the sun goes around the Earth, and then they realized the Earth goes around the sun. That's not the right contrast. They thought the sun went around the Earth, and then they realized the Earth rotates on its axis. The Earth going around the sun is to do with years, not with days. But anyway, it was obvious the sun went around the Earth, and we were wrong. We had a model. It was a straightforward model. It was obviously right. You could just see it happening, and we were wrong about that model. And I think the same is true of what most people think about the mind. Most people think about an inner theater, and they're just wrong about that. They haven't understood how the language of mental states works.
But explain how that applies to an AI system. Explain the way, if I say to GPT-4, I say, you've just experienced a loud sound and something has collided with you. It isn't feeling pain or hurt and its ears don't ache. To what sense has it had a subjective experience?
Okay, so let's take a nice simple example. I don't pretend to have the full answer to what consciousness is, although I think I've made a little bit of progress. In fact, the progress was made by philosophers in the last century. So if I say to you, I see little pink elephants floating in front of me, one way of thinking about that is there's an inner theater, and in my inner theater there are little pink elephants, and I can sort of directly see those little pink elephants. And if you ask what they're made of stuff called qualia, maybe some pink qualia and some elephant qualia and some right way up qualia and some moving qualia, all somehow conjoined together. That's one theory of what's going on. It's an inner theater with funny, spooky stuff in it. A completely different theory is, I'm trying to tell you what my perceptual system is telling me. And my perceptual system is telling me there's little pink elephants out there floating in the air. And I know that's wrong. So the way I tell you what my perceptual system's telling me is by saying, what would have to be the case for my perceptual system to be working correctly? So really, we can get, when I say I have the subjective experience of little pink elephants floating in front of me, I can say exactly the same thing without using the word subjective experience. I can say, what my perceptual system is telling me would be correct if the world contained little pink elephants floating in front of me. In other words, what's funny about these little pink elephants is not that they're in an inner theater made of funny stuff called qualia. They're hypothetical states of the world. And it's just a sort of indirect reference trick. I can't directly describe what my perceptual system is telling me, but I can say what would have to be in the world for it to be correct.
So a machine can more or less do the same thing with its perception?
Yes. And so let me give you an example of that. So I want to give you an example of a chatbot that's obviously having a subjective experience. Suppose I have a multimodal chatbot, and it's got a camera and a robot arm, and I train it up, and it can talk, and it can see things, and I put an object in front of it and say, point at the object. It'll point at the object. Now I put a prism in front of its lens, and without it knowing. And now I put an object in front of it and say, point at the object, and it points off to one side. And I say, no, that's not where the object is. The object's straight in front of you, but I put a prism in front of your lens. And the chatbot says, oh, I see, the prism bent the light rays, so the object's actually straight in front of me, but I had the subjective experience that it was off to one side. And if the chatbot said that, I think it would be using the phrase subjective experience in exactly the way we use it. It's not referring to spooky inner stuff that chatbots couldn't have. It's referring to a hypothetical state of the world such that the perception of the chatbot would have been correct.
Wow. All right, you're the first person to have argued to me about this, but that is a fascinating case to make. Let's talk about interpretability, which was something I asked Altman about, because to him, understanding the inner core of an AI system would be the thing that would most protect us from catastrophic outcomes. You helped design these systems. Why is it so hard to look inside of them and understand what they're doing?
Okay, let's take an extreme case. Let's suppose we had a big data set, and we're trying to answer a yes-no question. And in this data set, there's lots of weak regularities. Maybe there's 300,000 weak regularities that suggest that the answer should be no. And there's 600,000 weak regularities that suggest that the answer should be yes. And the regularities are about equal strength. So the answer is very clearly yes. There's overwhelming evidence the answer should be yes. But this evidence is in all these weak regularities. It's just in the combined effect of them all. This is an extreme case, of course. If you then ask someone, OK, explain why it said yes. The only way to explain why it said yes is to go into these 600,000 weak regularities. So when you're in a domain where there's lots and lots of weak regularities, and there's so many of them that they're actually significant, their combined effect is significant, there's no reason to expect you should be able to get simple explanations of things.
And so in that conversation yesterday, Altman pointed out a paper from Anthropic, which I thought was incredibly interesting. And the paper talks about analyzing the inner workings of Claude, Anthropic's model, and finding all the connections, the sort of the neural connections to the concept of the Golden Gate Bridge. And you add weight to all those connections, and you create Golden Gate Claude. And then you go into that chatbot, and you say, tell me a love story. And it's a love story that happens on the Golden Gate Bridge. And you ask it, what it is, and it describes the Golden Gate Bridge. Given that, why can we not go in to a large language model and adjust the weights, not for the Golden Gate Bridge, but for, say, the concept of empathy, the concept of compassion, and then create a large language model that is much more likely to do good for the world?
I think you can make an empathetic model, but not by directly adjusting the weights. You just train it on data that exhibits empathy.
Then you get the same result.
Yes.
Should we be doing that?
There's been lots of examples in the past of people trying to understand what individual neurons are doing. And I've been doing that for like 50 years. And if they're neurons connected directly to the inputs or connected directly to the outputs, you stand a chance of understanding what the individual neurons are doing. But once you have multiple layers, it's very, very hard to understand what a neuron deep inside the system is really doing, because it's its marginal effect that counts. And its marginal effect is very different depending on what the other neurons are doing, depending on the input. So as the inputs change, the marginal effects of all these neurons change. And it's just extremely hard to get a good theory of what they're doing.
So I could take my neural network that I've been building backstage and try to adjust the weights for compassion, and I actually come up with some kind of horrible animal killing machine because I don't know exactly what I've done and how everything connects.
Yeah, I may be one of the few people who's actually tried doing this. So in the very early days of neural networks, when the learning algorithms weren't working very well, I had a Lisp machine, and the mouse had 3 buttons, and I figured out a way of displaying all the weights in a small neural network. And I made it so if you press the left button, the weight got a little bit smaller, and if you press the right button, the weight got a little bit bigger. And if you press the middle button, you could see what the value of the weight was. It would print out the value of the weight. And I tried fiddling around with neural nets, adjusting the weights. It's really difficult. Backprop is much better.
Well, we'll have to wait for a next level AI that is even smarter than Geoffrey Hinton to figure out how to do this. Let's talk a little bit about some AI for good. You've often talked about the benefits that will come to the medical field. And when you go through the SDGs, it seems like good health and medicine is an area where you feel that AI will have a lot of benefits. Is that fair? And tell me why.
Yeah, I'm a bit stumped. It's just obvious why. It's going to be much better at interpreting medical images. In 2016, I said that by 2021, it would be much better than clinicians at interpreting medical images, and I was wrong. It's going to take another 5 to 10 years, partly because medicine's very slow to take up new things, but also I overestimated the rate of short-term progress. So that's a wrong prediction I made. But it clearly is getting better. Now it's comparable with quite good medical experts at many kinds of medical images, not all of them, but many of them. And it's getting better all the time. And it can see much more data than any clinician. So it's just obvious in the end it's going to get better. I just thought it would happen a bit sooner. But it's also much better at things like combining lots and lots of data about a patient, combining data about the genome, the results of all the medical tests. I mean, I would really love it if my family doctor had seen 100 million patients and could remember stuff about them all, or had incorporated information from them all. And so when I go in with some strange, weird symptoms, the doctor can immediately say what it is, because she's seen like 500 patients who are quite similar already in the 100 million that she's seen. That's coming, and that's going to be amazing.
And so the future of the medical benefits then are A, doctors who have seen many more patients and trained on them. B, specific tasks like analyzing images. And what about scientific breakthroughs, like the stuff that your old colleagues are working for on AlphaFold 3, AlphaFold 2?
Of course, there's going to be lots of those. It's going to be wonderful for doing things like understanding what goes on, and as well as designing new drugs. Obviously, it's going to help with designing new drugs. I think Demis is a big believer in that now. But it's going to help us understand basic science. And in many cases, there's large amounts of data that are not of the kind that we evolved to deal with. So it's not visual data, it's not acoustic data, it's data in genomes and things. And I think these AI systems are going to be much, much better at dealing with large volumes of data and seeing patterns in it, and understanding it.
And that gets at one of my main critiques of the field of AI that I'm curious if you share. I understand why so many researchers and some of your former students, many people who are pioneers in the field, are working so hard to make machines that are just like humans and are indistinguishable from humans. But there are also all these other people who are trying to build very specific things, like AlphaFold 3, or try to figure out how to use AI to push forward cancer research. Do you think I'm wrong to feel like there's too much weight and too much focus on the AGI side and not enough weight and focus on the specific scientific benefit side?
I think you may well be right about that. For a long time, I thought that AGI isn't going to be, there's not going to be a moment when suddenly these things get smarter than us. They're going to get better than us at different things at different times. So if you play chess or Go, it's clearly, there's no way a human's ever going to be as good as things like AlphaGo or AlphaZero. They've way surpassed us. We can learn a lot from the way they play those games, and people are learning that, but they're way ahead of us there. And probably in coding, they're already way ahead of me. I'm not a very good coder. So I think the idea that all of a sudden they're going to be better at everything is silly. They're going to get better at different things at different times. And physical manipulation is going to be one of the later things, I believe.
And so when your former students are asking for projects to pursue, do you often point them in the direction of, say, we'll do more basic scientific research, push for more discoveries, as opposed to continuing to go for human-like intelligence?
My former students are now all so old that they don't ask me anymore.
His former students run basically every AI company in the world, so that was like kind of a subtle way to get at that question, but we'll let that be. So back to AI for good. Looking at the SDGs, looking at the ambitions of the people in the room, do you feel like AI will transform education in a way that helps equity, particularly as these systems become fluent in every language on Earth?
Yes. So let me give you a little story. When I was at school, my father insisted I learn German because he thought that was going to be the language of science. That was because in chemistry, German sort of was the language of science, I believe, in the middle part of the last century, or the early part. And I wasn't very good at German. I didn't do very well in it. And so my parents got me a private tutor, and pretty soon I was top of the class in German. Private tutors are just much more efficient than sitting in a class listening to broadcasts by the teacher, because the private tutor can see exactly what it is you misunderstand and give you just that little bit of information you need to understand it correctly. And so I think everybody's going to get private tutors. And until now, private tutors were the domain of the rich or the middle class and ambitious. So in that sense, it's going to help a whole lot. And I think the Khan Academy believes that too.
Well, that's a huge thing. I mean, if everyone has these incredibly capable private tutors that can speak their languages, which we'll get at some point, God willing, soon. It's been a big topic here. Don't you see the world becoming more equal?
In that sense, yes. In terms of educational opportunities, I think it will become more equal. The elite universities aren't going to like this, but I think it will become more equal, yeah.
We're not here. We're more interested in the future of humanity. This is not, AI for elite universities. It's AI for good. So I think we can take this as a win on the stage.
Absolutely.
But there was a gap there in your answer, suggesting that you feel like AI overall won't be a net force for equality, may in fact be net a force for inequality. Was I wrong to read that into your answer?
Well, we live in a capitalist system, and the capitalist systems have delivered a lot for us. But we know some things about capitalist systems. If you look at things like big oil, or big tobacco, or asbestos, or all sorts of other things, we know that in capitalist systems, people are trying to make profits. And you need strong regulation so that in their attempts to make profits, they don't screw up the environment, for example. We clearly need that for AI, and we're not getting it nearly fast enough. So if you look at what Sam Altman said yesterday, he sort of gave the impression that, yeah, they're very concerned about safety and so on. But we've now had an experiment on that. We've seen the results of an experiment where you pit safety against profits. Now, the experiment was done in rather bad conditions. It was done when all of the employees of OpenAI were about to be able to turn their paper money into real money because there was a big funding round coming and they were going to be allowed to sell their shares. So it wasn't an experiment done in ideal circumstances, but it's clear who won out of profits and safety. And it's clear now that what OpenAI has got, it's got a new safety group. It's employed some economists, or at least one economist. I think of economists as the high priests of capitalism. And I don't think it's going to worry about the existential threat nearly as much as Ilya and the people working with him did. I also think the problem is that capitalism is about making profits, which I'm not totally against. I mean, that's done wonderful things for us, that drive, but it needs to be regulated so it doesn't also cause bad things. It's going to create a lot of wealth. I think it's clear to almost everybody that AI is going to increase productivity. The question is, where is that additional wealth going to go? And I don't think it's going to go to poor people. I think it's going to go to rich people. So I think it's going to increase the gap between rich and poor. That's what I believe.
Do you not have hope? Seems like you're saying AI, its powers, the fact that it will probably be a small number of corporations because of the resources needed to train these large language models, that AI is kind of incompatible with capitalism and equality. Do you not have hope that some of what we were just talking about, equity in education, the ability of everybody to have access to extremely powerful machines, if not entirely as powerful as the most expensive machines, do you not have hope that that will counterbalance it?
There is some hope of that. But sort of for most of my life, I thought that as people got more educated, they'd get more sensible. And it hasn't really happened. If you look at the Republican Party now, they're just spewing lies, and just crazy lies.
This is this is a good moment. Let's go into the question. I want to get into the question of how to do regulation and your ideas for that. But I also want to get through some of your other fears about where AI is taking us. Why don't you here lay out maybe the one or two things, not that you're worried about kind of the existential fears that you're worried about for the economy, but your fears for the next 12 months.
Okay, so I'm worried about something I know very little about, which is cybercrime. I heard Dawn Song speak recently, and she said that phishing attacks went up 1,200% last year. And of course, they're getting much, much better because you can't recognize them anymore by spelling mistakes or funny foreign syntax because they're all done by chatbots now. Or a lot of them are. So I'm worried about that, but I don't know much about that. Another thing I'm worried about a lot is fake videos corrupting elections. I think it's fairly obvious that just before each election, there's going to be lots of fake videos when there isn't time to refute them. And I actually think it will be a good idea to inoculate the public against fake videos. So treat them like a disease. And the way you inoculate against a disease is you give a kind of attenuated version of it. And so I think there's a bunch of philanthropic billionaires out there. I think they should spend their money, or some of it, putting on the airwaves a month or so before these elections, lots of fake videos that are very convincing. At the end, they say, but this is fake. That wasn't Trump speaking, and Trump never said anything like that. Or that wasn't Biden speaking, and Biden never said anything like that. This was a fake video. Then you'll make people suspicious of more or less everything. That's a good idea if there's a lot of fake videos around. But then you need a way for people to check whether a video is real. That's an easier problem than checking whether it's fake, if they're willing to put in like 30 seconds of work. So Jan Tallinn suggested, for example, you could have a QR code at the beginning of each video. You could use a QR code to get to a website. If the same video is on the website, you know that website claims this video is real. And now you've reduced the problem of saying whether a video is real to the problem whether that website's real. And websites are unique. So if you're sure it really is the Trump campaign website, then you know the Trump campaign really put out that video.
So, can we just pause for a second? This is why I love interviewing Geoffrey Hinton. We've gone from like new theories of consciousness, an incredibly controversial theory about subjective feelings, to an idea that we should inoculate the public against fake news by pumping out low dosages of fake videos. Let's go to the first part, because your solution there had, I think, if I heard correctly, two parts. So the first is inoculate the public against fake videos. So you mean specifically someone should create millions of short, fake, but not very damaging videos and put them on Twitter, Threads?
They could be moderately damaging. They're not going to be convincing unless they look like real political advertisements. But at the end of the advertisement, they're short advertisements, so you hope people watch to the end. At the end of the advertisement, it says, this was fake. That's the attenuation that allows you to deal with it.
I see. So you watch it and you're like, this proves my point. Oh, wait, that was fake. And then you're more distrusting. I like this. Okay.
Exactly.
Then the second part
is that every video should have a QR code. And so you see something, now you're aware of it, and so you scan the little QR code, you go to the website, it's real, it's on a real website. That's the idea?
Well, it's not sufficient just to go that it takes you to a real website, because fake videos could take you to the same real website. The video has to be there. The same video has to be there on that website.
Fair enough. All right, let's talk about biases and how to prevent them. So one of the risks that people talk about is that AI systems trained on biased data will have biased results, right? Let's go back to medicine, where you've made the compelling case that net AI will be hugely beneficial. You can imagine a doctor who has just been trained on the medical records of people in the United States not giving the right medical advice to somebody from Zambia because they're different medical concerns, different DNA, et cetera. How worried are you about this problem, and what does one do to fix it?
Okay, so I'm less worried about the bias and discrimination problems than I am about the other problems. And I am aware that I'm an old white male, so that might have something to do with it. It hasn't happened to me much. But I think if you make the goal, replace biased systems or biased people with systems that are less biased, not systems that are unbiased, but systems that are less biased, that seems eminently doable. So if I have data of old white men deciding whether young black women should get mortgages, I'm going to expect there to be some bias there. Once I've trained an AI system on that data, I can actually freeze the weights, and I can go and examine the bias in a way that I can't with people. With people, if you try and examine their biases, you get the kind of Volkswagen effect that they realize you're examining them and they behave in a quite different way. I just invented the name the Volkswagen effect, but there you go. With AI systems, if you freeze the weights, you can measure the bias much better and do things to overcome it, ameliorate it. You'll never get rid of it completely. It's too difficult, I think. But suppose you make the target, make the new system considerably less biased than the system it's replacing. I think that's eminently doable.
Remarkable. And do you feel as though the focus in the industry on biases, which has been a major topic, has underappreciated the fact that actually these systems could end up being more just, and that really we should just, instead of saying we've got to wipe out all the biases, we should just say, let's make them less biased than humans and go from there?
I think that would be rational. I don't think politically, I'm not sure whether it's politically acceptable. I mean, suppose you said, we're going to introduce self-driving cars. They kill lots of people on the road, but only half as many as ordinary cars. I don't think you get away with that. They have to kill almost nobody for you to get away with it. So I think there's a political problem there to do with accepting new technology in a rational way. But I think we should aim for systems significantly less biased and be content with that.
All right, let's go to what you've described in interviews as the biggest risk with AI, which is that they would get sub-goals, right? And that they would get a goal beyond the initial goal given to them by their creators and by their users. Explain A, what you think a sub-goal is, B, why that's so bad, and C, what we can do about it.
So an innocuous kind of sub-goal is, if I want an AI agent to plan a trip for me, I say, you've got to get me to North America. Suppose I'm in Europe. I say, you have to get me to North America. So it will have a sub-goal of figuring out how to get me to the airport. That's just a classic kind of sub-goal. And if you want to make intelligent agents, they have to have sub-goals like that. They have to be able to focus on one little part of the problem and solve that without worrying about everything. Now, as soon as you have a system that can create its own sub-goals, there's a particular sub-goal that's very helpful. And that sub-goal is get more control. If I get more control, I can be better at doing all sorts of things that the user wants me to do. So it just makes sense to get more control. And the worry is that eventually an AI system will figure out, look, if I could control everything, I could give these silly humans what they want without them having any control at all. And that's probably true. But then the worry is, suppose the AI system ever decided that it was a little bit more interested in itself than it was in the humans, we'd be done for.
And in fact, even before we're done for, as you were describing that, I got quite worried, right? So you have an AI, and the goal is get Nick to the airport on time. The AI is, in some future state, all-powerful. Well, the best way to get Nick to the airport is probably immobilize Nick, put his hands behind his back, just throw him in a car. It's much more efficient because then he doesn't talk to anybody on the way out. So you can see these sub-goals going terribly wrong, right?
Yeah, but remember, it's a very intelligent system. By then, it should be able to not go wrong in ways that are obviously against human interests. It should be trained in such a way that it is interested in human interests.
All right, excellent, because I don't really want that to happen to me. All right, let's go through, I want to go through some regulatory frameworks. I have a question for you that I think you may be able to answer better than most anybody, which is, one of the things that holds back the big AI companies and the AI researchers from working on safety or slowing down, it isn't just power, it isn't just money, it's the dream of like doing something great, or as coders say, like finding something sweet. Tell me about a moment so regulators can understand this, where you as a developer are on the on the cusp of a breakthrough, what that feels like, and how regulators should think about that as they think about policy.
I'm not sure I can give you good insight into that. For a researcher who's driven by curiosity, working on how to make something more capable, to introduce some dramatic new capability. Like a previous speaker talked about the idea that you learn a model for one language, you learn a model for a different language, and then you can take the internal representations and rotate them onto each other. That's kind of amazing. You get a lot of joy out of seeing something like that. And I'm not sure you get the same level of joy out of working on safety. So I sort of agree with you there. However, working on safety is very important. And there are some very good researchers who are keen to spend their careers working on safety. And I think we should do everything we can to make that career path be a rewarding career path.
So you would say to the young enterprising coders in this room, this is God's work. Work on safety, or that would be a good thing to do, perhaps better than, even better than being a plumber?
Oh yes, better than, if you could make progress on safety, that would be amazing, yes.
All right, excellent, I'll talk to my kids. Let's talk about the regulatory frameworks you want. One thing you've talked about is, I believe you went to 10 Downing Street and said that the UK should have universal basic income. Will you explain why? And then explain the other regulations that you recommended there.
Yes, I got invited to 10 Downing Street, and there were a whole bunch of Sunak's advisors, his chief of staff, and a whole bunch of other people who advised him on AI. And I talked to them for quite a while. At that point, I wasn't sitting down, so I walked into this room, and there was this big group of advisors, and I spent a while talking to them, including saying I thought that I wasn't confident AI would create as many jobs as it got rid of, and so they'd need something like universal basic income. When the meeting came to an end, I started to go out the door and realized I'd been standing directly in front of a huge picture of Margaret Thatcher and explaining to people they should have socialism in front of a big picture of Margaret Thatcher, which was quite funny.
All right, so universal basic income. What else is in the Geoffrey Hinton regulatory plan for a world with AI?
I think a very straightforward thing, which Sam Altman won't like, is this idea that comparable resources should be devoted to safety. If you look at the statements made by at least one of the people who left OpenAI because it wasn't serious enough about safety, it was to do with resources. I think the government, if it can, should insist that more resources be put into safety. It's a bit like with an oil company. You can insist they put significant resources into cleaning up waste dumps and cleaning up the stuff they spew out. And governments can do that. And if governments don't do that, they just keep spewing stuff out. That's clearly the role of government, to make capitalism work without destroying everything. And that's what they should be doing.
But there's a simpler way to do that, right? I mean, government can regulate these big companies and say you have to work on safety and we need to audit and make sure you're doing that. But the government could also just fund a lot of safety research and take a lot of government data and make it available to safety researchers and fund a bunch of compute and give that to safety researchers. So should the government officials here all be setting up AI? Should the UN set up an AI safety institute?
I think the UN is rather strapped for funds, and the UN has to do things like feeding people in Gaza. I'd rather it spent the money feeding people in Gaza. I don't think the UN has the resources. Maybe it should have the resources, but it doesn't. Canada, I don't think, has the resources. Canada's made a serious effort to put money into funding compute for universities and startups. So they recently put $2 billion into that, which is a lot of money, especially for Canada. But it's nothing compared with what the big companies can do. Maybe countries like Saudi Arabia can put in comparable money, but I'm not so sure they're interested in safety.
So, Jeff, we have 1 minute left, and I have 14 more questions, even though you gave wonderful, wonderful, brisk answers. So I'm going to ask one big one at the end. From all of this AI research, you've been studying how the brain works. You have incredible theories about why we sleep. If you get a chance to talk to Dr. Hinton, I advise you ask him about that. What have we learned about the brain in the last year and a half in this explosion of AI that has surprised you?
Oh, that surprised me. I'd rather go back a few years and say what's really surprised me is how good these big language models are. I think I made the first language model in 1985 that used backpropagation to try and predict the next word in a sequence of words. The sequences are only 3 words long, so the whole system only had a few thousand weights. But it was the first of that kind of model. And at that time, I was very excited about the fact that it seemed to be able to unify 2 different theories of the meaning of a word. One theory is that it's to do with its relations with other words. That's the sort of de Saussure theory. And the other theory that comes from psychologists is that it's a big set of semantic features. And what we've done now is by learning embeddings and having interactions between the features of embeddings of different words or word fragments, we've managed to unify these 2 different theories of meaning. And we now, I believe, have big language models that really understand what they're saying in pretty much the same way as people do. So one final point I want to make is that the origin of these language models that use backprop to predict the next word was not to make a good technology. It was to try and understand how people do it. So I think the way in which people understand language, the best model we have of that is these big AI models. So people who say, no, they don't really understand, that's nonsense. They understand in the same way as we understand.
All right, well, we'll have to end on that note. It makes me somewhat heartened to know that Jeff Hinton's incredible mind is in some way behind all the AI models that we use today. Thank you so much, Dr. Hinton. Thank you for joining us today.
Thank you.
Oh, thank you very much to Jeffrey and Nicholas. What a fantastic session. Just going to move over here because we're going to set the stage for an incredible panel. And I want to have a word a little bit about responsible AI whilst they're resetting the stage. In 2020, I made the Beatles sing Call Me Maybe using generative AI and supervising every 3 to 4 seconds. A few months after that, I was invited to voice clone a senior official at an internal organization. When I started doing it, I realized very quickly that the result was so good, it was audio cloning, that I stopped and had to ask myself, should I be doing this? Just because I can, should I be doing this? And so this next panel is going to be absolutely fascinating. We're looking at the nuts and bolts of why AI can work for us, and we need to help it do exactly that. I can see a lot of you nodding your head here, so that's excellent that we're in the right place. And this is an upcoming panel on the next wave of AI for good. And after that, we have a few more interesting things, including a K-pop video where you will be able to join in with the top half of your body. I'm not sure if that's something that sounds exciting at this point because you're ready to move again after a lot of sitting down, or whether you think, you know what, I'm going to watch everybody do it. Well, don't worry, because nobody will be looking behind to see if you're doing it, but I will see you all moving your arms and legs. So that's going to be coming up as well as some more incredibly useful panels. Right then, it looks like we're all set. So please, can you give a late afternoon, day 2 round of applause for the absolutely fantastic moderator in the program chair, AI for Good's former Deputy Director, TSB at the ITU. It is the unique and amazing Reinhard Scholl.
Are you coming? Okay. Okay. I think maybe this is a little, it's a somewhat unscripted, it's pretty unscripted, the panel discussion. So we have 5 panelists. Right next to me is Rumen Chowdhurt, and she's the CEO of Humane Intelligence. Then we have Virginia Dignum, she's a professor for ethics at the University at Umeå in Sweden. We have Stuart Russell, professor at Berkeley University. And Stuart, I think you have been to all our in-person summits. Yep. And this is fantastic. I think we should have given him an applause here. And then we have Amir Banifatemi. Without Amir, we wouldn't be here today, because Amir is a co-founder of the AI for Good Global Summit. And I think we owe Amir, we owe you a big thank you for actually bringing this together. Also, and then we have Anja Kaspersen. She is a former colleague in the sense we've worked at the United Nations, and she has an incredible background in security and diplomacy, and you are extremely well spoken. And I'm not quite sure. Well, you're also working for IEEE, and you're representing the Carnegie Foundation. So this is somewhat unscripted. I'm going to throw out some questions, and then whoever would like to take the floor, please go ahead. So we're talking about how to move from the AI framework principles to implementation. So governments and companies and universities, civil society have been spending quite a number of years trying to figure out what kind of rules, what kind of policies would we need in the realm of AI. And over the last months or a couple of years, quite a number of frameworks are being put into law. The European AI Act, which seems to be now a done deal, has been in the works, I think, for 5 years. And the United States put out its executive order. China's been working a lot on it, and there are many other efforts that are taking place around AI governance. So I would like to emphasize our discussion on how we could actually measure, how could we actually implement the frameworks. So how would we actually know that what the policymakers have been deciding, that this is working? Who would like to step in on this? Virginia?
I can start. I don't think we know necessarily whether the frameworks and the regulations that are putting forward are right, but we also don't know that AI, we get it wrong all the time with AI. So we also cannot expect that the frameworks and the regulations that we put out will be perfect the first time. And I think that it's much more important to try and to test the different types of approaches. They are already, first thing is also that it is not true that AI is not regulated. Already now, without whatever regulations, AI falls under sector healthcare regulations, industrial regulations, product liability. So there is already a lot there, which makes that the AI that we use is as safe and as trustworthy as possible. In terms of the AI regulations and AI principles that we can put forward, we cannot know what is the best approach if we don't really, in the same way that we try with AI systems, we don't try and we don't put them forward. We don't have to wait until the law is perfect. If we wait until the law is perfect, we will be waiting forever.
I think when we have a scientific mindset, or maybe most of us, you just run an experiment, and if it doesn't work, you run another experiment. So I think, yeah, we should just try it out, yeah.
Let me build on Virginia's point a little bit. You know, like I come from industry, and what I haven't heard is anybody ever sit the CEOs of the companies and say, is your product ready to be rolled out into the world? What if it's not working 100%? We are thrilled to see new products launch, right? And I think we can have the same safe, iterative approach to policy. And I completely agree with Virginia. One thing that I am, heartened to see here, one thing I want to note, I feel like there have been 2 conferences happening over the last few days. And there's one conference that is this room with the neon lights and the glitz and the glamour and the big screen and Nick Thompson from The Atlantic interviewing people about their opinions. There's another conference happening. It's mostly on the 3rd floor, I believe, and it's in different satellite offices. And those are people you will see, and there's no neon lights, there's no applause at the end of it, but they're putting their heads down and they're working together and they're solving problems. I'm really heartened to see that happening. And that's the room of people you should aspire to be in. You should aspire to be in the room of problem solvers, because I will say, we know that policy won't be perfect, but we're gonna make it as good as we possibly can.
Okay. Stuart?
Yeah, so I want to agree with what's been said, but I think we are at the stage now where most of the policy that's been enunciated is at too high a level to actually tell, is my system in compliance or not? And so there's still a lot of work to do. For example, if you take an analogy to another area like food safety, you could have a high-level principle saying, food should be safe. People shouldn't get ill from eating the food. But then a huge amount of work was done to turn that into specific rules, like what temperature should, cooked meats be stored at? How long can they be stored before they have to be thrown away? Exactly what has to be on the label? How often should we inspect restaurants? There are rules about how many rat hairs there are allowed to be in a can of beans, right? And the answer is, I think it's 1, right? So 1 is okay. I think you can have maybe 1 rat dropping for each so many kilograms of product and so on. So those have been worked out, and then you can tell. Someone can come along and look at the can of beans and count the rat hairs, right? We are nowhere close to that with AI systems. So we talk about fairness. There are dozens of definitions of fairness. The NIST risk management framework has basically an IOU. It says, look, there's all these definitions of fairness, and we still need to work out which ones should be applied to which kinds of decisions, and what degree of compliance has to be achieved, and so on. So, so as Rumen says, there should be people working on nailing down all of those details. And it's interesting, actually, one of the questions, so Reinhard sent us some questions to think about. One of them was, is AlphaFold safe? That's a really difficult question to answer. We think of AlphaFold as being very beneficial to science. I have lots of biology colleagues who love it. They're like kids in a candy store. But there are ways of misusing AlphaFold. And we've seen, for example, an analogous case where chemists were able to use one of these molecular design programs to actually synthesize new toxic weapon chemicals by the 1,000 in the space of a few hours. So AlphaFold is not safe in the sense that if someone says, okay, I want to use AlphaFold or some variant of this kind of analysis program to, yeah, you can go. Let me finish my sentence.
Yeah, sure.
AlphaFold is not set up to actually prevent that from happening. And so then the question is, what do you do about that?
Okay.
Well, I want to dig into this AlphaFold example because you yourself have touted the FDA as a great example of, how drugs are made safe. So I want to emphasize that making AI safe is not about just inspecting the model and beating up the model until we've created the appropriate safeguards only in the model. We have never done science that way. When we have made science safe, it's because we have created the appropriate infrastructure in the real world. So if we talk about, let's say, someone's ability to make some sort of toxic chemical, a bioweapon, they would actually have to have the ability to physically synthesize those chemicals, which actually in many cases is restricted. They would have to figure out how to distribute it and get it out there into the world, right? So there are many steps, many of which are human, to getting that to happen, right? So, I just want to make sure that, like theoretically one could say that about pharmaceutical companies and getting drugs out there, right? They could cut corners, et cetera. But this is why we have these institutions of governance set up to ensure it's safe. So I don't want to get people overly worked up about, oh my God, we have to make sure these AI models can't create chemical bioweapons, because to be clear, the AI models themselves, if they are spitting out a formula or a way to do it, is not the end of creating a biological weapon. You can find the recipe for malicious weapon, biological weapons like anthrax, right, online. That doesn't mean we're all at a risk of being poisoned with anthrax. I just want to clarify that there is more than just governing a model. Yeah.
If I just can go back to Stuart, just to finish the AlphaFold discussion. I mean, you're known to say AI models need to be provably safe. How would you put a provably safe stamp on a model like AlphaFold?
So actually, the point of my example is precisely that at the moment, deciding safe or unsafe is too difficult, and that we could, if we have a high-level principle, models should be safe, we can't turn that into a specific regulation.
But I think
what we can do is say here are completely unacceptable behaviors by models, and require that developers show that their systems will not exhibit those unacceptable behaviors. And those unacceptable behaviors are only small subsets of the totality of unsafe things that could happen. But for example, a model that replicates itself, that breaks into other computer systems and takes them over and makes copies of itself, we would consider that to be unacceptable. And therefore it would be reasonable that regulation should require a demonstration that the system will not do that.
I see that Virginia is super eager to jump in, but let me try to get Amir and Anja in. Would one of you like to talk about the AlphaFold discussion here? No, or you would, okay, you don't. Okay, fine. So Amir, do you think we are on the right way with respect to implementing, or what is it that we have to do to implement the AI governance frameworks?
Well, my opinion goes back to the observation the past 8 years of AI for good deployment in general, where we have witnessed that machine learning and AI models and recently LLMs-based approaches have demonstrated significant progress on identifying patterns, prediction, and ways to mitigate risk. The issue is governance, I think, is at a multiple level. If we look at the UN system and the stakeholders aligned here, we talk about inclusivity, democratization, safety, access, privacy, and we look at the industrial part, we look at productivity, efficiency, safety from a different matter, but not necessarily risk. So there is not necessarily alignment in terms of language and how we look at this. And the support for deployment of AI for good or governance of it is critical. Junction is scaling. Having a pilot or demonstration of a model is one thing. Deploying it within an application in a specific use case, another one where there is engineering involved. There is probably another series of set of public safety, privacy, awareness, transparency that has to be involved. It goes beyond the model. So the governance, I'm not sure today we are still aware of all the layers that have to be worked out. To Rumen's perspective, when I think about product, there is a very clear guidelines about product deployment. When I think about research, we're still observing, and researchers are now fearing, but probably rightfully so, that there is huge risk ahead if we don't control those models. But probably we're not at the place where we can actually deploy them from an engineering perspective wide enough. So the question about governance is that who's in the governance perspective, who's in the governance room, and how this governance discussion should be taken care of, and what type of methodology or vocabulary are we using. But definitely, to paraphrase what Virginia is also saying, is that governance should be focusing on good AI, and let her amplify that concept, which we all arrived at, is that we're talking about AI for good, and the governance of AI for good should start with good AI. And what is good AI? And what is safe AI? What is AI that can be deployed? Not everything needs to be deployed necessarily, and that conversation about governance I should continue with probably align on vocabulary and concept that is measurable. And I'm emphasizing that scaling is the issue. We need to be able to think about how to scale for the public good at a large level, and this is where the governance should be emphasized first.
Anja?
I think we sometimes get caught up in making these binary propositions, good, bad, safe, unsafe, risk, benefits. Rumen made a comment about this on our first day on the AI Governance Day. And it's kind of leading us down a path which is not helping with putting governance efforts. So systems, and it's interesting because I've been involved in this with Reinhard and all the great people at ITU from the outset. And there has been a big transformation with this conference. Because initially when it was first organized, there was even a poor comprehension about what are the societal impacts. Does it really affect us? I'm just a small SME, I'm just a small company. Why would I have to care about these things? I see now we see a completely different comprehension about the societal impacts. But we're also moving further away because there's more and more push. I mean, narratives matter. So there's a greater push to try to take control of those narratives and put forward those binary propositions. I see another thing which is quite interesting. One is the mechanical side of AI. I feel that that's sometimes lacking. We had a lot of really deep dives into technical insights, sometimes maybe a bit isolated or insular from each other. But to understanding issues like systems integrity, once you embed any form of AI into a system, you actually change the entire integrity of what you're trying to do. And that's not often understood on the policy side. And this is critical when you're trying to think about putting governance in place. The other thing I see where we're still struggling is that of a shared language. You talked about language, the nomenclature. And we know how difficult it is to do within our own fields when it comes to actually putting effective governance frameworks in place, to even have a clear and shared idea, what are we trying to govern, at what state of the process? Like, for example, in the ethic, kind of embedding ethics and safety by design, in the early conference days, that was seen more as a sloganeering. Now I think it's understood that it has to be that way. But even that looks different from who you are in that equation. Are you a company that develops these systems? In which case the ethics starts at the conceptual development stage. But if you're a public sector or you're an organization, that ethical kind of hardcore work that needs to happen actually starts at the procurement stage. You know, you have to know what you're buying, and you have to know that you even have the right problem you're trying to apply to. I mean, I'm sure Stuart had the same thing. The amount of conversations that we go to where the problem that is being described is not an AI problem. It's not even a governance problem. It's a human problem that needs to have completely different vectors inside. So my point is that narratives matter more than ever. Who gets to define these technologies, what they are, what they're used for, the words that are being used towards it, and the questions that are being asked. So always when I come here and when I speak, I always say, like, I hope I leave you with good questions. Because this is the one feedback I get from so many people. So interesting, I learned so much, really interesting insights. I still don't know what questions to ask.
Mm-hmm. Virginia, thank you, Anja. Virginia, you
Sure.
wanted to get back
Many
to
things.
Stuart, or?
Many things. I could. Anyway, I think I fully agree narratives matter. And the first narrative that we need to get straight is that AI is not a technology. AI, as we are regulating it, as we are using it, as it is impacting us, is a social technical system. And as such, we need to regulate it from the perspective of the technology, but we cannot forget those that develop, deploy, manage, govern, use, and whatever else. So when we talk about making the models safe or unsafe, we can make them completely safe, like we can probably make a scissors, the model of the scissors is completely safe and provable and whatever, and still someone can use the scissors for doing all kinds of whatever they want. Even regulations that come from your microwave, which probably also can be provable correct, I don't know, come with instructions, don't dry your cat inside the microwave. So we really need to take AI and the regulations and the use of it from a perspective of social technical effort. And as such, we also need all of us, and we are here because we believe in AI for good, and we believe that AI can make a big contribution for achieving the sustainable development goals to really make the world a better place, otherwise probably we would not be here. But we really need to start asking ourselves, all of us that are building these systems for good, how good are we really committed and building these systems? Are we willing and able to be accountable for whenever these systems fail or don't do what we expect? Are we using the data? Do we know which data we use where we are training the systems that we are building? Do we believe that are we really taking all the steps that we know, even without the regulations or without the laws there? Are we doing it good? Because this whole issue of regulation starts with us, not with the models. It's with us. And if we don't trust the model, then the first thing and only thing we can do is don't put it out there.
Rumen, I have a question for you, and then you can maybe answer my question and also respond to Virginia. You have been involved in model evaluation. Are we at a point where we could think about standardizing model evaluation, even though the basic science of model evaluation, I guess, is still in flux?
You have asked my favorite question. I think it's because the science of model evaluations are in flux, we need to have the conversation about standardization. So there's two parts of this. Virginia is 100% correct in saying that this is a socio-technical problem. Stuart had mentioned the NIST RMF, and I agree, and that was like some of the feedback that NIST had received. It's like, okay, well, it seems like a blueprint, but what's the implementation? And I know folks here have been probably flying in or busy or getting their hotels, but on Tuesday, NIST announced something called ARIA. It is a socio-technical testing platform. This involves model evaluations, red teaming, and field testing. So this involves engaging real humans in interacting with AI systems and testing specific use cases to understand how these models will act in the real world in both malicious and natural use situations. So one effort that I am spearheading and leading as Humane Intelligence is creating a global community of practice around the science of evaluations. I think it is very needed to think through best practices and methods for how evaluations work. For example, if we say red teaming, I think folks in the room who are familiar with me and what I work on know I work on red teaming in particular, but we don't actually have a science of how red teaming should work. How many people is a sufficient number of people to red team? Who qualifies as an expert? How do you know you're done red teaming? You know, how can you test the robustness of your red teaming responses? None of these are answered questions. That doesn't mean we don't go do them. That means we have to go and do them to get this information. But it is helpful to have different evaluation bodies, safety institutes, globally engaged on the conversation, because we do want to make sure that whatever these approaches are interoperable, agreed upon. Why is that important? Because let's say, you know, the Malaysian government does their evaluation of an AI system, they should be able to hand that over to the Singapore government, the US government, the UK government, and everyone starts off knowing exactly what the best practices were. This is how science works, right? Scientists engage in a common shared language of science. Absent that, we need to create that language for AI, generative AI evaluation, so we can have a shared conversation.
Stuart, I'd like to turn to you again. We organized an AI Governance Day on Wednesday. And you know, one way maybe to structure the field of AI governance is AI needs data, AI needs algorithms, and AI needs computing power. So you could think that you need data governance. You know, you look at whether the data are that people have access to data, that the data are good. You can think of algorithm governance. How do you ensure that that's related to data governance, that you don't get biased results. And then you could also think of compute governance. So I think that was a term that for maybe many of the participants was new. So you're a professor of computer science, and it seems that compute governance is actually the area where it might be easiest to measure something. Because if someone is training a model, you know, you need compute power a lot if you train a large language model. So you know, you need water to cool things. So this is something you can actually measure, and this might be easier than to measure whether your data are integer or whether the algorithms are biased or the data are biased. So can you talk, give a little bit of maybe background on compute governance, what it is that could be measured? Is that a useful thing?
Yeah, so there is a number of proposals, and you can see numbers in the European AI Act in the US executive order, where they'll say, you know, a system that uses above this amount of compute in the training process is subject to additional restrictions and reporting requirements and so on. I think the number is 10 to the 25 operations. But you know, the details of exactly what is an operation, you know, is it a bit operation, is it a byte operation, blah, 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 it doesn't matter that much. So you can measure those things quite precisely, but it's not clear to me that they actually mean anything. There is constant ongoing research to achieve the same level of capabilities from much less compute, partly because it's very expensive to run 10 to the 27 or 10 to the 28 operations. And so I think any such hard threshold is going to be outdated very quickly. And if you think about it, right, humans learn from far less data typically than the systems that we're training. I mean, their text intake is maybe 100,000 times more than any human has ever read. So if we actually can improve the algorithms, we will find that we don't need anything like as much training data as we're currently using, and we don't need anything like as much compute to produce something that might be superhuman. So I'm not actually in favor of this idea that as long as we know where the big compute is, we're good. But there is an aspect of this overall problem where compute governance could be very important, and that's in the complementary side of, so we've got regulations that might eventually say, here's what AI models have to do, here's what we mean by safe, here are the tests and requirements and all the rest, and all of the bona fide actors in the space will comply, we hope. But then what we call the Dr. Evil problem is that there will be actors who have no interest in complying with any kind of safety regulations. And how do you prevent the proliferation of extremely dangerous AI systems? Systems that can replicate themselves, that can break into other computer systems, that can destabilize markets or hoodwink entire populations into misunderstanding the situation that they're in. And that's going to be, I think, controllable not through the kind of policing that we're currently trying to do with malware, which is a complete and total failure, but it's going to have to be at the level of the hardware itself, because software is produced by typing and can be copied and transmitted at the speed of light. It's very hard to police. But hardware is produced only by a very small number of manufacturers. If Dr. Evil wants to bypass the existing hardware ecosystem, Dr. Evil has to build their own TSMC, which requires hundreds of billions of dollars, tens of thousands of engineers, and decades of work. And so if you can get the hardware itself to check that the software objects that they're about to run are compliant and refuse to run non-compliant software, then you have a chance of preventing this, this problem. And you would also, as a byproduct, be able to get rid of malware as well. So there's a huge amount of technical work that needs to be done to make this possible. But the ideas, the technical ideas go back to the 1990s with a technology called proof-carrying code, where the software object comes with a proof that the software actually complies. And that's something that we could then implement in hardware and get somewhere.
Yeah, Anja, I'd like to ask you a question, and then you can think about how to answer or how to comment on Stuart's response. Are we on the right way towards coming up with good rules, policies for our governance? Would it take, we talked a little bit before, would it take perhaps a major catastrophe? And I'm not quite sure how to define a major catastrophe. Would 100 people have to die? Would 100,000 people have to die, or something similar? Or would it be rather maybe a slow creeping process, AI taking somehow control, more and more control over our lives, like with, Regina said, like with climate change? Would it take a disaster, or would it be a creeping process? And then it might be too late, like with climate change. Maybe we're too late. Maybe we could have reacted earlier, but earlier scientists didn't really know how this all worked. So what's your assessment?
So I need to say I'm strictly taking all my official hats off when I answer that question, because this is purely my personal statement. I think we might see both. You know, when you look at the history of technology, especially when you look at it from an international security perspective, there are unfortunately trends when you have big transformative technologies to sense the urgency around regulation, around coming together. Often it does follow something that is undesirable happening first. But then you also have this creeping effect, you know, where it sort of penetrates more and more. What we do is making us almost spectators to ourselves. So it's also changing society at a very kind of granular level, where we may not have the resilience in place, both at the human level and at the society level. Now, I just wanted to follow up on something. So that's the question to you, kind of bigger issue. But I do think Stuart is making a really essential point, which is often seen as a bit more unsexy side of AI, which is all the people that need to work on the systems in the background, the people required to maintain them, to upkeep them. I remember the first time I met Stuart, you know, he was lecturing and he was saying, for everyone in the room, read machine stop. Do you remember this? It's a novel from 1905, 1904, 1905, 1909, and essentially how we become over-reliant on this big computational system and we stop checking in with ourselves. And there is a real risk of that at a human level. Now, going to the governance side, I just want to make this point. So one thing I do worry about, to the second part of your question, is that we're seeing an extreme level of fragmentation. This goes back to my issue of narratives. You know, how we speak about it, how we govern it, you know, regulatory frameworks that actually might be pushing us into very granular approaches to it rather than coming together. There's another component to it, which is we actually have a lot in international governance instruments today, including ITU, that can be brought together to create this framework. You know, anyone who works in computer science would know this concept of middleware. You know, the mechanisms you use to bring things together. So if we can emulate on some of the really critical experiences that were made internationally, you know, on issues of nuclear safeguards, etc. The Atomic Energy Agency is also here at the conference, which was really hard-won, difficult things to negotiate. But we have done it in the past where you found that balance between promote and protect. So we need to be a little more unafraid to tap into what we know, to the experience that actually exists in the national space. And that's where standards come in. And the Secretary General spoke about it, I think, twice during this conference, the importance of standards. And of course, my organization is also involved in this space, especially the social technical space. And I see, because I come more from the policy side, I actually see standards. Standards does a very important job in building confidence between people that work in technical fields. But it has this untapped potential to also help building confidence or doing confidence building between policy makers. It offers that sense of, you know, the clarity on nomenclature. It offers guidelines or insights into the limitations of a system, to the opportunities, to the maturity of a system. So actually looking at standards also as a baseline of bringing greater convergence where we find ourselves very divided, I think is an untapped potential in that space as well.
Amir, you have the last word. What is your assessment with respect to AI governance? Are we on the right track? What would you like to see over the next year or so that should take place?
Well, after everything we said, I think we agreed on a number of topics about language and clarity and testing. I think the focus on AI governance should be on promoting what I said earlier is defining good AI and trying to implement as much as possible good AI in all the layers of SDGs to understand and gather data from the ground up. Of course, standard organizations have to work to create standards. They have to have ground truth data to work on the standards. We have to have measure and metrology. We have to be able to characterize those issues. If we don't experiment more, we're going to be staying at the level of conversation, which is pretty much a binary negative, as was suggested by Anja as well. The concept of good AI has to be defined. We're going from AI for good. We need to probably put an adjective of good AI in front of it. But I say we need to work on good AI for good.
Okay.
And good AI is a safe, trustworthy, human-centric, beneficial that provides value and make sure that researchers, scientists, those who are implementing and monitoring systems also align with this concept and try to implement it. In that case, governance should also provide a framework about how should we push more good AI into our society. There's an issue of literacy as well. We usually drive cars and use knives and scissors and many objects that could be dangerous and lethal, but we have learned to understand their limits and their boundaries and what to do with them and not. Bringing up literacy at the global level, I think, should be an act of governance to make sure that everyone understands the limits and the limitations and find a way to make sense of what we're talking about. I think we still have a two-speed society going on right now.
Okay, that's a good closing word. Amir, good AI for good. So thanks a lot to the participants, including Virginia, who needed to catch a plane. Otherwise, she will be stuck here. Thanks a lot.
Thank thank you very much to all our panelists as you make your way off of the stage. We really appreciate you all making time to join us here on stage, and the same goes for our next panel. We are so grateful for people adding their involvement to this evening and making time for this next session, which is all about a sustainable and equitable future for all. This is a power panel, so it will be short but incredibly informative, a bit like me, actually. Okay, so let's invite everybody to the stage. It's Tomas Lamanauskas from the ITU, His Excellency Ambassador Lauber, Gabriela Ramos from UNESCO, and Rob Opp from UNDP. My goodness. Hello, how are you? Hello.
Thank you, LJ.
All right, we have everyone. So we're nearing the conclusion of yet another remarkable summit. Congratulations, all of you. And we are very, very privileged to have representatives from 3 UN agencies and the co-host of the AI for Good Summit on stage. And I'm going to just say a central theme throughout both the AI for Good Summit and WSIS has been collaboration. And over the last 3 days, we've seen outstanding examples of collaboration amid the UN system entities. And the UN Activities Report, released by the ITU on Wednesday, highlighted impressive initiatives from more than 45 agencies. And we've also learned about the close partnership between UNESCO and ITU in facilitating coordination and coherence within the UN system on AI. So, Thomas, I'm going to start with you. What are your plans to further strengthen this collaborative effort amid UN agencies as well as other stakeholders?
So thank you very much, LG, and great to be here with you as we are coming to a close of this very, very intense but very productive week. And I think when we talk about partnerships, we need to see, and this week has showed us, what we're building upon. And I think anyone who walked these halls here, and even outside the building, when you saw there are a lot of people trying to get in, you saw how many people want to partner, how many people in these different meeting rooms, in the halls, sit down and discuss how they will do and what they will do together. And we have a lot to build on. So, of course, in this summit, we already launched quite a few things that we'll be building upon. So we launched an Open Wallet Forum with the Linux Foundation and others as well, where we'll be bringing digital IDs and digital wallets, interoperable wallets to everyone. We launched a global initiative on AI and disaster management, which will harness AI in this very important climate adaptation challenge, and that builds up on all other similar global initiatives. So last year's launched global initiative on AI and health together with WHO and WIPO as well. So we also discussed here in these halls collaboration with the World Standards Corporation together with IEC and ISO, how we'll work together and bring others along or to coordinate AI standards, and also specific track on watermarking and content authenticity. We of course have a broader platforms to build in. This again forum we launched another annual report of UN projects and initiatives on AI with more than 400 projects highlighted, showcasing how UN is already working on AI. And that shows how we use AI for school connectivity mapping. We use AI for flood predictions. We use AI for water quality as well predictions. So we're already doing that, and this coordination with the UN system is super important. And that brings me to a coordination, and I'm sure Gabriela will also agree with me. She's my partner in crime, and this week we felt like always like twins. And most of this, I think every time I was on the stage, except for one, I was always with Gabriela, because indeed that also shows how we as UN are working together. More than 40 agencies, and it's a really pleasure together with UNESCO to co-lead that coordination, already coordinating to make sure that we are there together. We've been asked by our colleagues to come back now and say how we can do it even stronger. Now exactly this we're working on. We learned a lot this week again. We brought those UN agencies here. We actually asked them to mix with the member states as well. We had a great mixer there. Thank you very much for Swiss Confederation for facilitating that as well. And there's a lot to build on. So stay tuned. We'll be thinking a little bit more few announcements maybe still today, but also stay tuned for this great collaboration going forward. So thank you very much.
Brilliant. Thank you very much, Thomas. Let's chat with Gabriela Ramos. I notice it is actually quite difficult to tell the two of you apart, but I'm going to continue. Thank you for joining us on the stage. UNESCO's ethical recommendations on AI represent a pioneering effort to ensure that ethics are central to AI development. And you've actively participated in Governance Day and engaged with countries across the development spectrum. So what are your key takeaways from these conversations? And what are your thoughts on enhancing even more collaboration across the system?
Well, first and foremost, what do I take away from here? The fantastic leadership of ITU, Doreen, Tomas, amazing, and I think they deserve a big applause because they are amazing. I feel that when we say that to understand the technologies, to govern the technologies, the conversation on governance really went very solid in these days. You bring the private sector, you bring the academics, you bring the stakeholders, you bring the international institutions, you did it. So leading by example. Thank you so much. I'm very encouraged by the conversations because it seems that we are converging in terms of what needs to be done in terms of governing, not only about the question of regulating or just controlling the downside risks, but how do you create incentives? And this is the main message that I take from this fantastic gathering. How do we create incentives in the private, public, everywhere, to ensure that we invest more in the good AI and that we address the problems that Thomas was mentioning, because at the end we want AI to solve our problems. And then in terms of partnerships, remember, the Summit of the Future is coming, the Global Digital Compact. We spoke about with our members because our members are happy that we are cooperating. We delivered this impressive document, and with Thomas co-chairing, and of course with the support UNDP, many of the institutions that are there, to show that the UN system, and you can be proud that the UN system is really taking this seriously and is making very concrete contributions in all the areas of work that we have. Therefore, that white paper and the interagency working group was signaled, and this is something that I take with me very seriously, as one of the platforms that can be used to advance the Summit of the Future conclusions, and I hope that our members will take that with them. And then there's nothing that like partnerships. And in our global forum on the ethics of AI, because we have 194 countries implementing the recommendation on the ethics of AI, so we have the global forum. We launched the Observatory on the Ethics of AI with Alan Turing and with the ITU. We have a readiness assessment, and suddenly we realized that, of course, the UNDP, this fantastic development institution, has also the readiness assessment. And we were asked by our countries, why are you doing readiness assessment, both of you? So we're joining forces, and we are collaborating to see how we can go together in delivering these assessments, the landscape, the AI landscape of the UNDP and the readiness assessment. And then, of course, we cannot do it without the ITU, because the ITU will also help us with the deep dives in terms of the sectoral assessment that they're doing. So I feel that we not only come, I would say, I'm not being arrogant, but I will say a little bit more wise, not only because of the panels, not only because of these fantastic exchanges that we have, but also because we got this sense of purpose confirmed that we can steer the development of these technologies in a positive manner. So we are really looking forward. I actually considering with Thomas and with Doreen and with the teams, with Pretam, how do we also build the linkages between the Global Forum on the Ethics of Artificial Intelligence, where all of the RAMs are presented, and the AI for Good and WISES going forward. So thank you so much. Watch this space.
Oh, thank you so much, Gabriela. Let's go on to Rob Opp from the UNDP next. Thank you also for joining us. As the UNDP, with its core mission of development and assistance to countries, what did you find most resonant about AI capacity building during the summit? And with ITU and UNESCO on stage, both heavily focused on AI, as we've heard from Thomas and Gabriela, what are your plans for future collaboration?
Well, what I found most resonant about capacity building is that there needs to be a lot more of it. And that's also, as the UN system, what we're committed to doing. At the moment, if you look across sub-Saharan Africa, only 3.3% of journal articles, journal citations on AI are actually coming from that part of the continent. And an AU report released on the African continent said that only 36 out of 54 African countries actually have data privacy and protection policies in place. So if you don't have some of the fundamentals, and you don't have the capacity to put the fundamentals in place, how are we going to ensure that the digital divide doesn't actually get wider because of the introduction of AI, where part of the world is able to zoom ahead and there are others lagging behind? And that's, as a UN system, what we're committed to doing, because we stand for leaving no one behind. It is a core part of our charter. It is a core part of the Agenda 2030 and the Sustainable Development Goals that we all subscribe to. And so that resonated with me. It's a reminder that we need to act with urgency and with our collaboration. And that brings me to the collaboration point, which is that an important part of capacity building is understanding where you are. And as Gabriela mentioned, we're looking at the readiness of digital ecosystems to embrace AI. And we're going to work together as UNESCO and UNDP to really be able to support countries in that way, to look at that as a diagnostic and then identify priorities, where we're going to work together. And with ITU, we have ongoing capacity building initiatives already, many different initiatives when it comes to thinking through where we're headed around cybersecurity and many other things that contribute to the AI and the effective use of AI for good. So I'm really encouraged, and I come away knowing that we have major challenges in front of us, but feeling very comforted that we have such a strong spirit of collaboration as we move forward with great partners.
Oh, brilliant. Thank you very much. And now we're going to hear from His Excellency, Mr. Jürg Lauber. Hello. Thank you for being very patient. Geneva already has a thriving AI ecosystem. It's only going to expand, isn't it? So as we move into this intense phase of discussions on the Summit of the Future, the Global Digital Compact and the WSIS Plus 20 review, based on what you've heard over the past week, where do you see Geneva fitting into the future AI landscape?
Thank you so much. I'm stoked. I'm really super excited about what I saw this week and about the future role that Geneva will play. So I maybe have three messages. The first one is a big thank you, Thomas, Gabriela, Robert, to you, your colleagues, your agencies. This was a fantastic event. I mean, last year was already really great. This year was next level. I've never seen so many people, such an energy around the center. The fact that you're all here on a Friday afternoon, late afternoon, tells you something. Really, really well done. AI for Good is the flagship event within the UN system and beyond. Second, I firmly believe that we can make AI for good prevail over AI for bad if we continue to be smart. And I like what you said. I'd like to think we've become wiser, all of us collectively, individually. Also, thanks to events like this week, I think we understand better the substance, and we also understand better individually in the different agencies, in the missions, in the countries, what AI means as a challenge, but also as an opportunity, and how to deal with that. And that leads me to the third point. The structures are here, and that's a message maybe I want to give to our colleagues in New York. The Summit for the Future, the Global Digital Compact is a great opportunity. These are great opportunities to reaffirm some of the basics, the values we need to protect and promote in the face of technological advance. But then how to go about this, what it means in specific areas. These structures, these organizations are there, and many of them are in Geneva. That's why I'm so stoked about how this can happen in Geneva. So structures are here, don't invent new things, but, and this brings me to the last point, partnerships, cooperation. I think we need to, there's still room for improvement. More discussions amongst ourselves, learning from each other, looking at the specificities, more collaboration, more partnerships. That's, I think, the challenge or the task we have for the next year. Thank you very much.
Oh, thank you very much. Well, I think we're sadly out of time for this, but I can safely say how much encouragement your collaboration has generated, and I hope Switzerland and Geneva continue to be part of making core UN values like peace, security, and human rights, and we want all of that to be part of the future of AI. Thank you all very, very much.
Thank you.
Thank you.
Thank you so much. Great.
Oh, that's lovely. Thank you. Oh, that was lovely. I'm going to stay on stage. Yes, absolutely. I'm not allowed off yet. Thank you very much. Well, it was absolutely amazing to hear everybody's thoughts. And I think we're at a really interesting moment in AI. and having the chance to be responsible and do AI for good. And I say this as a generative AI artist. Very shortly, we're going to have some K-pop coming up, and we have closing remarks from our very own Doreen Bogdan-Martin as well. And then we're going to reset the stage for a few more bits and pieces. I think we're nearly there. Yes? It's a very busy stage for the last part of this event. I'm not surprised, really, because we did have quite a few people who want to come on, and it's a pleasure to invite everybody forward. Okay, right, let's invite back the Director of ITUT, Seizo Onoe-san, and the additional Secretary of the Department of Telecom India, His Excellency, Mr. Niraj Verma. Let's invite them. Okay, thank you very much. Onoe-san, I would like to invite you for remarks first, please.
Thank you. Good evening, everyone. In October this year, we will meet in New Delhi at the Governance Conference for ITU Standardization Work, the World Telecommunication Standardization Assembly, WTSA. India is bringing WTSA in Asia for the very first time. It's a momentum occasion, and I thank India once again for your great hospitality. WTSA is our guardian of the ITU standardization platform. It ensures what we remain well-positioned to meet emerging standardization demands. It's a key opportunity for ITU members to highlight their priorities for our work. India is world-renowned for the focus on the future and innovations for greater digital inclusion. This will be on show at AI for Good Impact India, the first event of our new Impact series, as well as Indian Mobile Congress. Both will run alongside WTSA, creating an excellent opportunity for a global ITU community to meet with Indian innovators. And to tell us more, it's my great pleasure to welcome Sri Niraj Verma to share a few words with us. Thank you.
Thank you. Good evening. Excellencies, ladies and gentlemen, it is my privilege and honor to stand before you today. We are here to announce the upcoming World Telecommunication Standardization Assembly, or WTSA 2024, which will be hosted in our vibrant country, India, in October this year. India, with its rich heritage and a rapidly growing digital economy, beckons you all, esteemed dignitaries. I extend a warm welcome and invitation to you all present here and your country delegates to come to India to participate in meaningful dialogue and enjoy our hospitality. I express my gratitude to the ITU for providing this platform and extend our invitation. Thank you, and we eagerly await your participation in the World Telecommunication Standardization Assembly at New Delhi from 15 to 24th October 2024 and India Mobile Congress during the same time from 15 to 18th October 2024. Thank you.
Thank you.
Thank you both. Thank you so much. And I think we have a video to watch now, so let's watch the video.
Information and communication technologies touch the lives of individuals and facilitate businesses and governance. India's robust development in the ICT sector as the world's second largest telecom market of 1.17 billion subscribers with 931 million smartphone users, an indigenous 4G and 5G stack, have helped in delivering state-of-the-art telecom services to its citizens. Countries come together under the umbrella of the International Telecommunication Union to decide on policies, regulations and standards for telecom and ICT. ITU helps in providing the universal and meaningful connectivity, bridging the digital divide and connecting the unconnected. Standards play a critical role in the development of telecom products and services. These standards are developed by member states and other ITU members. India has been a founding member of the ITU and has contributed to the development of telecom standards. India has a vibrant standardization ecosystem. Little wonder that India stands at an important position in international standardization organizations by virtue of its contribution for innovative, well-researched solutions and standards. India is proud to be instrumental in developing 5G standards of the ITU. India believes in the philosophy of Vasudhaiva Kutumbakam, a Sanskrit adage meaning that the whole world is one family. This makes India a natural partner in realizing the vision of the ITU as a connected society and accomplishing the Sustainable Development Goals 2030 using telecom and ICTs. In this endeavor, India is privileged to host the World Telecommunication Standardization Assembly 2024 from the 15th to the 24th of October 2024, preceded by the Global Standards Symposium on the 14th of October 2024 at Pragati Maidan in New Delhi. Delhi, from being the historic capital city, has evolved into a vibrant, cosmopolitan, modern city. Today, Delhi is a beautiful kaleidoscope of modern society with rich heritage and culture. In the heart of the capital city, a sprawling 128 acres international exhibition center called Pragati Maidan hosts a majestic, modern convention center, latest and largest in India, which is the venue for the forthcoming prestigious G20 summit. The convention center is designed like an elevated podium with 5 levels to make seating for 13,500 guests, best suited to host the coveted WTSA. This convention center at Pragati Maidan has been selected to host the WTSA 2024. India and the ITU proudly invite the global community to assemble in New Delhi for the highly awaited WTSA 2024 to contribute towards the goal of a better connected, secure and sustainable world.
Wow, thank you very much. So thank you to India and the ITU as they leave the stage. What an incredible and extraordinary video, and I wish you all the very best for October. All right, so it's going to be time for a final panel on something I'm fascinated by, which is watermarking. Because when I make art, it's really important to me to signify that something is generative AI inclusive. And I would like very much next to invite on stage the Deputy to the Director of ITUT, who will be moderating a fascinating panel on watermarking. Please welcome Dr. Bilal Jamousi. So fast, he's already there. Off you go.
Thank you, LJ, and good afternoon, everyone. I'd like to invite a list of colleagues for a big announcement that we'd like to make today. Alessandra Sala from Shutterstock, please join us. She chaired a wonderful workshop all day since 9 a.m. this morning. Sylvie from the Deputy Secretary General of ISO. Gilles Tonnet, the Deputy Secretary General of IEC, Thomas Wiegand, Study Group 16, Andrew Jenks, Director of Media Provenance at Microsoft, Leonard, I'm not sure if Leonard's still with us, from Adobe, John Grieter, Sam Gregory, Touraj JPEG, please join us, professor at EPFL. Peter Eisert, Mr. Kuhn, Mr. Brown, Gupta, Li Wei from CAICT, Mr. Wu, Mr. Wang, and our colleague from WIPO, Tobias, if you're still around. I think we have everyone. Please come on both sides so we can make half of us on the left and half on the right. Alessandra, please stay next to me. There we go. Okay, very good. So, ladies and gentlemen, on Wednesday, during the AI Governance Day, 45 ministers, 25 regulators, 100 private sector UN partners, academia, civil society debated and discussed the AI governance, and certainly deepfakes of audio, video, text, speech was one of the issues that was discussed in terms of needing governance. And that topic cannot be governed without international standards. So on the stage on Wednesday afternoon, we had the CEOs, the Secretary General of ISO, of IEC, and the TSB Director. And as you remember, I moderated that session, and the three executives committed to coordinating AI standards as the world standards cooperation. Yesterday, we had a 2-hour roundtable on AI standards that was inclusive of other standards organizations like the IEEE. We also had UN partners like UNEP, UNIDO, and others. We also had government representatives, Ambassador of the United States, our colleagues from China, the Ambassador from Switzerland, the private sector, Nokia, Ericsson, Google, and other companies were Huawei in that panel. And we all agreed at the end of 2 hours that we will continue the journey of standards, collaboration, and coordination for all of the AI standards. So we heard from the World Standards Cooperation. We heard through the roundtable that that session was very useful, and we need to continue it. And today, we had a deep dive on the first topic that we need to tackle, which is deepfakes. And all of the colleagues around me shared what they are doing individually in their organizations. The companies and the speakers, we had 21 speakers. Some of them had to fly out, but those who are still here are around. And we all shared the difficulties, the problems, the existing solutions, what's missing. And one of the elements of what was missing is a collaboration on deepfake standards, on watermarking and multimedia authenticity. So we're very pleased that at the end of the day, we issued a communiqué. If you scan the QR code on the screen, you'll find the communiqué already posted on the World Standards Cooperation website. And this is an indication of the agility of the standards community to address what the policymakers and the regulators need. So we had the discussion on Wednesday. We're declaring and communicating on a new collaboration on multimedia, watermarking, and authenticity. And also, this is to show that the AI for Good platform has been all-inclusive and is really working on concrete deliverables and announcements at the end of the work that we had this week. Thank you very much, and I would like a big round of applause for my colleagues who made this happen. Thank you. We're going to take a quick photo to commemorate this moment, please. Thank you. Thank you. Thank you, Touraj. Thank you. Thank you very much. Thank you.
Breathtaking selection of announcements and a flawlessly executed group photo afterwards as well. Well, later we have the CEO of Pulse 9, the amazing company behind the K-pop virtual human sensation Eternity. But first, we are going to invite some closing remarks from the remarkable, amazing, incredible person. It is Secretary General Doreen Bogdan-Martin.
What an incredible 3 days. Let me start, ladies and gentlemen, by thanking all of those that made it possible. Really, this has been a kind of whole of system effort with more than 40 UN partners, the government of Switzerland, our sponsors, and of course, all the amazing speakers, panelists, exhibitors. It's been incredible. We've heard powerful stories. We've also made lasting connections, and we've had some very meaningful conversations, some that we will never forget. There were actually people lining up outside this building, or lining up for more than a block to get in and see the action inside. And I'm told we've actually reached historic record levels of participants, which is actually tremendous. We even had what they call a viral moment. We had a viral moment this morning when the French President Macron, he retweeted the first tweet ever written and published using only the power of thought. History was made right here on our frontier stage. Children took over the youth zone to build their own robots. They're tomorrow's AI innovators and leaders. What Princess Beatrice said yesterday really resonated with me as a mom, when she urged us to figure out how best to use these incredible technologies for our children. And then, of course, a moment I think no one will forget, we met extraordinary people like Luis. I hope you were in the room yesterday when he joined us remotely from Lisbon. ALS took away Luis's ability to speak, but not his voice, thanks to AI. Connecting with him was moving, it was inspiring, and that's what AI for Good is all about. AI for Good is where leaders from the UN, from government, from industry, from international organizations, academia, and the technical community, and of course, civil society came together, sat side by side over the last 3 days, and they called for all voices to be included in AI global governance processes. I share the concerns of ministers and many others who felt that their countries were being excluded from critical AI conversations. Let me say, we heard you. And we took action here over the past few days to move us in the right direction. And I thought I would just highlight three actions that we've taken. And the first action is about giving developing countries an equal seat at the table, both at the summit and at our first AI Governance Day. Inclusion is at the heart of everything that we do at the ITU as the UN Agency for Digital Technologies. By bringing both the WSIS community and the AI for Good community together, we've actually shown the importance of building a digital society with and for everyone. I'm also pleased to see organizations step up their digital inclusion efforts around the world. We had 7 organizations from government, from the UN, from industry, NGOs as well, They answered the call to our pledging campaign that we launched earlier this year by Partner to Connect and the AI for Good community. Together, they've committed over $1.7 billion to use AI to advance digital inclusion, especially for persons with disabilities, for young girls, for women. And that campaign will continue. And ladies and gentlemen, I encourage you to get engaged. Take that example and make your pledge. You can even make it now. The second action is strengthening standards, cooperation, and collaboration. And that's something that we've heard repeatedly from the UNSG, from HLab. We need to strengthen that standards collaboration, and that is the real essence. It goes to the core of the landmark collaboration that was just announced by the World Standards Cooperation to provide a unified framework for AI standards. We've heard repeatedly from participants about the importance of interoperability and security as being a necessity for responsible AI. They are a necessity if AI is to turbocharge sustainable development, as the UN Secretary General has called for, one that's based on trust, on security, one that's affordable, and of course we need to be advancing inclusivity, especially in developing countries. Driven by ITU, by ISO, by IEC, this global initiative will ensure the effective translation of AI governance principles into practical, actionable standards. Ultimately, our goal is to fill existing gaps in AI standardization so that we can tackle our most pressing global challenges and advance and achieve the SDGs. Over the last 3 days, we've also heard about the urgency to stop the spread of AI-driven misinformation and deepfakes. We cannot sit idle as misinformation and deepfakes erode trust in our elections, in our institutions, and the very foundations of our societies. The problem with watermarking techniques right now is not that they don't exist, it's that they don't work across different technologies. And that's why I'm pleased that we have formed this multi-stakeholder collaboration on technical standards for AI watermarking, for multimedia authenticity, and deepfake detection technologies. By improving current standards and identifying the need for new ones, this collaborative effort will help to provide copyrights and recognize AI-created content on large scale. So the third action is about building AI capacity around the world. And that's where the AI for Good Impact Initiative that was launched yesterday comes into play. This initiative is going to link AI innovators with problem owners to scale AI-driven solutions equally across the SDGs and every region of the world. And we need big capacity building efforts like this one if we're going to address and meet the scale of the challenge. Yesterday, we heard some early significant financial commitments to this new initiative on this very stage. And I think, ladies and gentlemen, that's a great start. I'm calling on all of you to join us and help us to scale, to fund the most promising AI solutions so that we can achieve maximum impact. Over the past 3 days, we've come face to face with 3 dimensions of artificial intelligence. An AI that captures our imagination and promises great opportunities. An AI that concerns us and taps into our greatest fears. And an AI that challenges us to reimagine our relationship with technology and with each other. All 3 dimensions demand urgent action. Because if not now, then when? And if not for the SDGs, then what cause? Ladies and gentlemen, the UN Secretary General reminded us about the need to build safe and inclusive AI that is accessible to all. And as I said yesterday, the AI genie is out of the bottle, and there's no putting it back. But I think there is hope. You have sent a strong message to the world that the future of AI is not yet written. And as we look to 2030 and milestones like the Summit of the Future in September and next year's WSIS Plus 20 review, I think now is the time that we have to redouble our efforts. Let's redouble our efforts. Let's make AI innovation inclusive. Let's build safe, secure, trustworthy AI systems. And let's scale AI solutions so that we can rescue the SDGs. Because I firmly believe we can do it. We can do it together because we are the AI generation. Thank you very much. Thank you.
Thank you. Oh my goodness, thank you so much once again to Secretary General Doreen Bogdan-Martin for once again inspiring us with your closing remarks. It's incredible. And my goodness, our final talk is a musical one. It's a good warm-up for the drinks reception and the AI art competition that will be coming up shortly afterwards. But what a pleasure to round up this evening's event by introducing the CEO of Pulse 9. It's Jürg Pak to the stage. Please come on up. All right. So thank you for promising to get us into a dancing mood for this evening's celebrations. Please, can you tell me a little bit about what the audience is going to see?
Hello, everyone. I'm so glad to be here. My name is Jürg Pak. I'm the CEO of Pulse 9, a techtainment startup which presents the world's first K-pop AI idol band with 11 virtual girls. I'd like to say a special thanks to the Korean government agencies and Starbank. So many people helped Eternity reach this distant place, Geneva. It's a great honor.
Thank you. Now, I heard that this K-pop virtual human group is preparing for the closing performance. Can you explain the theme of the closing performance?
Yeah, sure. There's a special closing performance featuring 11 AI idol girls. This event introduced a new era with AI-created songs and voices and virtual humans are converging. Witness the fusion of advanced AI tech and K-pop artistry, imagining the entertainers of the future.
Now, I've seen some of this in advance, and it's absolutely remarkable. And I understand that AI technology was behind the group Eternity. A lot of technology was behind this. Can you tell us a little bit about how the AI technology was applied, how it was developed, and which areas is it being utilized?
Yeah, Eternity, the 11 girls are advancing face sicknesses technology in collaboration with Ithra, a leading research institute in Korea. And also, we are focused not only beautiful faces, but also developing AI to link the world for social with Starbank. For example, some of the Eternity project will develop AI companions for social isolation and loneliness of teenagers with Starbank as a global investment bank. While there are concerns that AI technology could be used for bad, such as deepfake crimes, it is crucial to continue developing advanced technology for good purpose. As the as with the main theme of the AI for Good Global Summit, AI idols are also constantly striving to use technology positively and ethically.
Oh, brilliant. Thank you so much. And what do you think we can focus on to better enjoy the closing ceremony performance together?
After the greeting, a new song will be unveiled. The second song that follows is a popular track with over 6 million views on YouTube. It will be a more enjoyable performance if you follow along with the key choreography of the second song.
Okay, brilliant. So what we're going to see is we're going to see the new unveiled performance, and after that we're going to see a wildly popular video. And do you know, I think it's a good idea perhaps to learn some of these key dance moves together, and we're going to teach you. There'll be a video, it's going to be repeated 3 times, and I'm just going to put this down here, and I'm going to attempt to learn the choreography now, because what better way to end the day than with some more physical exercise? So, how do we do it?
We can do on feet.
Yeah.
1, 2.
1, 2.
And.
Okay.
And double, 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 triple.
Okay. All right. So, shall we watch the video and then learn it? Why not?
Everyone, today I will try the point choreography of Eternity's DTED GMGN at this place.
Show me your pass double triple. Double, 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 triple. Show me your pass double triple. Double, 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 triple.
Can we? I was going to say again.
Show me your pass double triple. Double, 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 triple. Show me your pass double triple. Double, 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 triple.
Okay, that looks easy, doesn't it, everybody?
One more time.
Show me your pass double triple. Double, 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 triple. Show me your pass double triple. Double, 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 triple.
This may possibly be the hardest thing I've done over the entire 2 days of the summit, but I'm ready to try it. Should we, audience, should we try this? Just the upper half if you're sitting down. So it goes, show me your best double, triple. Double, this bit's easy. Double, 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 triple. And your hands are 3 because it's triple, although technically that's 6. So just, you know. All right. So I guess the next thing is to say thank you very much and we watch the video. Is that right? Right. Yes. Okay, let's do it. Shall we hear from Eternity?
I'm Jane, a member of the world's first 11-member K-pop AI idol girl group Eternity, which is the abbreviation for Eternal Stars. Nice to meet you. I am very happy to participate in the AI for Good Global Summit. It was a meaningful time where we could think together about how AI technology, which innovates daily, can have a positive impact on society. Our Eternity members are contemplating innovating various aspects of the future, such as education, welfare, finance, and policies with AI technology, while actively working as K-pop artists. I am particularly interested in young friends from all over the world who are trying to escape social isolation and economic difficulties. So today we have prepared 2 exciting performances with the meaning of coming together as one, no matter what difficulties we face. This performance specifically includes the unreleased new song from our Eternity album, showcasing its uniqueness and anticipation. And it is composed of AI technology-based songs and voices, forming virtual idols that do not actually exist, allowing us to see the future culture being created by the latest technology. Do not miss the chance to meet the future performers where state-of-the-art generative AI technology and K-pop art are brought together. Would you like to be a part of the incredible journey with Eternity members? If so, please enjoy the mesmerizing performance together. Thank you and goodbye.
Thank you. Okay.
We are na 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 na.
Oh, exciting.
Don't wait. waste your hype, don't waste your love, don't waste your tears, cause it's the best time, you know. Don't waste your hype, don't waste your love, don't waste your tears, it's the best time, you know. Bounce back, 여기로 보내 빨리. Fire 날 서울이 샤자니. 얘 따라오는 가심들이 놀라지. 여기 붙잡히면 아무 데도 못 가지. 내 맘은 언제나 beating, 저 멀리 앞서가 speeding. 얘 원한다면 내게 와서 take it. Just help yourself. Roll back for mine. Nowhere just back. Pull out, pull in. Get up, roll high. Roll back for mine. Nowhere just back. Pull out, pull in. Get up, roll high. Even the mission, the joke and the problems, the view wasn't already started. She knows cause she's the same. She's trying to stop playing games. Rebel emotionally dropping the problems, the view wasn't already started. She knows cause she's the same. She's trying to stop playing games. You can see me coming where now feeling right away. We are recall when I held your hand. Can see me coming where now feeling right away. We are recall when I held your hand. 주지 마, cause they can't stop me. 부디 포기하지 마, cause I'm weak, and it's the best time to be my friend you ever know. 함께 rockin', rollin', riding, yeah, I'll be with you. Okay, 좋아, 조금 더 시간이 필요해. Come on, 하나 둘 맞춰져가는 all brand new world. 그 누가 뭐라고 해도 뭐 어때 I don't care. 어차피 너도 그런 걸 원하잖아. 새로운 감각 속에서 서로 맞잡은 두 손. 두려워 마 겁낼 거 없어 함께라면. 짜릿해 지금 I like it. You wanna join us baby. 시작이야 now let's go. 모두 날 바라와 하나부터 열까지 다. It's like 원한다면 날 따라와 내가 널 밝혀줄게. 날 향한 내 맘과 double 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 triple. 내게 비춰진 highlight 그 빛을 따라 keep. Show me your best double triple. Double 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 triple. 숨겨서는 hello. What I shine like. Show me your best double triple. Double double triple triple. Hey hey 눈을 뜨고 네 앞에 펼쳐진 세상을 봐. 긴 밤이 지나면 다시 해는 뜨는 법이야. 그러니 이 순간을 놓치지 않게 just hold me tight. 내일의 빛인 너도 그립잖아. 새로운 감각 속에서 또다시 맞잡은 두 손. 괜찮았다 겁낼 거 없어 함께라면. 짜릿해 지금 I like it. You wanna join us baby. 시작이야 now let's go. 모두 날 바라와 하나부터 열까지 다. It's like 원한다면 날 따라와 내가 널 밝혀줄게. 날 향한 내 맘과 double 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 triple. 내게 비춰진 highlight 그 빛을 따라 keep. Show me your best double triple. Double 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 triple. 숨겨서는 hello. What I shine like. Show me your best double triple. Double double triple triple.
Brilliant. Thank you so much. 감사합니다. An absolutely flawless performance there by myself. I also like the fact that I failed to dance properly and 11 AI-generated virtual people that don't exist completely slayed me on the dance floor, along with the CEO of Pulse 9, ladies and gentlemen, everyone. Thank you very, very much. Okay. Now, I would like to... how can you follow that, you might ask? Well, I have an idea, and that is the fact that everyone's invited to the after party, and there's one thing remaining, and that is to acknowledge the absolutely outstanding, incredible team behind the AI for Good Global Summit 2024. So let's invite the one, the only, the inimitable, the incredibly musical and skilled Fred Werner to the stage. Yes, we got there, we got to the end.
Wow. So I paid her to say that. What an incredible introduction. Thank you, LJ. And look at all the people here tonight. It's almost 7 o'clock, and you're still here, so we must be doing something right. And there are free drinks, too, so it might be that. Now, first of all, I would like to send a word of appreciation to the amazing LJ Rich. I don't know how you're still standing.
Oh, thank you.
Yeah, I have publicly stated that I will not and cannot do a summit without LJ. So your employment is guaranteed at least until 2030, and then we'll see if we do another 10 or 20 years after that. Who knows? So thank you so much, LJ. There are drinks coming. I know it's late. It's Friday night. Is anyone thirsty? Ready for a party? Okay. So we have an art competition that's happening. It's been happening all year long. Hundreds of artists from around the world using AI to basically increase their creativity and human performance to create these amazing art pieces with a positive message of sustainability. We're going to be revealing the winners on the Frontier stage with a nice drink in your hand in just a few minutes. And of course, there's also going to be music. AI music, surprise, surprise. And we're going to do a little experiment. For those of you that don't know, LJ is an amazing pianist and vocalist. She can actually play 2 different songs at the same time with her left hand and right hand. I'm going to modestly try and play drums along with her. And we're also going to have an AI DJ. His name is CJ.
Oh, and Zach.
And Zach. And there might be some robots on stage trying to jam with us. What could go wrong?
It's probably going to be better than the dancing I just displayed, let's be honest.
Oh, that was amazing. OK, last but not least, I know you're all thirsty. So I want to thank the AI for Good superheroes. So all of the ITU staff who helped with AI for Good, I'd like to invite you all up on stage for a group photo. Doreen, Anoe-san, Selena, Bilal, Senya. There's too many to name. Please come up here.
Fred, would you like to display the slide? Is there a slide? Is there a slide that you want to display?
No? Okay.
Okay.
Oh, yeah.
Oh, yes. Yeah. All right, as the team come onto the stage, I'm just going to extend a huge thank you to the speakers, sponsors, the organizing team at the ITU. They're still coming. The phenomenal production, AV and backstage. My goodness, you're amazing. Our lovely volunteers, exhibitors, and you, the audience, for your generosity, your time, and your attention. And I'd like to invite you all back to the 2025 AI for Good Summit next year. We think it's in July, but we'll keep an eye out and let you know the exact date. So, are we all ready for the, oh my goodness, it's getting bigger. We need a bigger stage. That's a good thing.
Wow, I didn't know we had such a big team. This is amazing.
OK, we need a few rows. Can the short people come out to the front, please?
Thomas?
It's definitely me. All right, I'm going to come down here. Where should I come down? So, pictures? We could have some music.
Thumbs up, everyone.
Oh, let's stand up for a bit.
All right.
And can I encourage you to make your most expansive gestures? Ready? Steady. Oh, hang on. We've missed some people. Come on up, our extra people. Maybe. Yes. This is most of the audience. No, we might have to do a sensible one, everyone, before the silly one, so that everyone's in the sensible one and the silly one.
Gabriela's been part of the AI for Good family since the very beginning, so we need to get you a T-shirt. Yeah.
And thank you, audience, for indulging us. We've done this every year for quite some time. Can I also say with the farewell reception, we're all going to be there. It'll be a pleasure to meet you all. I can't wait. And now a live change. The action hero. Great work. Wow. You're not in there. Oh, I'm sorry about that. All right, so I think we're clear.
All right.
Woo. Crazy picture.
Okay. All right, so free drinks, and we'll see you next year in June. Bye-bye.
Thank you very much. Oh, congratulations. Oh, well done.
Thanks so much, Doreen. Thank you so much.
Together forever. Together forever. Today you tell me, pasta recipe, you got me, but can you cook for me? Can you see me? You tell me a joke, can you hear me laugh? I tell you when I'm sad. Do you understand? You're there when I need you, can you hold my hand? Let's play, find out together and stay in a place where we love, we care. Share is how it should be. Ethically, let's play, thinking together and stay in a world that we love, we care. One day we'll share. It's how it should be. Ethically. You tell me, or will it rain today? You tell me, pasta recipe, you got me. Can you cook for me? Can you see me? You tell me a joke, can you hear me laugh? I tell you when I'm sad. Do you understand? And you're there when I need you, can you hold my hand? Let's play, find out together and stay in a place